So you have a web app. Maybe it's even a good one, a rare sight these days. Why do you suddenly need to know about virtual networks, identity policies, load balancers, and like 40 other AWS services just to get it live on the internet? Sure, you could slap it up on a managed hosting solution like Vercel, but in this course, our goal is to learn how medium, large, and even enterprise software companies manage custom cloud accounts, where they need a lot more control, flexibility, and cost efficiency than what they can get from a managed solution. Zach Gates is a senior cloud infrastructure and DevOps consultant who's worked across AWS, Azure, and Google Cloud, and he designed this course to teach you AWS the way developers actually need to learn it, by deploying real infrastructure in a real AWS account.
I'm gonna delete this account before this video is published, so all you good folks that would like to borrow this account, I'm sorry.
In this course, you won't just memorize which acronym matches which product page in the web console. You're going to build a small but surprisingly complete cloud stack. And BootDev's interactive CLI tool will check the actual resources in your account as you go. But before I drop you into the web console, which has enough menus to qualify as its own operating system, let me give you an overview of all the things you're going to learn about in this course. You'll be working on Patient Ping, a fictional healthcare app that sends appointment reminders to patients. It starts out as a simple Python web server, and step by step, you're going to deploy it on all the cloud infrastructure it would need in the real world. We're going to start with the cloud itself. Zach's going to talk about what you're actually renting, why a company might choose the cloud instead of buying physical servers, and how AWS divides the planet into regions and availability zones, and even how pricing works. You'll install the AWS CLI and create and secure your own AWS account. Then we'll build Patient Ping's network stack from scratch. You'll create a VPC, split it into public and private subnets across 2 availability zones, attach an internet gateway, and configure route tables. This is what devs tend to skip when they first learn about AWS, but without it, nothing we deploy later will have a sensible place to live. Understanding this kind of stuff is what separates actual DevOps engineers from web devs that only know how to do one-click deploys on GitHub pages. Once the network is ready, we'll launch an EC2 server, which is AWS's name for a virtual machine. You'll configure SSH keys, public and elastic IP addresses and security groups, then SSH into the server and actually deploy Patient Ping. You'll even turn that configured server into an image and launch template so you can understand how to create consistent copies of your infrastructure instead of rebuilding every machine by hand. After that, Patient Ping needs somewhere to store its data. You'll deploy Postgres on RDS inside the private part of your network stack, connect it to the app without exposing the database to the public internet, and learn how managed storage, backups, snapshots, and read replicas work. You'll even watch the app start generating appointment reminders once the database connection is live. Then Zach is gonna get into IAM, which is AWS's identity and permissions system, and easily one of the most important parts of the platform. You'll create users, groups, roles, and policies, see how explicit denies work, and give the Patient Ping server permission to read its own configuration from SSM parameter store. This is the stuff you need to know about so that you won't be tempted to commit your API key to your Git repo. From there, we'll make the app observable with CloudWatch. You'll collect CPU and memory metrics, ship application logs, build a dashboard, deliberately spike the server's CPU, and configure an alarm that can email you through SNS. Then we'll cover the services that get your app and its assets in front of actual users. You'll create private DNS records with Route 53, upload images to S3, and put CloudFront in front of all of it so you can learn how object storage, CDNs, and pre-signed URLs all fit together. And finally, I know this is a long course, we'll move beyond a single virtual machine. You'll package an app into a Docker image, push it to ECR, run it on ECS with Fargate, and put an application load balancer in front of it. You'll even build a separate serverless endpoint with Lambda and API gateway. By the end, you'll have used most of the AWS building blocks that backend and DevOps engineers use day to day. Now, an important note before you start. This course uses a real AWS account, so some resources can cost money if you leave them running. That said, everything we cover at the time of the recording can fit within the AWS free tier. So if you have access to that, you can do it at no cost. Even if you're not free tier eligible, the whole course should cost far less than even just $10 if you complete it within a few weeks. Zach calls out the paid resources as you go and also mentions every time you're safe to delete something. So you never need to leave it running longer than needed. So Basically, just don't skip the cleanup lessons. Amazon will happily keep your load balancer alive forever if you want to keep paying for it. I also don't recommend watching this course passively in one sitting. Go actually make an account on boot.dev. Get your hands on the AWS console and CLI and work ahead of Zach. Configure each resource yourself, then watch his approach and compare it with yours. Cloud infrastructure only starts making sense once you've actually connected all the pieces and sometimes even broken a few of them. And as always, all the content in this YouTube video and all the course content on boot.dev is totally free. The interactive features are paid though, so if you want to submit assignments and have our tests inspect your AWS resources, track your progress, chat with Boots, or earn a certificate of completion, you will need a membership for that. And if you do want a membership, use Zach's code, ZachGates, for 25% off your first year of all boot.dev courses on an annual plan. Part of your payment will go directly to Zach to support him and his content. This AWS course is just one part of our full DevOps learning path, so be sure to check that out if you're really looking to level up your infrastructure skills. And one last thing, courses like this take a ton of time and resources to produce. We spent over a full year of time spread across about 6 different people to put this together. So if you want us to keep releasing these long form walkthroughs for free, please like this video and subscribe to our YouTube channel. It only takes a second, it's totally free, and it helps us make more of them. So thanks in advance for doing that. Now, let's learn about AWS with Zach.
Hi, my name is Zach Gates, and welcome to the Boot Dev DevOps course for AWS. We're going to be walking through practical AWS knowledge here today, of walking through the course from end to end, hearing my unfiltered terrible thoughts as I'm trying to struggle through the course right along you. And whether if you want to just listen to this thing and see the content, or if you are working through the course yourself, I hope that this is beneficial to you, that you learn something and that you become a better engineer through this thing. So let's jump into it. I'm going to go ahead and log in here, and you can see we get to the main dashboard. We're going to go to courses, and we're going to go to the AWS course here. And look at that handsome individual that's ready to go. Let's start the course, and we're ready to start. So the first thing we have to do is what are the goals going on here? Why are we here? Why take this course and not the literal 7,000 other AWS or cloud or system tests that are out there? And the goal is, one, cloud computing is pretty ubiquitous. Whether you use AWS or Azure or GCP or a lot of these different providers, there's reasons that people are going to the cloud, and there's a big expectation in the market that if you have these skills and another candidate doesn't, that you have a leg up. If you have this tool in your toolbox as a developer, it gives you the ability to deploy tools and to be able to get things done quickly. And that's the hope, that we introduce some useful components of the cloud and why it's there, when to use it and when not to use it. So we're going to understand some of the major offerings. We're going to understand why you do this instead of on-premises infrastructure. And we're going to do hands-on experience. We're going to walk through. I'm going to be fighting through this Amazon CLI or the web unit interface right along with you. You're going to see me doing the exact same things. And we're also going to be talking about the AWS CLI, right? Say, hey, this is intimidating. What do I do with this? Is this a useful thing? Do I have to learn this? Do I have to learn everything within it? And we're going to talk about this CLI tool, which really lets you set yourself apart and be an effective AWS operator, right? CLIs in general unlock a great ability to get stuff done at scale when clicking around or going through that is untenable or just simply annoying, right? So you're going to see me using it. You're going to see it within the courses, and that's one of the focuses that we brought in here. So let's talk about what we need. For a Windows user, you're going to need some kind of bash or real ZSH kind of session. You can see I'm running over here just a quick little Debian box that I have sitting on my desk here. You can run WSL as well and get real Linux, and you're going to want that to be able to run the CLI commands and some of our text interactions that we're going to be doing. We're going to need the boot dev CLI. Let's make sure we got that up and running. Version. And I've already got it installed. If you don't, go knock that thing out. That's super quick and easy. And then there's also a boot dev login command that I know is there. And it gives you a little code. So you click the link, you refresh the page, paste in said code, and you're in. All right. So we've got that done. The run submit, right? How are you firing this? So we're just going to go ahead and submit this lesson, and we're going to keep going. We're going to talk a little bit about Docker as well too. Let's make sure I've got Docker on this machine. Yep, we are all set. So I just did a PS there, right? Like, hey, show me what's going on. And I think we're good. So I'm gonna copy this guy. We're gonna come back over here. We're gonna paste. And we have successfully finished our first lesson here. Let's go to lesson 2. And you can see I even refreshed my account for you guys so you get all the beautiful confetti and flare and celebration that you see. So let's keep going. What is the cloud, right? Why did people build the cloud? Why are people using it, right? And the reason is, purchasing hardware is fun and all, but at a certain point, it's less fun, right? If you want to have an application or a piece of software or a utility that's available to folks all the time, do you have a laptop? Is a laptop good enough? Do you have to go buy a desktop and sit that somewhere? Do you need special equipment? Do you need to have dedicated power supplies or multiple power supplies? Do you need hardware RAID so if a disk dies that you can replace it? And cloud is a response to how do you deal with some of these hosting or these kind of self-operating methods, right? So purchasing the hardware, right? Do you have to buy hardware for 5 years at a time and expense it out? Or having something else? Is there a different way to get that done? Do you have to pay people to show up and swap hard drives? And the first kind of step in this journey was this idea of virtualization, right? Where instead of buying, you want 10 servers up and running. Instead of running or going out and buying 10 servers, you can buy one large piece of equipment and then subdivide that into smaller virtual servers, right? So you pay for one server, and oftentimes that's cheaper than buying all the individual ones, or certainly smaller than buying each individual one. And then you can subdivide it up. So this happened in a lot of, you're gonna hear things like Citrix or VMware or lots of different hypervisor or virtualization providers out there. And so what the cloud was the next step in that, saying, okay, instead of, we've already kind of subdivided and we're working on these fake servers or these virtualized servers, what if instead of me having one large server that's sitting in a shoebox or sitting in a server closet somewhere, what if I had a server that was available to me and ran in a data center somewhere? And maybe I don't even own that data center. And that was kind of the key idea about this. So we're going to talk more about this. Let's go to the next lesson here. But we're going to say the cloud is something that immediately 100x. No, having where your server run doesn't honestly matter unless it's giving you something that's unlocking. You don't really care where the thing is happening as long as it's happy and snappy and working. Is it idempotent container driven? No, it's none of those things. You can build some of these fancy things on it, but just having it, you can build terrible things on Amazon just like you can build terrible things in your own data center. Is it a collection of servers that you rent, right? You're paying month to month and that you access off the internet? Yeah, that's what it is. All right, let's keep going. The CLI. All right, AWS is one of the big 3 providers, right? We talk about GCP, Azure, Oracle. There's a blue cloud out there, right? There's many other ones. But one of the things that I try to highlight is that these concepts are reusable. In my professional life, I work on GCP, I work on Azure environments, and the concepts I learned first with AWS, and those terms were repeatable and reusable for me regardless of which cloud provider that I'm working on. But we've got to choose one, so I chose the one that's most likely to be at your company or the one that's most likely on that job opportunity, and so that's what we're going to run with. So it's the oldest, it's the biggest, right? And the CLI, we talked about this a little bit too, right? How do you access, how do you interact with AWS APIs and get stuff done? Right, we talked about no Windows, that's all fine and dandy, Linux, and then we've got to check to see if we've got AWS CLI installed. And we need something in the 2 versions. So let's see if we got it. So I got that, drop that over here. We got 2.34. You might be on something newer, but as long as you're 2. Or we're gonna have to come back and update some of this course stuff, and you should be good to go. All right, let's grab this. We're gonna run the command. Boom, bada boom. All right, let's keep going. All right, we're gonna need an AWS account, right? And there's a few things to know about this, right? This is one of the big kind of anxiety-inducing components of running in the cloud, right? You've probably read an article or 2 about someone who lost control of their account or someone that ended up spending a lot of money that they didn't intend on doing. And being able to grapple, right? It's a nice thing to be able to rent servers and to pay as you go, but there is a silver lining. There's another component to that you have to be aware of, that we know when we are spending money. We are aware of how to turn those things back off, and and to be able to grok not only what we are building, but how much it's going to cost us to be able to operate and maintain that thing. One of the things you're going to see in basically all the lessons that have important aspects to it is a cost check, right? That we say, hey, you're spending money doing X, and you're going to see a lot of cleanup lessons. We're saying, hey, we're done with this. But I really want to emphasize, if you're planning on doing this course over a long period of time, try to get to one of those sections where you can tear down some of those materials before you move off. AWS offers a free account that we talk about here, a free tier on many of their services. You may or may not be eligible for this based off of other accounts that you have or where you live, but we're going to try to stay under, right, that $1 billing amount on AWS. We're going to be trying to moving along a quick clip. I'm paying for my own AWS account here right along with you, and I don't want to waste money. Bezos has enough, right? I want to keep some of it and do things with it. All right, so we're going to create an account, and I do have an account, so I'm going to just talk through a few of these things, but we'll work through it. So when you first create an account, and there's some steps for here on how to get in there, you're going to be granted something called a root account. This is like the God mode account of the AWS environment. It lets you do anything and everything, change billing, identify who the contacts, who should Amazon call for security issues and stuff like that. But you shouldn't be using root for your normal stuff, right? There's a reason sudo exists and that we don't just switch to root all the time. And the reason is you can break things. You can do things that you don't intend doing, and some of those safeguards are not there. And so what we generally do with the root account is we're going to jump in and we're going to create a user for us. We're going to create an account that's meant for our daily kind of operation and follow that best practices. And we can do some of the protections of that, like multi-factor authentication, and we can scope the permissions down to things that we should be doing. So let's come through here. So we have an account. I've done this, so I'm just going to keep cruising through this. If you haven't, go pause. You need an AWS account before you can keep going. We're going to log in as the root user. I've already done this, but I'll show you here. So I'm logged in, and if you don't know what user you're logged into, you can come over here and click this button, and it will show you. I'm going to delete this account before this video is published, so all you good folks that would like to borrow this account, I'm sorry. But you can see here I'm logged in, and you can see the account ID, and you can see what you're logged in as. And this will say root, or this will tell you which user that's logged in here. So we're okay there. Create an admin level IAM user. All right, so we need to go to the IAM dashboard and start chewing through this. So let's do that. So I'm not going to use the quick keys just in case you guys don't have access to it, but I'm going to jump over here, and this search bar is your best friend. I don't bother with any other way of navigating AWS at this point. So I came to IAM, the Identity and Access Manager, and I'm going to come to IAM users. You can see I've got a Zach admin user here created, pre-baked, but I'm going to just delete him. We don't need him. We don't need this thing, and we'll walk through creating this ourselves. Nothing hidden up my sleeve. That guy's gone. Let's create. So I'm going to create a Zach admin user, and I don't need a management console credential. That should all be fine. And it's going to want us to create this group as well too. So I'm going to go ahead and just skip this for now. He's not going to be attached to any groups. And we're going to create the user. All right, so Zach admin is back. He's not in any groups. And then we have to create an IAM user group for him. But let's go back to our steps here. So navigate, click on users, Zach admin, provide access. This lets you do a username and password. I'm not going to be using that, but you can also set up username and password. It lets you log in through the normal method. It's all fine and dandy. Auto-generate, that's fine. And we need to create a group for this user and attach, call them administrators, and we have to attach a policy to it. All right, let's come over here. We have a section later that's going to talk specifically through some of this. I'm just going to delete it. This is the old one that I pre-baked here. And I'm going to create a group, administrators. And I'm going to say, hey, Zach admin should be a part of it. And I'm going to attach a policy. Now, policies are the things that actually give permission. And I'm going to give anyone who's in this group administrative access. So that all seems good. Boom, boom. And if I jump back to my user and refresh this, you can see that group count went to 1. And if I click on the user, you can actually see which groups I'm in. And you can see it all resolved. It all figured itself out. So boom, create that, assign the user, we did that, review and create. We download the credentials. This will have that username and password in it. I don't need it. But what I am gonna do is I'm gonna create some API credentials for myself because that'll be how I interact with it. So you do that by coming to IAM users, clicking on the username, security credentials, and then I'm gonna create some access keys. And I'm just going to come and click Other here. And this is going to let me download these API keys. Boom. And I can copy and paste them. So let's do this. You're going to learn with me exactly how to do this. I'm not super familiar with this tool. So I think I do granted credentials. Add. I'm going to create a boot dev. Let's remove it first. Okay. Get rid of the old one. Yeah, that's fine. So you can see here, I'm using this tool called AWS Vault. This is the one I'm more familiar with. So I'm going to paste in my access key. Boop. And I'm going to paste in my secret key. Boom. Okay, so now I'm going to see if it lets me use it. Exec, BD, session. Boom. Oh, I have two running. Beautiful. Now let's see if it works. So if I just do, this is just a command, partial keys found, missing secret. So let's see, maybe grep AWS. That seems something like a unset AWS access key ID. Let's see that. Well, this is the part of the show where you get to see how I try to make this thing actually happen. So let's do AWS Vault, login, BD. And it's there. So let's do AWS Vault, add BD. Okay. And if I come back to my thing, it's got my access key. Okay. AWS Vault, exec, BD, AWS S3 LS. Okay, that took. So now I think it's because I set it up while I was in a subshell there, if you really care. But hopefully you don't have to do this. So if this is working, I should be able to do this. And this get caller identity basically says, hey, Amazon, I'm logging in as someone, please give me my information back. And you can see because I'm using those keys that I inserted, it identified me as saying, hey, you are that Zach admin user that we just created. That's the end goal. All right, let's keep going. Download CSV. In the web console, make sure you log out of the root user. So if I jump back to here, you can see I'm not the root user, so that should be okay. Okay, be prompted. I'm not going to set up MFA here because I'm using those keys, but that was in that security section. I'll show you where it is. So you come down here to security credentials, MFA, you say assign an MFA device, you put in some content here, and then you choose what you have. When you click next, it gives you that QR code that you can scan or you can grab the key. I always grab the key and put it in some kind of password manager because it lets you regenerate or associate a new token management service if you ever want to. And you add in the MFA codes and you're ready to go. I'm going to cancel that. You guys should do that. Do as I say, not as I do, at least in this case. All right, go back to your terminal. We did our login. We've already done that because we're getting calls. We did this get caller identity, so that's all good. And let's see if this works. So we're gonna grab you, and we're gonna see now Zach forgot something. And we're good to go. All right, let's go to next. Why should I use the cloud, right? So there's a famous thing where DHH famously moved his, was it Hey or one of his big applications off of cloud hosting services and onto bare metal servers and was really successful in cutting his costs and being able to operate well all while doing so. So don't hear from this course and don't take into your workplace or into your world that cloud is absolutely the answer to every possible solution. It will always save you money. What cloud gives you is a few things, right? It's going to make things scalable. If you are a small shop, you are working on some proof of concept of a project that may or may not work. Most software projects are going to fail. And so do you spend that money up front before you know if this thing is going to work out or not? Or do you pay for just what you need and then have the option to basically turn up the lever to be able to increase the resources when you need to do that? And that scalability, the ability to create a whole bunch of servers when you need it and not pay for it beforehand, is a real reason why you should consider this as potentially the best option that you have. But if you're really big, if your demand is super stable, if you know exactly what your server needs are going to be in a few years, then buying and running hardware is a time-honored practice, right? And people are doing it every day successfully. OpEx versus CapEx, right? OpEx is like, hey, how much does it cost to operate versus how much do you want to capitalize expense? Do you want to expense it over a long period of time, right? Are you buying a candy bar or are you buying a house, kind of like conversation? Reliability, right? As good as your electrical grid is, right? I was in Texas for a long time and we famously destroyed our electrical grid for a while, right? Where we did not have stable electricity and you could not go buy it unless you went and bought a generator to go do it. Cloud providers are going to have those diesel generators inside their cloud data centers that will pick up regardless of whatever the grid is doing. Off-the-shelf products, right? This is the other kind of interesting thing, is that the cloud provider is more than just a VPS provider or a colo, right? They are providing software solutions in addition to that server, that raw compute, the graphics cards that you could rent from them. And so using things like S3 or Lambda or CloudFront that are natively integrated into these cloud resources that we're provisioning is kind of a big reason you go to a cloud provider. The cons, right? You can get locked in. If you start drinking the Kool-Aid too much, right? You can design your infrastructure in such a way that you cannot leave, right? That's bad if your relationship with a specific vendor goes sour. That's hard because like, what is the knowledge that I'm building within my own kind of career trajectory? Is it transferable or is it super narrow and niche? Right? It's important to build skills and to kind of keep this in mind as you're kind of building your architect, as you're building a team, and as you're building the skills within yourself. Cost, right? Sometimes you can save money by just going to Hetzner and getting a really cheap server or grabbing it like just I do, a very cheap mini server, pop it on your desk, and you've got ready Linux machines that cost near nothing to run. Complexity. There's a lot of terms you're going to hear here. You're taking a course probably because you don't know what's going there and it seems complicated or is complicated and you're in there and you are here to kind of help solve that. It's true. Security, right? There's two sides of this argument, right? There's the bank vault is probably going to be more secure than stuffing money in your mattress or hiding it in your backyard. But at the same time, it's really easy in AWS to leave the back door open, to unintentionally, if you're not thinking about it, make problems for yourself or expose or have a lot of surface area that you have to go protect. So lots of pros, lots of cons. Let's answer to Boots' question here. So why might cloud infrastructure be better? Scalability reasons. If we want to start small and then grow over time. And I'll say reliability. We'll give Boots two reasons. If we don't have stable internet or network capacity by default. See what I said? Did we get it right? Boom! First try. Easy. Easy. Let's keep going. Regions and availability. All right, so what are these? Are these the same thing? Are they different? How different are they? And it comes down to this, right? A region is a geographical area, right? It's things like Virginia or Eastern Europe. Yeah. There's lots of different ones, but it is distinct, it is completely different, and information inside your network that's going from one region to the other region almost treats it as if it was from a completely different network. Versus an availability zone, right? So you can see inside US East 1 here, there are identical copies of resources within it. And what this represents is a different data center essentially on the same campus. So if you go drive through one big data center, you might see one large warehouse on the left, another large warehouse on the right. And this essentially be saying, hey, we have our own generators, we have our own internet connectivity, we have our own fiber drops, and everything is geographically not too separated, but is separated. So if that power outage goes down, or if this facility has issues, or if the sprinklers go off, which I don't want to talk about that, then it's not going to affect what's running in this one. And it all comes down to how important is for your applications and for your suite of utilities to be up and running at all times. Is it okay for Amazon to go down for a few minutes, or is it really important for it to stay up at all times? If you're running mom and pop lawn mowing service, you might not need to be running in multiple availability zones. But if you're running something where this is critical for your business's success, the demos have to be running right while this presentation is going on, you may want to be splitting things out. Do you have users inside the US as well as in Europe? It might be nice to have applications really close to where those users actually operate. And we're going to talk about that a bit later, so I'm not going to talk too much about it, but let's keep going. All right, so we talked about that. This is another important thing, is that even though that these facilities are really close to each other, you still have to pay a toll when you're transferring in, right? And it seems a little ridiculous, but it's true, right? You have to be cognizant of where the cost measures are. AWS is one of the biggest expenses that you'll see if you're a web company using AWS is your bandwidth charge. Not your compute, not the utilities that you're using, but how much data did you send in or send out of that network? And so being cognizant of when you are paying the toll man, when you're hitting a toll booth, right, versus when that data doesn't cost you anything to send in or out is really important. If you don't need multiple availability zones, don't use them, right? You will be wasting money. You pay for the things that you need for your application. We're going to be using US East 1. Let's do this. Oh, that's kind of interesting. So let's jump over here. We're going to fire this. Oh, that was the old command, if I didn't actually copy it for real. That format. I really hate the table. I would just switch this to Jason. Oh, that's funny. So you can see here, India, Sweden, France, UK. There's a lot of opt-in regions here, Ireland, Japan, South Korea, Canada. There's a whole lot of regions in here. And there's a bunch of the US ones there at the end. There's also government regions. I think China has its own kind of regions that can operate that kind of have special permissions that state agencies or governments need for their networks that you can't get in the normal kind of commercial grade or some of the assurances that they require. Availability zones, you'll see that. Fun thing about availability zones is that depending on how you're looking at it, your availability zone 1A will be different than someone else's 1A, right? AWS wants different companies to be in different availability zones so that they don't have to have one really big availability zone and a bunch of small ones. And so they shuffle it. There's ways to tell which one you're truly on, right, if you're working between companies. But just know that your 1A might be different than someone else's 1A. We're going to set a region. Let's go ahead and go do that. Beautiful. And let's get the region. Beautiful. Let's YOLO our way through here. Oh, I did it wrong. Copy, please. Come on, Boots. Do me right, Boots. All right, we got the region. We are good to go. Cost of this course. Oh, so this time we say $10, right? And that's probably a little bit more realistic. We do spin up some load balancers, some RDS, some Lambdas. So this is probably a good kind of threshold for it. And talking about the free tier component. Yep, we're gonna try to be clear. Be careful, all right? And this is really one of those skills that you have to learn by exercising this muscle, right? You have to be cost conscious of when you're clicking around, when you're provisioning things, and it's a required component to operating in AWS. So we've constrained down to probably just the things that you should care about, but just know, before you start that big project, go look at the cost page. Go check to see if those services are available in the region. See if they're costing different depending on the region. How does traffic get in and out, right? Are you going to be paying for that bandwidth? And we'll be talking about it when we get into specific areas, but it's an important thing. We're going to be trying to build those muscles in you as part of this course. All right, it's the most cost effective and requires the least rework to complete this course, whichever one's shorter. Yeah, it's going to be this one. Keep going. All right, so we got a VPC. Let's keep going. VPC is the network. It is the top level network object. Now you don't set necessarily the subnets, but you kind of set the box that all of your subnets are going to be within. Once upon a time, this wasn't something that you could change after the fact. But today, you can add new ranges of addresses onto things so that you don't have to have everything figured out on day zero when you're logging into your AWS account. So you can see here that generally lots of people use VPCs to split up different life cycles of their application, right? Dev, prod, testing, stage, right? Depending on how many that you need for your workflow. Sometimes companies will spin up entire new AWS accounts so that it's really clear where the dev starts and where the production resources end up. Sometimes that's not feasible. Sometimes you need to pull a lot of data out of your production system, sanitize it, and then send it to your dev system to be able to test and be able to work effectively. And so there's lots of different reasons. Yours are going to vary. We'll talk a little bit about this in our designs, but let's keep going. Basically, we're going to follow kind of this two-tier. We're going to have a prod VPC within the same account as our development VPC, and then we kind of mix and match and kind of see what it looks like to operate with multiple VPCs. All right, so it says, choosing the number of addresses is important. Aim for a little bit more than you need. Don't use all the addresses that exist in all the private IP addressing. We had a big issue where we had different departments that consumed all of what's called RFC 1918 space for each one of the departments, which made it nightmarish to get things to talk to each other and interconnect with one another. Be reasonable. You can add them later now, so you can start small. All right, and we get introduced to our company here that we're going to be running, Patient Ping, which is good. We are going to be a patient management application for local doctors and dentists. Good. And hopefully developing some patients within ourselves. No cost with VPCs, so that's good. So we're going to create some VPCs. So in here, we'll go to Virginia, go to VPC, and click on the VPC menu, and then click Create. So let's knock out a few of these. So back to the top, VPC, your VPCs, create VPC, and here we go. All right, what does it want us to name it? It wants us to call it Patient Ping with 10.00022. Okay, Patient Ping, what is it called? Patient Ping, and it was 10/22. Beautiful, this is fine, and it's glued that name. All that happens when you add this thing on here is it writes a tag for you called name and writes it here. So we'll create this, go back here, and we'll go back to our VPC and make sure it's there. So if I go to your VPCs, get the giant list, there it is. And there's the default one. Whenever you spin up an account, and regardless of which region that you're in, this is a fresh AWS account here. You'll see that there's always one VPC that AWS helpfully creates for you, and it's called the default VPC. Generally, what I try to do in my accounts is I delete the default VPC just because you probably shouldn't be doing it. If you're using that, it probably was a mistake and you're just accepting all the defaults for all the networking primitives for your entire AWS account. It's a bad idea. Do your stuff on purpose. Don't use the default VPC. Let me go back to Virginia here before I forget that. You gotta log back in. Let's go do that. We're back. Beautiful. Click that. And this is going to describe the VPCs here, and it's going to fire. So I'm pretty confident we got this right. Let's just go for it. Beautiful. All right, next lesson. CIDR blocks. God bless CIDR blocks, right? How do they work? CIDR size. I always call it CIDR. Lane might have other ways of pronouncing it that are wrong, but you pay attention to me. All right, CIDR blocks. Let's walk through this. So CIDR blocks, and regardless of how you say, designates how many addresses are available in your VPC, right? You saw we did it there. And when we start dividing it up again, it'll choose how many addresses are in each of our subnets. So this isn't a networking course, but I'm going to give you a few kind of rules of thumb for how to operate here. And the big thing is counting by eights. So if you have a CIDR address with a /32, you can see that right here at the end of it. This means that you have specified each of these octets, and that this only includes one address total. If you go down by 8, right, these are octets, then you allow basically any number to exist in this furthest right section, and then these numbers are fixed. So a 32, right, so 32 is all of them, and if you minus by 8, you get 24, right? So if I did 10.20.30.0/24, that would include all addresses from 0 to 255 here. If you subtract 8 more from 24, you get 16, and these two would be locked, and these two could be anything from 0 to 255, right? And you get kind of growing numbers, exponentially growing numbers by increasing the number of octets that you allow or don't lock. It's related to net masking. We've got a video that I'll talk about a little bit more of CIDR blocks, how they operate, and some more explanation. So jump into it if you want it, but usually the rule of 8s is going to be done. And no, the other critical thing is that making the number smaller increases the number of IPs that are in that block. Essentially, every time that you move the number up or down, you either have it or you double the number of IP addresses that you had to work with previous. Oh, and you see that here. So here's the 32, 1, and the number of addresses 1. Here's the 24, here's the 16, here's the 8. And here's my quip about IPv6, which is a different way of basically accomplishing the same thing, but having way more addresses. This ebbs and flows in its popularity and kind of common networking. You don't need to worry about it for this course. All right, so which of these CIDR blocks? So that's going to be the number where the CIDR is the smallest. So 32 to 8, obviously 8 is the smallest, and so it's going to have the most number of unlocked addresses in this grouping. Great, let's keep going. CIDR blocks number 2. In the 15.255.0.16, what does this represent? And so this represents the starting point of where that block starts, right? This tells you how big it is, basically how many addresses are we including, how many of those 32 bits that we've locked down, and basically 16 of them are going to be open, half of them are going to be open, and half of them are going to be available. So is it the number of bits used? No, that would be the CIDR. Is it the number of addresses defined? No. Is it the last address? No. Is it the first address? Yes. That's what we want. Subnetting. All right. So we have one big box. We talked about region decisions, right? Which are pinned to a VPC, right? A VPC can only live in one region. But what if you wanted to operate in 2 of those local campuses and have distinguished and safe things, right? Even if this one goes offline, this one will stay alive in Virginia. And that's where we do subnetting, right? We can split up groups of our network to do different things. And this might be done to split between those 2 different campuses. And another big thing that you might do is you might have one subnet that talks to the internet and one subnet that's more protected from the internet. So let's kind of walk through this. So we need to divide it smaller. We talk about public and private. Yeah, that makes sense. Is in an availability zone, right? So sometimes you'll have 2 public networks, you'll have 2 public subnets, 2 private subnets, and you'll use availability zones to distinguish between both of those things. Let's keep going. So we say how we're going to split up. All right, so you can see, and we're using that CIDR block notation. So we used a /22, and basically we've made the number 2 larger. These are smaller chunks of the network, and we basically split that 22 into 4 different chunks. And you can see what we're supposed to do. Ping A, it gets 0. B, that goes up by 1. And that goes into a different availability. And then we've got the 2 public ones here as well too. So this will end up with 256 addresses. And the beautiful thing is that this doesn't cost a thing. So let's go knock this out. All right, so go back to VPC. On the left, I'll click subnets there. And I've got some, let's destroy all these. Let's see if there's anything in here. I think these are some from when I was doing my practice session. Now, you can see, no subnets here. Let's go ahead and create our subnets, and we have to create 4 of these things. So let's choose our patient ping, and that's where there's some name tags, so we don't have to remember some random ID. And it's definitely not that default one. Don't use that. All right, we need a subnet for name 1. So let's come here, and it looks like it's gonna want this as the name. Copy that, paste that over here. I'm gonna stick this in A, and it wants a CIDR block. Okay, so this is the CIDR block of the VPC, basically the thing that contains our subnets. And we want all O's 24. There's 4 octets, right? And we want a /24. 256 addresses. And you notice it only knows the number of addresses after you've added that CIDR notation, right? This tells it where it starts and this tells it where it goes to. And each time I increment that number 1, right, you see it's getting smaller and smaller each time. And each time I get bigger, right, 256 to 23, 512, 1024, right? You'll see that it's increasing the amount by double each time. /24, we have that, and I'm just gonna copy this for myself. Oh, we can actually add them all here. Beautiful. Boom, let's go B. Let's change this to 10.0.1.0/24, and we'll add another one, and we'll say paste that. We're gonna make this public, call this A. And I made a mistake here. If you guys caught it, you are smarter than I am, but I'm gonna definitely remember and not forget that I made that mistake. So there's public B, this should go in B. This should be our 4th one, so it should be 10.0.3.0/24. I think I got it. All right, let me check the names. Public B goes to B, public A goes to A, private B. Oh, maybe I did get it right. Private A. Look at that. Look at that, Zach. All right, let's save that off. All right, I've got some subnets here and some terrible formatting here from our friends at AWS. All right, got that. Got my 4 subnets. Let's see if I got it right in the order, though. And there's our CIDRs there. So let's start by CIDR. So it should go private, 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 public, public. Private, private, public, public. I got it right. All right, let's check all that off. Return to subnets. Let's run the test thing. Let's see if I definitely got this order right or if I'm doing terrible things. So over here, let's clear this off. Let's fire this. And I'm gonna make this a little bit bigger. It just occurred to me that this might be small for you guys to read. That looks positive. How do I make it bigger? There we go. All right, there's a little bigger for you guys. So let's run the real thing. Oh, I got something wrong. All right. So patient ping private B, JQ should have US East 1B. So I got that wrong. So here's private B in the availability zone for this guy. Jerk. See, I thought I did something wrong. All right, so let's delete this. Delete that. Delete that. I'm also going to copy this name. Thank you. Great. Boom. Click that. Paste. This should go into 1B. And this is the second one, so not the VPC, but this guy, 10.0.1.0/24. Create, jump back over here. Let's fire this again. Come on, come on. And first try. All right, let's keep going. What do we got after that? Internet gateways. All right, so great. We made a private network, we made public subnets, but really the only thing we've changed is like what address the thing starts at and what the name is, what availability zone that it should go into, and that's it. So we've got to actually do this. So right now we have this no internet access from our VPCs, right? There's a gap between them. And so what makes a subnet private or public? Well, does it have access to the internet? It's not really not that complicated, right? So our page-and-ping public networks need an internet gateway, which is basically like a giant extension cord that you can plug into a subnet, and it allows you to interact with internet connections, right? It lets you host outside of the network. And then you need a route, which is basically that tunnel that lets you connect from your servers to that point. So it's super easy. We're gonna jump into the VPC again. It's over here. We're gonna click Internet Gateways, and you can see I've got one created here. Let's get rid of him. I'm gonna detach it. I'm gonna delete this. Boom. All right, now I'm gonna create an internet gateway. What's I want it called? Patient ping internet gateway. Seems reasonable. Paste, go. All right, you can see that detached those. So I imagine we're gonna have to attach that to our VPC. And you'll notice that we're attaching it to the VPC itself. We haven't done anything with our private versus our public subnets. So basically we are connecting the internet to things within our VPC, but that route piece, that's where we're gonna get more specific. So let's choose this. Naming is good. And all right, we got that attached. And let's see. Click, click, click. Go back to the list of gateways and checking a box. And can attach internet gateway. Okay, it just wants us to attach it. Does it not want us to do the route right now? Oh, we don't have a route. Look at that. See, I'm reading my brain. So I guess it makes sense. So copy this. Let's run over here. Let's fire this thing. What do we get? What do we get? And we passed. Brilliant. Let's keep going. Here's the route table. So a route table is simply a map of available places that a server or things within a network are allowed to go. And so usually we're gonna put an internet route that says, hey, if you ask for something that's not local, right, not in the same network as you, try over here and you might be able to find it. And then on that route table, you'll also see our CIDRs, right? Those network blocks that we specified as part of the VPC or as part of the subnet. You're gonna see, if you ask for one of these blocks, hey, you've hit a private address. Stay here, don't go to the internet. And you actually can't, on AWS's side, force those private addresses to hit the internet without jumping through a lot of hoops. So let's add to this map that's available to our servers about this internet gateway to say, when you want to go to the internet, go here. So do that. It's a list of routes. And you can see here, we're going to actually split up our subnets. We're going to have private subnets that don't have access to go directly to the internet, and we're going to have public subnets. And why do you have this, right? If you had databases, if you had stuff that you're trying to keep segmented away from people that would do nefarious and terrible things with it, you try to keep that as far away, right, as least exposed, to have the least amount of surface area. And it's a lot easier to tell your database to say, only trust things that are coming from my private network as a kind of top level safeguard than it is to say, only trust things that have this credential and yes, definitely didn't steal one of our developers' laptops. All right, let's keep going. So we need to add it to our public ones, get the gateway, right? They have a route to the gateway, which then lets them hit the internet. So VPC and then route tables, VPC, route tables, and then from there, orange create route table button. Let's delete these. I wonder if it does let you. Boom. Can't be deleted. All right, I'll just create one. Create a route table, and I'm gonna call this, does it want a specific name? It does. Public route table, and I imagine there's a private one too. Let's stick to the script. Let's not create more work for ourselves. So here is the public route table. Let's create this. Notice that we haven't done anything, but now we have this routes. And so you can see the VPC's routes all got stuck on the route table by default, saying, if you ask for a private address, you're going here, right? You can't send this anywhere else. But what we want to do is we're going to come here, we're going to say edit routes. We're going to add a route, and we're going to add this route for this special route called 000/0, right? And remember, when that number gets smaller, it gets bigger. And so 0 is literally as small as you can get. And so it includes absolutely every IP address on the internet. And say, hey, if you ask for anything, and this is called the default route, and we're going to say, if you ask for anything that's not somewhere else on this list, you're going to go wherever we set here. Go to the internet gateway. Boom. And you can also do other things with this, right? So companies will use this to say, hey, I want to send all traffic through a proxy, or I want to send all traffic through a NAT or a firewall or things like that. And so you can do other things with your default route that can be helpful. If you're in a super secure network, you might actually send this to your security team to say, hey, if my servers ask for something that's not private that I'd expect them to be doing, don't let them, right? Send it to security, and then they get a phone call for doing something that they shouldn't be doing. All right, let's keep going. And if I can see the button, which I cannot. All right, did I get it? Boom, boom. So created successfully, that's good. And we can have this, but right now it's not associated, right? So you have this route table, and you can have a bajillion of these free route tables, but until you associate a subnet with them, it's not going to do a dang thing. So that's where this subnet associations come from. And you get to this by coming to this route tables button. You click on the route table that you care about. Here's my public route table that I just created. And you can see right here, there's our subnet associations. Click there. And I would like to add an association. Let's make this a little taller. That is a bit obnoxious. Let's go open this thing up. I think I'll be able to see it better. There, subnet associations. Okay. And this is our public one because we added the internet. So public A, public B. And notice that both of these ones, even though they're in different availability zones, right? B versus A, that they both still work. And boom. All right, let's go back to our list. So we went to the route table, actions. We selected both, edit the routes. We added our route. We added a default route. Internet gateway, we got that. We hit save changes. We have finally got this. All right, let's see if we pass the tests. First one out of the box says, boom, first try. All right, next guy, private subnets. A subnet becomes public by connecting it to the internet, to route table and internet gateway, but what about the private, right? And this is a hard thing to kind of grasp for some folks, right? It's like, okay, we don't want this thing on the internet. We don't want it directly talking to the internet, but we still want to do, updates, right? What if that server needs to reach out and talk to someone else, right? It's like we want to allow outbound traffic and like traffic that we want, but we don't want to just allow anyone in. This isn't a website that should only be used by us or by things that we need to go grab and pull back in. And that's what a private subnet's for. And the way that we accomplish that is we use this thing called a NAT gateway. Basically, it's a step that says, hey, I'm going to take all my private addresses, and when they ask for that 0/0, if they ask for some address that's not local, send them to the NAT. And the NAT does one thing. Basically, it puts your traffic into a little tiny box and it sends it using its own IP address and out to the internet, right? It lives in the public subnet, that NAT does. And when it receives the traffic from our private, it says, okay, I'm gonna put that in a little box. I'm gonna send it to the place that it's supposed to go. They're gonna respond to it, and the NAT unpacks that box and sends it back to the person that asked for them to do it. And that does two things, right? One, it gives you that clean flow of how do those private resources get to the internet. And number two, you can't come back. If someone were to come back from the internet and hit the address of our NAT, they don't know. When the NAT opens up that packet and says, hey, who's this for? There's not going to be one of our targets as the originator of that traffic. And so it keeps those resources safe and private. You watching this video are probably operating on a NAT right now. This might be from your ISP on the router or 100 different ways that this goes about doing it. But generally, the IP address that your phone or your device is using is not bidirectional, right? It's being simplified and kind of packaged up by a NAT somewhere along that chain. All right, this is one of the first kind of big cost points, right? And you can go find famous articles. There's reasons, right, why NATs are kind of the ugly stepchild for AWS. You can spend a ton of money, right? One, because the NAT itself costs money every hour, regardless of whether you're using it or not. And so we're going to try to tear down this thing basically as soon as we create it. And number two is that the NATs increase the cost per gig of traffic that go through it. So you're paying AWS for internet per gigabyte, and you're paying for NAT per gigabyte. And so you've uplifted your cost per gigabyte noticeably on all the traffic that's going through. So more information here, go look at this guy, go read his blog if you want to know more kind of fun tongue-in-cheek AWS stuff. All right, let's keep going. So we're gonna create our NAT. So go to the VPC dashboard, and there's a NAT gateway here. We're gonna create a NAT, and we need a name for it. Patient per route table. Oh, it wants a private route table as well too. All right, let's go create the route table right quick. Show route tables, create route table, paste that in. We want our VPC, not the default, and that should, yeah, that's fine. Got a private route table. Notice I don't have to add anything here, and we don't have anything to point our default route to till we have the NAT. So let's go grab our NAT. Okay, we just want to associate with the routes, this guy. So let's go subnets, and you see it's not attached to anything. We want both of our private, boom, boom, save. Beautiful. So now you can see this has both the private ones for the private route table, and our other one, here's our public route subnets, has both. All right, this is the private, private, private. Here's the public, public, public. All right, all's well, we've got it. Let's go to our next step. Okay, so I want to go here, and I'll paste that in. Did I get it? Boom. All right. Oh wait, what does it say? Return all tests passed, but also failed. No, I don't know what's going on here. Let me refresh my page here, maybe I got. All right, so I got this. Route table associations of 2. It's gonna ask for the number of routes here. Bool equals false on create routes. I don't know what happened. All right, let's keep going. All right, we're ready to start chewing through EC2 lessons here. So we've got our subnets created. We've got an internet route to our public subnets, but we need to put something in our public subnets. So let's start working on that. So the first thing we need to do, and we've got a few steps to set up before we can have our actual server up and running. And the first thing is keys. We need a way for us to unlock our server to be able to let our server know that we are allowed in and other people aren't allowed into that server, especially for something that's going over the internet. So we're going to be using a public and private key, basically a public key that we store on the server and a private key that we use to prove that we are who we say we are and can access it. And we're going to be using SSH, right, the secure shell, to be able to tunnel into that, unlock the door with our key, and be able to administrate and access that server. So let's start working on it. The first thing we're going to need to do is generate a key. So I'll copy this out, jump over here, and let's run the command. And you can see it's choosing an encryption standard, it's naming this key, and then it's also putting it in a specific location. So that all seems fine and dandy to me. I'm not going to do a passphrase. And you get some nice little random art, and you're off the races. And you can run this multiple times, all right, and override it, and you get different art each time. So it's just a way to visually tell, like, hey, did I do this twice, or did I just do it once, kind of thing. All right, so we've got our key here, our public key, and then private key right here. Let's figure out what we need to do with it. So we got that. We have to import it into AWS. Let's grab that. And we'll paste that there. And I think that'll work just fine. But the refreshed credentials are still expired. Credentials were refreshed. Oh. Exit this. AWS Vault. Let me just make sure my AWS account. AWS STS get caller identity. That seems fine. Let's see if that works now. All right, that was just my AWS credentials ran out of juice. So we're ready to go. And we've done that. Let's run this, and we can see if our key pair is up there. And that seems reasonable to me. And it was updated today. All right, so let's come over here. We're going to copy this. We're going to fire this here. See if we pass. Good, good. Next lesson. EC2 instance with a VPC subnet and with key pair. Now we've created and we're ready to launch our first instance. So, how do I get Linux or Windows running? How do I provision it? How do I create an instance? So we're going to walk through like, hey, what does it take to actually stand up this instance through this step? And we're going to stand up a very small server, right? What is that, a penny per hour? So hopefully this does not take us very long. And also really show you, if you want a small server, it's pretty easy to get one, even on AWS, and even there's cheaper ones out there. All right, let's go to EC2. And we're going to go launch instance. So we'll go to instances next. We're going to launch instance. And we want a name here. All right, it wants Amazon Linux. Click. Did that do it? I think that did it. Oh, there it goes. Amazon sometimes is a little slower than other times, but there we go. And that's all fine. Here's what size was T3 micro. So that's a T2 micro. It's really sluggish here. I'm just gonna go ahead and reload this thing and maybe it'll, oh mercy. Reload this thing and see if it goes a little faster. All right, throw our name in there, Patient Ping Web. Thank you, Amazon. Thank you, Amazon. All right, so I got this, I got this. Let's switch this to T3, which is super slow. Come on, Amazon. There it goes. Oh, okay. There. T3 micro. Boom. All right. We have to choose our key pair that we uploaded in that last lesson. We have to choose our network. Don't use the default, right? You can hear me say that 100 times. Choose patient ping, and I'm pretty sure it wants us in public A. Let's just double check. Public A. And we're going to turn off auto assign. That's already turned off. And we need a security group name. Okay, we need to call it empty. We'll be doing this the right way later. Boom. And we don't want any of this. Storage, that's all good, that's all good. And create. And so let's watch our progress here. So these things don't spin up instantly. You can see it goes into that pending. Oh, it's already up and running. That was pretty quick. Oh, you can see it's still actually initializing under the hood. All right, so what did we do, right? We stood up, we had to build our key first, and we had to have the network where we're putting the server in. But once we have those things, we say, hey, please build me a server and please put it into that network. And we're up and running. Let's see. Boom, boom, boom. Launch it, so you should see that. Patient ping, and that. All right, let's see if I can run this thing. Wonder if it's going to be upset if it's still in a pending state when it goes online. Oh, there it is. Let's see, it's up and running. All right, beautiful. What does it want us to do next? Sorry, so what is an AMI? We made some choices there, but we didn't talk too much about what those choices are or like why we chose a T3 micro instead of a T2 micro, and what the heck is the difference? All right, the first thing we chose is the AMI. So Amazon Machine Image is like an ISO. It is a disk image or a disk or a configuration for a server that contains all of the OS information related to that. And it's a little bit more than just like, hey, this is the OS disk that's attached to the instance, because it does change how that VM operates in some case and changes how it gets billed. So you can choose many of the free AMIs, those free images for building an Ubuntu server or an Amazon Linux server or one of these other free distributions. But you can also choose things like a Red Hat image, or you can choose a Windows image. Images that come not only with the software, or come only with the OS level, but also software on top of it that costs money. And so you have to be a little careful when you're choosing it. Some of them also come with applications installed on otherwise free OSs, right? If you want a Palo Alto firewall server, you can go to the marketplace, you can click on their AMI, build it, but there's additional costs associated with that. So be careful when you're choosing an AMI that you're choosing what you know, and yeah, so that's the AMI. The other thing that's interesting about AMIs is you can make your own, right? So if you have a whole lot of deployments that you're going to be doing on a repetitive basis, you can take an server, kind of cook it exactly how you want it with your application, with your logic, with whatever security configurations that you want to do. And then you can click create an AMI. And that lets you basically clone that server as many times as you want going forward. And this is the basis of some things we'll talk about later, like auto scaling groups and some other utilities. Some people use it for backups as well too. Saying if I take a full copy of my server every day at 8 p.m., guess what? You can always quickly build a new server whenever you need it. All right, that's enough of talking. Let's keep going. And then the instance type, right? The instance type just tells you what are the resources associated with your image, right? How much RAM does it get? What kind of operating characteristics that you have? The letter in front of it talks about the instance family. This talks about instances configured for a specific purpose. So there's like M, which is their general use, or there's R, that's CPU, or G, that are Graviton, or there's also graphics, ones that come with graphics cards attached to them. Look up what the instance family that you are using, what it specializes in, and try to understand that. But then let me also show you a really helpful tool. There's a tool called EC2 Instance Info. And I'm just going to look for the GitHub version. There's a version that got purchased by a company too. We don't need that. Well, I guess we'll just go to Vantage's version. But you can see here, it will give us a full list of all the instances, how much they cost, and all their different configurations. Of course, ever since they got bought, it's been much slower. Let me give this just a second here. All right, there it goes. I just had some filters on. So you can see here, right, if I wanted to look for my T3 micro, you can see that it's going to cost me for a Linux server on demand $7 a month, right? Or for a reserved cost, and we'll talk about what that means, even less than that. But the Windows cost you see is nearly double that cost that's been associated with it. So this can be helpful, right? You could also look for M4 extra large, right? It's really common, and you can see that it's coming with 16 gigs of memory and 4 CPUs that it can work with. So the different sizes, that the first thing is the family. The 4 kind of stands for the generation, like Amazon releases new versions of their M series family or of other things, but generally the latest is going to be the cheapest and the best option for you of whatever family you're operating in. And then the last bit just kind of designates what size, right, what t-shirt size that you're operating with, and how many resources that they come for. So shop it around, take a look at what's available to you, and choose a good one, right? We choose the T3 series. T is a burstable image, and they're meant to be low cost generally, right? You get kind of bursty workload, so when we send a command and we do something specific, we get more resources than what we generally have for kind of steady state operation, which is really nice when you're going around and testing stuff like we are. All right, enough talking, let's keep going. So we've done that. We chose an instance type. So what does an AMI do? Is it a template for building servers and defining OS? Is it a template for building? I can't see. Is a Docker image? Yes. No, it's going to be, I can't tell the difference. For building servers and defining software, but not the hardware. Oh yeah, that's right. So we're not doing anything hardware with an AMI. Because you can actually take an AMI from one server and then choose a bigger instance type to run it with, right? It doesn't lock you in necessarily in most cases. All right, let's keep going. All right, public IPs. In the IPv4 space, some addresses blocks are open to the public internet, while some are reserved for private use. And there's some rules around it, right? These joyous, terrible to read things called RFC 1918, request for comment, right? Where basically they pull the professional area of like, hey, let's develop a standard for something, where they define some of these IP rules, but you can come and read these. But essentially what these two things say is like, we've dedicated some blocks to be purpose built for private addressing, right? So when an internet provider gets a request with one of these private addresses, it gets dropped. It says, okay, we know that this is we're not supposed to do anything. This traffic shouldn't be coming to us, and we don't send it. So some of these things, some ISPs will drop and just not send anywhere. And 6598 gives one extra group of addresses kind of classified in that private space. So all that to say, oh yeah, and this is a great thing, right? So most people are operating with two different IP addresses, right? They have a private address that they use to communicate with other private servers and resources, like when you talk to your printer or when you talk to another file server on your network. You talk to that with your private IP address, and you can set up trusts for your applications, or even at your network level, that says, hey, you're allowed to access the file server if you're coming from a private network. Or maybe it's a backup server. Say, hey, the backup server, it lives in this special network, and this special network is allowed to do this thing. Versus if someone's coming from the internet, right, and they would come, you'd be using an internet IP address, something that's not in one of those private IP address ranges, and you can build logic off of it. All right, so to answer your question, why might a server need a public address? Public addresses are needed to talk to other public addresses, like a website or service. Private addresses can be dropped by internet providers and are meant to only be used for local network traffic. Thus, using a private address won't connect to those external resources. Oh, and if I could spell, boom. Let's see if we got it. Does Boots like it? We got it. All right, let's keep going. Elastic IP addresses, right? So our patient ping server, remember we had that option that says, hey, would you like to auto assign an IP address to this thing? And we said no. And there's a specific reason that we did so. So an elastic IP address is basically one of these public addresses that we can glue onto any server or machine or some of the services as well and make it have a public IP address that's associated with it. So let me show you. It might be easier to see. Oh, let me get this back up and running. So when I come to the server over here, so I'll click EC2 and we'll let Amazon load. All right, so when I come over here for the server, right, you can see patient ping web, and you can see if I click on it and we go to networking, it has a private IP address, but the public IP address is nothing. And so if I were to try to connect to this, I could try to send traffic to this private address, but my machine that's sending the traffic, right, if I came here and I say, hey, I want to SSH to this address, and make it verbose, it's going to try to connect to it, and it's going to look inside my house here, right? And it's going to say, hey, does anything in this local network have this address? And it's not going to find anyone because no one is listening under that address. So we need to give it an address that is public so that when we hit the route table, it goes to the public internet and it tries to connect to this server. So, and what elastic IP addresses allow us to do is basically glue that public IP address to that server for when we want to use it. So let's go to it. So, all right, and here's the thing, right? Once earlier in Amazon's history, they used to give free public addresses to some servers, right? Or on a per server basis, you would get one free public IP address. That's no longer the case, right? So now they charge for every single public address that's associated with your account, whether it's in use or not in use, or regardless of how many servers that you have. So don't turn on public IP addressing unless you have a specific use case for it. The other thing is that elastic IP addresses can be detached and reattached. Have a new server or want to replace that server or move that traffic to a backup server or something else. If you have an elastic IP address, you can pluck that thing off of server A and drop it onto server B, versus if you are using some dynamic or like quickly assigned or auto IP address from Amazon, you can't do it. You're going to have to find a way to funnel that traffic some other way because you can't just simply move the IP address in a graceful manner. All right, that's a lot of talking. Let's go create an elastic IP address. So you can see not a lot of cost, but $4 a month, right, thereabouts. So come over here. We're going to come to elastic IP addresses. I'm going to allocate one. It's Amazon's fine. It's going to be in US East 1. Hopefully this IP address doesn't exist when you guys, or it's been given to someone else by that point. Let's allocated it. Now we need to associate the IP address, and I'm going to choose my server. And I would say that's fine. I'm going to associate with that server. And now when we go to that server, we should see that thing's attached. So let's go over here. And if I look at the networking now, you see the previous, it's got it cached here, right? There's no public IP address, but if I refresh, boom, that public IP address is now on here. So let's see if we get anything back from it. And unfortunately, we're not going to be successful. So let's try it. Boom. and nothing, right? I didn't run the verbose that time. But you can see we're still not getting some, we're still missing something. So let's jump back into our lesson and we'll kind of figure it out. Okay, so we allocated, that's all fine. We checked the box, associated, and now we confirm. So all that's good. Let's grab our tester. Beautiful. All right. And that issue that we ran into was security groups. Security groups are basically a firewall or a software-defined firewall, right? For it's not a physical piece of equipment we're dropping in place, but basically we're configuring Amazon's firewall to allow some traffic while denying other traffic. And by default, it's an allowed list. If you are not on the list, you are not allowed into that environment. So we have to set up some kind of condition on that security group for the server to let ourselves in. So, and what you can see here is like, okay, if we've got our server, right, here's our private network, here's the public network, and we want to connect those two things in, by default, we're hitting this chain, right? We're not allowed in. And we want to have a specific channel that our servers are able to communicate with one another. I want my server to talk to this server that we just provisioned and to make it work. So we need to add the security group rule. And you're going to see the CIDR blocks are coming back in, right? Where we can actually, instead of just writing the rules one by one or with some kind of special identifier, we can actually open up network space for ourselves to be able to access from. So let's go do that. So create a security. Okay, that's fine. That's fine. And we need to create a security group. So let's go create that. So down here, there's a security group. So I got here from EC2, and then there's on the left-hand side. Let's create a security group, public, and this needs to be associated with the right VPC, otherwise it won't show up. Don't know that. And I want to allow an inbound rule on port 22. And that's fine, that's fine. I'm gonna leave the outbound rule in place. Technically, you don't need this. Let me actually check the instructions and see if they care. Allow public access, okay. Oh, I didn't add this, let me add this. Forget if I added a check for it or not, but we'll throw it in here. Okay, inbound rule. And it wants a description. Boom. And I didn't do the type. Let's change the, so you can do custom TCP where you just specify the port, but you can also do this. If you come to SSH, click, you can see that it locks it in, says, okay, I know SSH is usually on port 22, and it will do some of those things for you. So if you know the protocol that you're working on, it will kind of figure out the port for you. Now, it's important to know that you can actually do SSH on any port that you want. It's not dedicated, it's just kind of the practice of this is usually what SSH traffic travels over. So it's all fine. Is there anything else on here? Create security group, and it wants me to associate that. So let's create the group. Then I'll come back to my instances here, and I say I want to edit this one guy, and I think it's under security settings. Change security groups, there it is. And you'll notice you can actually have more than one security group on here. So here's the public. So add that, and I'm going to remove this empty one. Save. But that lets you say you could have a security group that is one specific for a single server or a group of servers or a combination, right? So you might have developer allowed machines security group, or you might have access to DNS or different types of like logic based versus like pure sets of rule for individual servers. And this lets you kind of compose what is allowed to certain groups of servers and what isn't. You can have a default security group that applies to all your machines and traffic that you know that you want to allow for every other machine. You can kind of mix and match with what you need. All right, so did that, and we associate it. Let's run the command. See how we do. All passed. Beautiful. Let's keep going. We want to SSH onto our server. Okay, so now let's see if we can do the thing we tried to do at first. So we've got, do I still have the command up here? Let's see if it lets me do that. Oh, so we got a response back, right? Let me get rid of the verbose so you guys can see it a little bit. So I did SSH and I did the name of the server, and you can say, hey, we connected to this thing, but we can't establish its authenticity, right? It's basically saying our computer has never SSH'd onto this specific host before. Do you want to add a fingerprint? Are you expecting this to be a new host, right? This keeps someone from like pretending to be our server and says, hey, please send us your information or please log into this thing, right? It gives you a way of saying, okay, I'm talking to a host that I usually talk to here. So let's say yes. But we get permission denied. Why the heck was I denied? Spiff cannot access this server. Why would that be? Let's read and we'll probably get a reason for it. All right, you may understand why people, so okay, there's definitely some steps going on here, right? People turn and some give up on AWS before they get to this point. Like, it's networking, it's too complicated. Nothing we've done here is crazy, right? We're just saying, hey, we built the thing. We built a network to put our server in. We put the server in it. We put keys in it. We said that we're allowed to access it and we're up and running. But it can be hard, right? Let's come through here. We said we've allowed port 22 traffic in. And what's it having us do here? Oh, we want to update the message of the day. That's always kind of nice. But we need to say we're missing something. Okay, it wants us to set up our SSH config. Okay, let's come do this. So I am going to, so basically what we need to do is we need to see, you see the issue we're running into is that we need to specify the specific user that our AMI is using. And when I set up this SSH config file, we're actually going to say, hey, patient ping, here's the IP address, and we're always going to use it as this EC2 user, right, idea. And that allows us to log in with a specific user. And the way that that would translate in the command line is doing this. SSH EC2 user at that server, and I've forgotten the name of it. Here we go. So EC2 user at this. But I missed something. See if you can think of what it is before I does it. I still get denied with this. I did not specify the key that we're supposed to be using. So I have to specify that identifier, right? And we do that like this. And I say, hey, I'm gonna set up actually I think you gotta do it before this, but inside SSH, we set up a, what's it called? Patient ping? There it is. Basically, we have to, where's my command? Oh, here it is. Mercy, SSH -I, thank you. Is that the right server? Patient. There's the key, and it's gotta be EC2 user at that thing. Mercy. Okay, and does that work? All right, that does get us in, right? So you see that we had to specify both our identifier, and this is the private side of the key. That's what I use to say, hey, yes, this is me, I am me connecting to this thing, versus the public key, right? You can look at that. This is, oh, mercy, I was missing patient ping. Oh, I'm on the server. Okay. First, if I do this, cat SSH and say patient ping public, you can see here is the public thing. This is what gets stored on the destination server for the patient ping key. So let's jump onto this and let's do the thing we're supposed to do here. So we're on the server now. You can see I am EC2. Who am I? I am that user. So let's first set up our SSH config, right? Because this will be used by you can see here in when we're running the tests under the hood, we're using your SSH profile to connect to the server and validate things are doing what they're supposed to be doing. And also saves us a lot of typing and me futzing around trying to get my parameters right. All right, jumping here, and I've got that. That's all good. So over here, so I'm gonna exit out of the server, and I'm gonna move my old SSH config. So, and then I'm gonna make a new one. All right, so here's our server, and we need the IP address. IP address was this guy, 34. And this was SSH patient ping key. Let's see if I can do it. Boom, ls Patient ping key, patient ping key. That's right. All right, let's save this down. So the nice thing about using these SSH configs is you can do a lot of things with it, including naming things well in a way that makes it easy for you to operate. But what it lets me do now that I have this thing is I can run SSH patient ping. And it does that exact same thing. It's saying, hey, please log into the server. Here's the IP address. And I don't have to remember all those things myself or fuss with DNS or key rings or 100 other ways that you could solve that problem. But now we need to edit the message of the day, right? And I forget what it has me do. So we're gonna come in here and it wants us just to do this. So let's grab this command here. And what's it doing? It's saying it's echoing welcome patient ping and it's dumping this into the message of the day. And now if I log out and log back in, boom, you can see it's popping in. That message of the day pops in whenever someone logs in or SSHs onto the server and gets an interactive session. Good, good, good. Let's grab this command and let's see if we pass now. Beautiful. We can keep going. All right, so now we need to deploy the site. Now that we can SSH onto it, we'll install Git. Let's go grab that, and we're gonna be using DNF for this. So we'll SSH patient ping, we'll fire this command, and we got that. So we're installing Git, and we're gonna be using Git to pull code onto the server and for us to be able to run this thing. And we're gonna be grabbing UV, right? This is the fancy new or newish, at least new at the time that I'm recording, newer at the time that I'm recording, way of managing Python and dependencies in the version of Python in a way that's a little bit more sane. So thank you to the team at Astral that's been working on this. So run that. So basically I pulled down, okay. So basically it pulls from this address, this install.sh script, and then it passes it to the shell, right, and executes whatever file it's in there. So that's all fine. Let's see if we've got it. This is fine for us who are testing and building something that we're planning on throwing away. If this is a server that's gonna last a long time, maybe, double check. Don't trust random Zach from the internet's script that you should just definitely fire this on your big server. Go to Astral themselves and you can confirm that we're doing the things that we're supposed to be doing here. Supply chain attacks are no fun. All right, we got UV installed, so that's all good. Let's see what else we got. Boom, boom. We've checked both of those. And now it wants us to clone this and then change directory into it. So I think we can just grab all this and dump it here. So we're gonna go to the home directory. We're gonna do a git clone. We're gonna go into that folder that we just cloned. UV sync installs all the dependency. Basically it grabs the requirements.py and fires it, or I think it's called something different in UV world. And then it runs this UV run command. So you can say, okay, SSM config was unavailable. It went to .env and it says, hey, there's no credentials available, and it's listening here. So this is probably gonna come up in a later lesson, a little foreshadowing for you. But you can see it is listening. So let's see what we got now. So you should see the server start up on that. On your local machine, try opening this and it will fail, and it should hang and fail. And why is that, right? So here's a question for you, right? It started on port 8080. Why would opening this address not work? And it's because that same thing, right? The security groups have only been connected to port 22. There's no 8080 trust going on here. So let's see what's going on here. So this is going to jump onto that and it's gonna SSH from the server itself. So that should be perfectly fine. We'll fix this soon. Okay, so that's gonna be in a later lesson. So let's run this command. So can I run this command? All right, I've got another window over here we can use. So let's run this. All right, so that did pass. It was able to connect and see that this thing was running, and let's keep going. All right, open web traffic. Patient ping app is running on the server, but our security group only allows inbound on port 22, right? We got to open that to port 8080, so that seems reasonable. And it's a good practice, right? Adding firewall rules as you need them, when you need them, is way better than just saying, hey, I'm just gonna allow all of the internet to access my server, and they probably won't find some terrible 0 day that allows them to administrate and do whatever they want. least-based access and access as you need it is a really good practice to start baking into your brain. I was saying, yeah, this is going to keep me out of trouble. All right, so let's jump over here. We've got to add 8080 to our firewall. So I come here, I come to the server. I'm going to come to security, right? That seems reasonable. Here is the security group. I'm going to click on the inbound rules, traffic that's allowed in, and I'm going to edit it. And we're going to add custom TCP. I'm going to add 8080. I'm going to add my IP address here, and let's see, what has it got? We need our description. Beautiful. Oh, can I find the button? There it is. And confirm. Okay, save rules. And now let's see if this works. So let's come over here. And I've got this, do I have the server over here? I can just do it this way. Let's also make this a little bit bigger for you fine folks. So control big. So let's grab the server address, which I have in my SSH config. And so let's curl this. Grab you, curl that, and we set on port 8080. We definitely have content there, but we can do better than that. Let's go to our web browser. Look at that. DB is disconnected, internet egress is okay, but the words are way too small. Let's move this up a little bit. Beautiful, beautiful. All right. So let's jump back over to our lesson. Oh, and I just closed it. There, we're back. So we did that. We did that. We opened up. Oh, the source should be anywhere. So let's go correct that. Instead of I just allowed it to my specific port. So if you come over here, you see, hey, this /32, remember 32 means one address is allowed to hit the server. We want to let anyone hit what's running on this site. So we're going to come and edit it. Edit inbound rules, and I'm going to flush that, and I'm going to say 0/0/0. It's the opposite of /32. It's every address in existence. And we're going to save that. And now anyone should be able to hit this site. So that's good. Yeah, let's try loading this thing. We're going to need this guy again. I wonder if that worked. Yes, because I didn't do my AWS. All right, AWS Vault, exec, and I want to do boot dev. AWS STS. Let's see if that actually works. All right, so that's worked. We're back to Zach admin. So now I should be able to run this thing. I'm not going to get any streak awards in this session. No, that's not what I want. I want this. Ah, that seems better. Boom, we've all passed. We got a 200. Let's keep going. Creating your own AMI. When we configure, right, so we talked about this a little bit. AMIs are basically the OS and any application installed on that OS. Sometimes it does have a few other kind of fancy things, but generally think of it as a snapshot or an ISO of all the disks associated with our machine. Now, you can also snapshot, like take backups of individual disks themselves, but that can be tricky, right? What if you have a database that's running on the disk and then a management application that needs to be in sync that's running on two different disks, right? An AMI will do what's called a freeze, a file system freeze, and so that you don't even have to turn off the server usually, and you can take a consistent snapshot of both volumes. Versus if you ran them individually, you might have slightly out of sync information between your two volumes. Snapshots help you. The safest option is to turn it off, right, and then snapshot both of them. But that's it. So let's use an AMI as a backup utility here. So we're going to create a simple snapshot of a running server. We're going to cold store it, right? So AMIs are backed into S3 under the hood, right? So it gets nice and cheap for us storing these things. You can actually send this to different places. So if we wanted to send this to Oregon, we definitely could. And it's cookie cutter, right? We talked about that. So let's create a AMI of this. So we're going to jump here. We're going to go to EC2, instances that are running. And if I can navigate Amazon here, there it is. So I'm going to say instance state. All right, I want this, image and templates. Create an image. And does it want a specific name? Select your instance. There you go. Boom. Oftentimes, right, so while this is cooking, you'll do this before you kill off a server, right? So if you've got a whole bunch of servers to offload, say, hey, we're spending a lot of money, no one's using those servers, right? Will you go destroy them? If you want to be smart and if you want to sleep on weekends and not work on weekends, what you can do is you can, before you destroy the instances, create an AMI for them, right? That way, if that server did actually end up being used or there's some cron job that's running once a week on that thing, when the world explodes, you can say, oh, I took a backup. I can quickly, with one button, build a new copy of that server. We're back in business versus wasting huge amounts of time or disrupting businesses, right? Knowing that this tool exists is one of the things I want to have in your brain so that you can operate confidently, saying, okay, if I break it, no big deal. I can always roll back, and to know how to do that and to do it easily. All right, let's go look at our AMIs. So let's go to AMIs. And I'm going to say owned by me. You can see this guy is chooching along and it's still in a pending state. I wonder if the lesson lets us go on. Let's go check. It'll take a few minutes but you're free to move forward in the meantime. Oh, beautiful. So let's grab this. Because depending on how long this takes, it could be a hot second before Amazon actually finishes running that thing. So we're going to run that. We passed. We can keep going. Reserved instances, companies, so basically the idea is saying, great, cloud usage lets us have basically rent servers by the hour, right? But if you've ever kind of done the economics, eventually at some point renting the thing is way more expensive than just, buying the thing. And the people that are buying it and then letting other people rent it are depending upon that being just like a fact of economics, that they can eventually make money on their purchase of that hardware by renting it out. But reserved instances let Amazon get more predictable usage and lets you get cheaper compute, right? So if you can commit to a level of spend, right, and they call this reserved instances, or they're now making a big push towards savings plans. But basically the top level idea is that you have a commitment of 12 months or 36 months to say, I, Zach, will be using this server or this number of cores or this amount of memory for this period of time. And you provide that commitment to Amazon and they give you a discount, a huge discount because of it. Did I pull the numbers? Right? 26 to 72%, right? Your cost can be saved if you're able to get your business or if you can make this commitment. And so it makes a huge difference in your operating costs on AWS, right? For being able to commit to these things. There's a different aspect to it, right? If you are a really large company, so you can also use this to also reserve, right? That reserve term comes from the idea of saying, I would need to make sure this number of computers are always available for me to use and me alone, right? So if you needed to spin up 10,000 servers, you should probably, talk to Amazon and have them keep that capacity available to you. But for Zach, I've never had that need. I've never run out of servers personally. It's definitely possible, but it never happened to me. So using a savings plan allows us to commit to Amazon and using a certain level and to get a huge amount of discount and can make a big difference for your company. So, and you can see here, there's some details, right? You reserve by the family and you can change different things like you can choose like different availability zones that it'll be operating in, but there's lots of small details to it, but that is the main thing. So if you're going to be on AWS for at least a year, should you use a savings plan? Let's say almost always, right? If you know that you're going to be running the thing, right? Even in the small instance, right? If we're spending, $7 a year or $7 a month times 12, $78, is that right? No, $84. $84 a year, and you got 25% of that back. That's not nothing. It's worth a few seconds to go click the button if you've got that kind of foresight into what your future looks like. All right, let's keep going. Auto scaling groups. So now we did create an AMI, but Zach, the course author, was also kind of strategically setting us up for this conversation. So we have one server that's up and running. That's great. That's fine. That's inexpensive. But what if that server is a little flaky? Like if that server explodes sometimes and we need to recreate it? Or what if we need 10s or 20s of these servers? How do we kind of be able to scale this thing up to this huge kind of like cloud scale that everyone's talking about? And the answer is like these auto scaling groups, right? We basically tell Amazon, here's an AMI we want you to use, and we want you to print this thing off 20 times. Or if my server gets too hot and keeps like maxing out the CPU or the amount of memory, or I see this number of transactions rolling through, build me another server and add it in, right? So that we can start doing things. So a scaling group doesn't cost anything by itself, but obviously if you're building a whole bunch of servers using a scaling group, then it's going to cost you some money. So that makes sense, straightforward. And this is just a question. So auto scaling groups, we're going to be walking through it. So what is auto scaling? Does it do automatically increases CPU and RAM? Now this is important. You can change the instance type. I'm blanking now if it requires you to reboot the server always or just sometimes. I think it does. But you can do what's called horizontal scaling, where you just like, hey, I'm going to add more resources. That's vertical scaling. I'm going to add more resources to this server to get it to operate, right? It was running on 4 gigs of RAM. Let's see how it runs on 64 gigs of RAM. And so you can do that. But that's not auto scaling. Auto scaling is copies of that server using that AMI to print copies of the thing. So auto scaling is not that. It's not that, it must be this. All right, let's keep going. All right, so how do we do this? How do we actually set this up? The first thing is a launch template. Basically, this is the recipe card that we tell Amazon saying, this is what we want you to build and the criteria when we want you to fire new copies of the server. So we need to build one of these things. Let's go to the launch template. Hey, look at that, private subnetting. Is that my challenge? That might be my challenge. Okay. So we need to go to, it's an EC2. Launch template, thank you. It's also something you might see called launch configs. If you see that, there's usually a button over here that says, use our new launch template feature, but hopefully that's going away and simplifying. But know that they're very similar, launch templates and launch configs. All right, we need our launcher. Let's grab that, paste that there. And we need a description, let's grab that, paste that there, and under my AMIs, so let's go that, my AMIs. There she is. We're going to choose that. An instance type, does it want us to include it? Yep, T3 micro. Oh, this is the really slow menu. T3 micro. We need our key pair. Now this is important. You'll notice that you don't necessarily have to put a key pair on an instance when you create it. If that's the case, then you might build a server that you can never actually access. Like if you're using your own AMI like we're using here, you can like bake key into your AMIs. But usually the best practice is that the AMI providers will let you specify the key. And so as it boots up for the very first time, it installs that key in. Not required, but make sure you don't forget, because that's embarrassing to have to destroy that brand new server and start all over again. Don't, I'm granting you 5 additional minutes of your life back to you. All right, it needs to go in public. Boom, 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 boom. Public B, public A. Boom. Now that's interesting. So you choose the subnet, but you can also choose this, but we're not going to specify that because it should happen automatically. Yeah, the subnet determines this. Common security groups, we want public. And is there anything else? Storage level, leave the default, 8 gigs, or gibbies, I guess. And create launch template. So the launch template itself doesn't cost anything. It's when we start firing and building new servers based off of it. So you'll see that in a little bit. All right, let's click that. So we got that. Confirm it's there. That's all fine and dandy. Let's do this. Let's go to the next lesson. And success. What do we got over here? What's next? So now we want to launch from the template. At this point in the launch template, we could create, The point of creating a launch template is so we could treat servers like cattle, not pets, right? So it's like, hey, we don't try to nurse these things back to health. We don't have one of these things. We have hundreds of these things. And if we need to replace it, we simply replace it with a new one, which is really handy and can be helpful in some circumstances. So let's go through and do it. So we're going to blow away the old server. Let's go do that. Boom, 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 boom. Actually, I think it's over here. Terminate. Goodbye. Now you see there is an option to release this. That is interesting. Did it have us do reassociate? So I'm not going to release the attached. Oh, let's try it. The following Elastic will still be associated with your OK. So it's not going to actually destroy it. It's just going to disconnect the Elastic IP address for it. And I'm going to skip OS shutdown so things go a little quicker. Just like unplug the machine, right? You don't need to do anything graceful. Flush the disk. We don't have any like graceful application spin downs. You can see it disappears instantly, but if you uncheck this box right here, you can see it actually is, shutting down. And I think there is AWS rules, I'd have to remind myself, but of like when AWS exactly stops billing you for that server. Is it when it's terminated for real, or is it as soon as that API command hits? And I'd have to remind myself of which side that actually happens. All right, let's keep going. Dun, 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 dun. So EC2 launch templates, that's here. And you can see this. We can see auction, launched instance from template. Is that what it wants us to do? Yes. Can we click launch instance? Seems simple. Just for fun, let's build 5 of these just to say that we can. And so 1, 2, 3, 4, 5 built. Back here, we should see a bunch of instances spinning up here. All running. Oh, and that one finished terminating. That's good. So we did that. We did the terminating. We launched the new instance. That's all fine and dandy. And we need a name tag to this so I can see that. Yes, we did in fact do that. Come here. It is interesting. Oh wait, no, our message of the day should still be there, right? Because we did our own edit on it. Or we did our own AMI. Let's do that. And let's go grab, we need to add the IP address to this. So can I do this? Network associate. Disassociate Elastic IP. Do a public IP address for all these guys? No, I don't see public IP addresses on these. That would be right there. But it is still initializing, so it might be just waking up. But let's go to our Elastic IP addresses and we'll attach it to it, just manually. Boom, boom, associate, choose instance. Here's the one that we named. Yes, that's all fine. Associate. Beautiful. Now we'll come to instances. And if I come back here and refresh, boom. All right, so that's all working. And guess what? Because it's using that exact same IP address, we can still use our normal SSH. So if I patient ping to this, and see, this is expected, right? We talked about that fingerprint a little bit. Someone has changed the actual instance that's running the last time we connected. And so this is a warning that says, hey, something's changed, right? Did someone replace that server on you and they're trying to get you to connect to their server instead of the one that you're used to? But no, that's not the case. We just recreated this thing. So we can use the handy command that they provide here, this keygen regenerate, I think is what it stands for. That's what I'm going to go for. Copy, paste, boom. Oh, I forgot the copy, paste. Remember your quotes. Okay, and now let me see if it lets me do it. Beautiful, and you can see. Oh wait, where's my message of the day? Let's go splunking. Sudo cat etsy modded. Oh, see, that's not in there. What, it wasn't in my AMI. Neither here nor there. Little mysteries. Enjoy every day. All right, let's keep going. We attach the IP address. Update your SSH. Okay, you can see that -R for regenerating, saying yes, we did move to a different host. And we did this, and this wants us to start the application back up. So let's go do that. Oh, I'm not on the, let's go over there. There's that content, so that's all good. UV sync, UV run, and then let's do that. Did I run it backwards? What did I miss? UV run patient ping. Oh, you got to specify the file. UV run patient ping that, and then I'm going to do this ampersand, which just sends it to the background. So you can see it's running, but I still get access, so I can do something like this: curl localhost 8080, and I get the content back. Let's come over here and see if our site is still running. Still chugging along. So that's all fine and dandy. And we also used, we still have all the other servers, right? It spun up 5 identical copies of this thing, so let's blow away our ones that we don't need anymore. Boom, terminate, delete instances, delete. And I forgot to click skip shutdown, so it's actually gonna go through and boot down the little Amazon Linux that this thing's running. Neither here nor there, let's keep going. So we got that, and let's fire. This has got to be on my machine. Beautiful. Spot instances. All right, saving plans are great, but what if you want to save in even more money, right? So what if you're not in a position where you don't know what your usage is going to be in 3 months, let alone 36 or 12 months that a savings plan or reserved instance would make you do? What are spot instances? Essentially, spot instances are just a huge discount on a leftovers market or secondhand server market. Amazon has a bunch of servers that it hasn't been able to sell for full price, and so they have 2 choices. One, they could still rent that server out for as much money as someone would pay for it at a discount, or 2, they could just leave it idle sitting on their rack. And the idea is that those servers will age regardless if someone is actively using them or not. And so it's better for Amazon to get some of that money back than to not get any of it. And selling it at a discount can still make financial sense to these guys. So, let's see. You get a 90% discount, but you have to commit to a long-term contract. No, remember, the long-term contracts are those savings plans, not the spot instances. Oh yeah. And the big thing with spot instances, right? So it's saying, great, I can bid on this unused resources and I can get a huge discount. Why wouldn't I just do that at any time? And that's this, right? It's I'll give you this massive discount, but be warned, at any time I may literally delete your server with a 2-minute warning. So at some time, if Amazon finds a customer that is willing to pay full price for that server that you're using, Amazon will literally delete your server with a 2-minute warning and give it to that new customer. And it makes sense. It's hey, I want the discount for as long as you'll give it. And if I have some workload that is okay being interrupted, or maybe I'm running hundreds of nodes and only some of them are spot instances, that can be perfectly acceptable for saving a huge amount of money for that specific project or that specific workload. All right, so it's not this. And it's this one with the 2-minute warning. No, it's not that. And it's not lower quality instances. So let's keep going. Stateful, stateless, right? And so just from my background, so you guys know, I came from an operations background. I was a finance major in college, right? And trying to figure out stuff. And so I just got interested in IT and operating systems. And then I went all the way down to learning to program and to being a developer really full time now. And so this is near and dear to my heart, and it was intimidating for me. And so I want to help you understand this, and especially how it affects how you architect cloud solutions. So stateful, stateless, right? Applications, right? There are going to be some things, right? Some applications that you run that are going to care about the information. I do enjoy some of my own writing, right? Which is a little self-serving. It's a little humbling and also fun to kind of read your own jokes, right? Because they're kind of tailored to your own brain. But let's talk about it. So we just talked about spot instances, which are instances that can disappear at any point in time. But if your application is controlling all the data, right? So your users sign up and you store that information on the server, which seems reasonable. And if that server is deleted, you've lost everything that user has ever done. And so that would be a stateful full, right, application. That application controls some block of data that it needs in order to be able to do its operations, and then it has direct ownership of that data that it's created. Now, a stateless application is an application that doesn't have that. It doesn't control where the data lives, right? And so this would be the idea of saying, okay, maybe the web application, right? You log into bootdev.com and you log in, you create a new account. If that web application, instead of writing that information and logging you in and saving your information and your progress, if that instead of happening on the web server, if that happened on the database, right? If that web server called to the database, wrote to an external database that was always on and always available, a few things happen. One, if you got connected to a different server, the database doesn't change, right? We can throw away a server and replace it, and all your information, all your progress is still going to be there and saved and available. And using something like a spot instance, where the server could literally implode and be replaced by 100 new ones over a course of a day, doesn't really matter all that much, right? We don't really care about the servers as long as the application is healthy and as long as that database where the application state lives. Now, there's also different types of stateless applications. Like you might have a landing page that's just like, here's information, right? And there's literally no way to like change how that application operates. That's also a stateless application, but that's kind of what's going on here. So if you understand your application, and how it's storing information and how it's interacting, it really impacts what levers you have in AWS to work with. So let's talk about it. What is application state? So application state is all information stored as a result of operating the application. So user creation, content, progress, logs would all be aspects of application state. If the server contains state on it, it must be protected, right? We don't want to lose that information. If the server is stateless, having all of its data in an external DB or service, then the protection of the server itself is a secondary concern. Let's see if it likes that. All right, can you give me one more reason why we should care about application state when building servers, right? So in AWS's case, stateless applications are a great fit for spot instances that can be procured much cheaper. It also helps us determine what servers, let me spell correctly, mercy, need to be backed up. Did I make Boots happy? Boom. All right, brilliant. All right, cleanup time. Optionally remove the EC2 instances and the Elastic Ps if you're not moving to the next section immediately. So let's go, well, am I going to be moving directly? What time is it? 4:50. So let me go kill off some servers. So we don't want to pay for anything, and I think it might be good for you guys to see this as well too. I check my server state, terminate the instance, terminate that. Beautiful. Let's go. Remember, we looked at NAT gateways, and those are crazy expensive, so I'm just going to go double check that I didn't create one on accident. And so I'm on VPCs, like the networking category of things. And where is that NAT? There's the NAT. No NAT gateways found. We have a launch template. We stud that up. We did a key pair. We did an elastic IP address, right? I don't want to spend that $3 a month. So let's go to, and confusingly, instead of elastic IP addresses being in VPC, where all the networking stuff is, it's actually in EC2, which is terrible. And I wish I had a better answer for why that was. But it is how it is. It's probably there because EC2 was one of like the very first services and you couldn't really run it without the ability to manage it, but that doesn't make me feel better about it. So I'm going to disassociate the IP address, boom, boom, and it's already disassociated, so that's fine. Now I'm going to release the IP address, right? And say, hey, what's going on here? Release. Yeah, I think I just got to be patient. So I'm going to do the cooking show approach where it will magically be solved because Zach that steps away from the camera will be a little bit more patient than Zach on the camera. And we'll be back and we'll walk through some of the RDS lessons here momentarily. Thank you guys. Be back. All right, guys, so I'm back here. We've cleaned up my elastic IP address. I finally figured out, I just took a little bit for the server to let it go so that I could actually release it. And I'm ready to charge into, database management and talking about stateful or stateless app. Like if I don't want the state on my servers themselves, where do I have to stick them? And that's what we're gonna kind of figure out next. We're done taking a break. We're off to the next thing. So a relational database service. This is one of the core components of what AWS offers, right? And the idea was saying, hey, we want to provide a relational database as a service. One of the most critical components shared by a bunch of different applications and sometimes multiples of your applications or sometimes third-party applications, all depend upon your database having data, having it in sync, having it be the authoritative ledger of everything that's going on. And databases can be expensive. And look at that, DevSite is powered by a managed database service. It used to be on AWS and now it's on Google Cloud SQL. Well, there you go. So the idea of not having to manage, of putting professionals in charge of keeping your database alive, well, and optimized, that when it's doing patches, that's handled to you, is a great thing to be able to hand off. There's a reason that large companies have database administrators, and that's one, to structure the data in the database well, but number two, it's that walk through those migrations, to walk through updates, to tune the database specific to your workloads in a way that's effective. And it's nice to be able to leverage those smart people to go and do those smart things. All right. So we have a patient ping VPC. We can skip that. We left that up from being free. We have these done, and we have the internet gateway, and we have a key pair, and we need to build an AMI. So let's go build our server again. So I'm going to use our launch template just because it has everything. Oh, I don't want to create a launch template. Heavens no. I'm just going to fire a new server and say, hey, please launch this. Launch the instance. I'm just going to do one this time because, let's be reasonable. And you can see that the launch, it's kind of nice to have all the settings baked into that launch template. And hopefully you're some neurons are firing for you there and saying, yeah, clicking is fun and all, but it's nice to be able to do stuff quickly. All right, and security group. Okay, we did that already. And we need an elastic IP address. So let's go provision one of those. That's all fine. We're going to allocate him. And I wonder if it'll let us associate it. Associate the IP with an instance with him. Associate. Boom. Okay. And it lets you check all those things, and that's all fine and dandy. So what the primary advantage of using RDS instead of managing your own, does it do better performance? RDS only works with Postgres? No, because RDS lets you run many different types of database on it. They're all relational, that's what that R stands for, and there are other services for non-relational databases. That's not this part of the course though. RDS is always cheaper, right? We've talked about cloud economics a little bit, that's not always the case. And RDS handles provisioning, backup, patching, monitoring, automatically reducing operational hardware. That's it. The performance thing also comes in down to like, hey, me having a database running on my desk or having it run in memory, kind of like SQLite, sometimes you can be faster with that, but you're making different trade-offs there. So you can't always take this as a truism. All right, create a Postgres database and the patient name. Everyone's in constant fear the next time Zach reboots the thing. See, it's a funny course. You should read this more carefully than I'm reading it right now. But we're trying to get through it and talk through interesting stuff. All right, so we're going to stand up Aurora and RDS, and I'm going to choose a private subnet group for our database to live into, right? It's almost always the case that you want your database not sitting in public subnets by default, or sometimes it's called the DMZ or things like that. It is the crown jewels of your network and of your compute. Keep it safe. So let's go spin up an RDS server. Do I need to know anything else in here? No, I don't think so. All right, but I lost my AWS window. Oh, here it is. All right, so we're gonna come to RDS. I'm gonna use my nice little thing up here for RDS databases. I'm gonna create a database, full config. That's a new Express configuration. Do they want me to do Aurora or Postgres? I've forgotten already. Oh, it wants me to create the subnet group first. Let's go do that. So you can see here, a subnet group is basically for the databases, you tell it where it's going to be operating. So I'll grab you. Basically, because remember that those subnets are tied to availability zones. And so how many availability zones do I need to be operating in? And so it's a little obnoxious, but you got to specify it beforehand. And remember, don't ever use the default VPC. It's almost always a bad idea. We're going to add, I'm going to leave that empty. Oh, wait, can you? Or let's choose A and B, and then that brings up the subnets. Isn't that obnoxious? All right. Both the privates. Nope, not you. Private B. Boom. All right, so private A, private B, that looks good. That looks good. Check. We've got a subnet group. And then we wanted to create the database. Full configuration. Postgres. We do want Postgres. So go back up here, dashboard or databases, create a database, full configuration, Postgres, the Lord's database. Yeah, that's all fine. Dandy. I think that's fine. Does it care about? Chooses the engine. Did it give me an option to choose the engine? I guess I haven't gotten to that point yet. Templates, choose free tier. We did that. It's interesting. I don't see it. They might have changed that since when I wrote the course and if they had a little button. Oh no, the engine's down here. That's interesting. I wonder if we should update that or if it's gotta be, select the latest version. So I put a note here for me to come fix that. But Postgres 18 is out. So we'll choose that. Select free tier, did that. The database instance identifier. So we want database patient DB. Got that. Master username must be Postgre, self-managed for the credentials. And create a strong password using only alpha, avoid encoding issues, and save it. Make sure you've got this, okay? So I'm gonna put my super secret password right here. What should I do? Oh, what throwaway password should I use? I got to average, good enough for me. Fortunately, we're going to keep this database private, so hopefully no one can actually reach this database unless they're already within our network. And you know, if they're in our network, we probably have other things going on, bigger fish to fry. All right, password authentication, that's all fine. And burstable is fine. What instance class? They want DB T3 micro. DB T3 micro. Thank you. And storage, we want 20 gigs. And connectivity. Select don't connect to EC2. We'll do this later. Okay. Do this. I do not want the VPC. Don't use the default VPC, right? You're going to hear me say that. There's our DB subnet group. Do we want public access? No. The answer to this is almost always no, you do not want your database on the internet. And let's keep going. Create a new one called patient ping. So create a new patient ping, ESSG. And I'm going to say I don't care. Let's put an A. RDS proxy, no thank you. Certificate authority, that's fine. Database instance standard, I do not want to pay more, right? More performance insights, it's a higher cost threshold for the monitoring. Don't care, don't care. I'm gonna set an IAM role. We're gonna talk more about this when we hit the IAM section. DevOps guru, no thank you. Create the database. And let's see. Standard rather than advanced, disable that, that's all fine. Oh, well crap, did I skip some steps? Automate backup 1 day. So I don't think it's gonna audit us on it. We're gonna see if Zach just failed my own assignment here, but we can actually fix this here after the fact. Let's see if it actually checks what that database name is. So it checks the subnets, it checks that, publicly accessible. Boom, 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 boom. It all seems to be okay. But, you know, just to do it right, we'll go ahead and spin up another one. So you can see that this is gonna take a quick second for it to spin up. So I'm just gonna do here, say full configuration, and we're gonna speed run running through this again. Dev test, that's fine. Right, let's get full config. We want this to be free tier. We want that to be that. Don't care, we don't want extended. We want this to be something else. All right, so we need the name of the thing. We created the group already. All right, so here, patient ping DB is the instance identifier. It's not gonna let me. All right, we will try it with the one that we've got. Worst case, I'll have to create that database myself versus having it implicitly there, but that's not a big deal. So let's refresh this. It's in creating mode. Let's see if it lets us continue on. So I did finally create a database, wait for the database to come online. It can take 5, 10, and once it's available, then you can run a submit. Let's see if it actually check it. I don't think it actually checks it. Because I don't see, status of subnet availability, but we're not gonna be able to do anything until it comes online. We'll run this just for fun. AWS, exit. Gotta reactivate my thing. Actually, that's fine. All right, I'm gonna fire it. We're gonna see if it actually does, if I was smart enough to set up. No, I didn't. All right, so it doesn't actually care if it's online or yet. So we can see at least what the next lesson is before we get there. All right, now we wanna connect to the database. So to connect to the database, we're gonna need to talk about how does the traffic get from our server, right? We're gonna SSH that patient ping server, and we've gotta connect that to the database. And so it's gonna need its own firewall rules. We're gonna need to make sure that there's a route there that can get the traffic from A to B and make sure it works. All right, so there's one other concept specifically in networking where the term stateful or stateless is used, right? And so if state means in simple terms, like does it remember, does it have memory of something that's going on, versus stateless means it has no memory. A stateful firewall, traffic that is initiated on the inside, it goes through the firewall, goes somewhere, is allowed to come back. That return trip is remembered, right? It has that state, it has that brain to say, oh, this is that traffic that I sent out not too long ago, and it's allowed back in. Versus a stateless firewall, traffic can be allowed out through one rule, but unless there's a rule that allows that traffic to come back in, it's not gonna happen. So that's the difference between a stateful firewall and a stateless. It all means at the end of the day, does this thing have a brain? Is it remembering anything? Is it mutating some internal thing? And it's called state, right? Whether if you're doing development or whether if you're doing networking. It's just also used here. All right, so we got to set up a connection path for it. Postgres talks on 5432, so we need to allow inbound on 5432 to the RDS server. So let's go do that. So here's our server, and I believe there's a quick button where you can go to configuration, and our security group is not there. Maybe it's networking or security. Here, security. Here is our security group, and you can see each individual rule there. So I'm gonna click you, and you can see that's when naming gets kind of helpful, right? Don't be the guy that names every server and security group after a Ninja Turtle. Call it what it is so that you don't have to waste a whole lot of time looking up what these things are, especially if you hand off that network or you work with coworkers that don't have the same brain as you. All right, so this is for RDS, and so I want to allow inbound on 5432. So there's actually a Postgres rule, and so if I click that, you can see it pre-populates TCP in 5432. And then instead of IP address, what we can actually do is do the security group. So we can say patient ping, and I can connect this to my public, right? So servers that are inside this public are allowed to access it. But I don't know if that's what I set up in lessons, so let's go double check. Sure, outbound rules, so it wants us to check that. So there is an outbound rule, but it's not on this page. Let's check the inbound. Oh, this is the outbound on the other side. So let's save this and we'll come back. Preview, confirm. Okay, so now let's go to our instance and make sure the instance's security group. Let's also grab this name so I'm not confused and grabbing the wrong one. Did I get it right? Patient ping web v2? Come on, Amazon. That undoes it, that's unhelpful. Is that gonna take it? All right, so here's our server, patient ping v2. Let's go check what security group it's on. So I click on it by itself. I go to security, go to security groups. Here's this guy. And what we want to make sure is that can this server actually go outbound? And the default rule is still here. Usually, in most places that I've seen practically, most folks allow servers to go out and reach out to anything that they want to reach out to, right? This might be, hey, I need to go to NPM to download new viruses, right? Or I need to go to GitHub and actually pull and clone stuff down, or 1,000 different things. Is it wise? Probably not, but it comes down to what is the best use of your team's time, and you've only got so much bandwidth in your life for secure networking, right? And so allowing only specific addresses for your server to reach is a great practice if your team has time for it and there's a return on that investment. All right, let's keep going. All right, I'm gonna try to back up so you can actually see the top of my head. All right, so we do have this, that's all fine. Confirm the this, likely done. It's probably done. Add the necessary inbound rule. Navigate back to the, okay, and you can see that we do tie it to patient ping public, right? Instead of the IP addresses. So regardless of whoever has this security group tied to it, they will be granted basically 5432 TCP access to it. So that's all fine. And test the connection. So let's go SSH onto patient ping. Let's see if it's true. What a beautiful thing that SSH config is. if you don't take anything away. Oh, although, guess what? When I associated a new Elastic IP address for it, I did not update my config. So we've got to go do that. All right, so here's and you see my old IP address is still in here, 34 ending in 215. And let's go see what the actual external IP address for this thing is. So EC2, instances, come in here, and you can see it's got a 44 address. Let's go paste that in over here. Boom, save this, fire that. Now let's see if I can SSH onto this thing. And guess what? Am I gonna get the warning? No, it didn't get the warning because it's a new IP address. There's nothing that identifies that specific host or that specific IP address in our config. Let's go look, I'll go show you. Because our host name is tied to the IP address versus like some DNS name, it said, oh, this is a whole new host name. I don't have to worry about it. We're going to a different host. So that's why we didn't get the challenge. All right, so now from here, we need to go to the database. So let's see how we can go about doing that. So we need the URL for the database. Let's check the lesson first. So we did that. Oh, we're gonna go grab the Postgres utilities. Let's go grab that. Updating, that's all fine and dandy. Now we're gonna install a Postgres client. I wonder if this includes both Postgres and the client. Bring it all down, which SQL, does this thing exist? Yes, we've got it in here. 17.8 seems to match what we installed there. So that's all fine and dandy. All right, and so now it wants us to do this, right? It wants us to do it. You specify the host that we're connecting to, you pass it a URL, and then we give it the username and the default database. Now remember, I did not set up the database correctly, so I'm probably gonna have to update this and figure out what it defaults to. But we'll discover together here on the fly, right? It's good to see me tap dance a little bit. So let's grab this. So we come over here, PSQL, and we specify the host. And I'm actually just gonna go to show you guys an easy way. If you go over here and go to RDS, we're gonna close some bloat out. All right, go to our databases, go to the specific database instance that we're working with here. And you'll notice right here, connectivity, it gives you the dang thing right here. Actually, I'm just gonna grab this because doesn't that look nice? Oh, look at that, actually, and it gives you this command as well for this. I'm just gonna grab both these and we're gonna cheat a little bit. I wonder what database, oh, see, the default database name that it's gonna use is Postgres. So we're gonna have to create a new database within our Postgres environment. So that's easy to do. So got that. So could not validate that. Trusted roots. I'm gonna go back to my side. All right. Postgres, and we need that. So did the RDS host exist? And echo, boom, RDS host. Is that in there? No, it didn't take. Oh, there's no underscore. Okay, so we got that. So PSQL -h RDS host, and then what does it want? It wants the username, because we're using user password. Yeah, you happy? It wants a user for Postgres. Why didn't it take it? Or password for Postgres. Oh, that's right. All right, we got it. So we got connectivity to it. And we're connected. So let's also make sure that we stand up our new database. So stand by 1 second while we ask Google. SQL, Postgres, build, create new database. Oh, well, maybe I should take the boot dev Postgres course and I could, skip some of these things. What's it supposed to be called? Boot dev or patient ping? It's supposed to be called patient ping. All right, so let's drop out of it. So /q or other /q. And now let's update my command and let's make sure I can connect to that patient ping. So just so you know, a database can contain more than one logical database. So there's database, the idea of a server, and then database has like a section within that contains its own list of tables, et cetera, et cetera. So you could have a production and dev database on the same host if you wanted to, or on the same cluster. You don't need one-to-one in all circumstances. All right, so that's all good and dandy. Let's see if we can pass this thing. So grab you. Oh, not that so much. Let's exit. Fire that out. Check. Connect the app to the database. All right, so we have that web app. Remember that UV run patient ping pi, but we need to connect that to Postgres and let it do its magic. All right, so we need to jump onto this, and then we're gonna set an environment we're gonna create an environment variable. Oh, I said to use nano for this. See, that's no way to live. And we're gonna set a database URL, and we're going to embed that password in this connection string, right? So this is pretty common. Unfortunately for databases, there's other better ways to do it, but let's build the concepts and then we'll show you some of the better practices in the future. Good luck with them. That's kind of funny. Let's see, my own jokes are funny sometimes. Okay, so we're going to enter the database URL into that format. Okay. So I wonder if I can use an environment variable as part of that, because if it uses single quotes, right, it'll interpret it literally, versus if it was double quotes, it would allow extrapolation. All right, let's go. So where does it want this env? It wants to end the patient ping. All right. So let's do this. SSH patient ping. Let's go into, oh, I was curious. Oh, there you go. That's not too bad. Did I write any of this? Oh, Mr. Theo, doing good work. All right. All right, so we need to make a file. I don't have NeoVim, so we're gonna do Vim, or do I have, yeah. So let's do Vim, and we're gonna write an env file, and what's the thing supposed to be called? It's supposed to be called database URL. I'm just gonna grab all of this action. Database URL, paste that, and then my super secret password is bootdev1, patient ping DB, we set that, and we need the random ID that it generated right here. So let's go find that. Here is said random ID. Paste that in. Bada bing, bada boom. And let's run this thing, right? You remember how to start it? I think I do. UV run patient ping, and then I'm also gonna ampersand it so it shoots it to the background. And let's see if this thing wakes up. So database init, okay. Reminders table is ready. So I bootstrap that thing, and it's creating stuff. Perfect. So let's do curl localhost 8080. We get content back, that's all good. And let's see, oh, I did make it accessible to the world, right? So I should be able to hit it. Let's go grab it. And if I go here and I say, I want to do that, and then port 8080. Look at that, database is connected, internet egress, okay. We're generating stuff. Patients are being pinged, pings are being patients. All right, so let us go back to our lesson and we'll keep going. Did I accidentally close my boot dev? Oh no. Oh no. We'll have to figure it out. So we'll go back here. Oh, and I gotta do it in the right window. All right, I want cloud computing. I want to jump down here to RDS, jump here to connect app database. I want to click here to copy the command that I don't want to remember anymore. And I'm gonna jump over to 4 and fire it over here. Boom. RDS, storage, and IOPS. When you create RDS instance, you choose the stop. All right, so we're gonna talk about storage, right? So usually the good rule is go cheap to start with. You can change storage classes as you need to, right? It's not too painful to, even if you need to clone the thing and move it to multiple things. But it's important to know, general purpose, GP, right? And 3 is the 3rd generation of this, is almost always the good use case, right? You should almost always be using this as your kind of default basis, right? It comes with baseline performance, 3,000 IOPS input output operations per second. And it's hard, right? You go to your vendor and ask them, hey, how many operations does my application do on a regular basis? And there's a threshold of company size where you have to be active to a certain scale before you actually are gonna really care about these things, right? So be monitoring, and you can actually look in RDS, right? We turned off some of the nice components of it, but in the database itself, you can get some pretty good information on the metrics of how many operations you're happening on the actual database that you're using, right? So if you see the number of operations going up and then like peaking, oh, my CSS isn't playing nice with it. But basically, if your graph is going like this and then flat lining at the top, right, for number of operations that you're able to perform, you probably might know, hey, what is the limiting factor that's not letting this go up and not letting it perform more action? Is it CPU pegged? Is it memory pegged? Is it disk pegged, right? It can't perform more operations because literally the disk is saying, no, you've got to wait in line until I've got more operations that you can consume. The other way that you might see is like the dreaded sawtooth, right? Where you see something like this, where it's going up and down, where sometimes it gets stuck, but you've got this pattern where you've got thrashing that's occurring that's not able to kind of get to the spot where it wants to be. Versus a more normal, right? You're gonna see spikes in normal operation, but then you usually see kind of nice peaks and valleys and maybe even sustain, but not quite at that limit, right? So look at your metrics, use that to determine what type of disk that you need. Don't shoot blindly, right? Vaporware or building out for scale that's not there yet is almost always a bad architectural idea. All right, so general IOPS, right? This is gonna be on an SSD. It gives you IOPS a good consistent amount, and it scales up with the amount of storage that you provide. Provisioned IOPS is like, nope, I know I need this much storage at this exact speed, and you can just set it artificially. And then there's also another one for like disk based as well too that you can opt into. So Know that. It's way nicer than what we'd have to do in the data center days of like striping disks together and then mounting it and then hoping none of these things fail, and what kind of RAID controller are you using and what type of RAID. It's nice to just have a dial that you can turn up and turn down. All right. When should you use provisioned IOPS? When do we need to like actually set a specific amount of performance that we need? When you need guaranteed predictable input output. Seems simple enough. Let's keep going. I do like this go. 1 is done, 2 is 1, right? Who was that? GCP Gray or someone's told me that. Backups are important, right? If your environment and if your recovery story needs to be able to say, hey, if Virginia falls into the ocean, we still need to be able to operate. How does your architecture handle that situation? And backups are only beneficial if someone is actually dusting them off and using them on occasion, right? Otherwise, it's just kind of a little bit of theater, or it's paper compliance, which is the worst thing in the entire world. So daily backups, transaction logs, retention, storage, and the cost of these things, right? Backups can be expensive. Are you pruning them? Are you retaining what you actually need? Do you want 365 daily snapshots, or do you want 1 monthly snapshot retained for 7 years, right? Or something like that. Get your standards written down somewhere and then perform to that component, right? Don't make them up as you're going. So for RDS, right, you have the full database snapshot saying, hey, I want to be able to roll back my entire database to this specific point. And then the transaction log, all changes that have happened since, right? So databases have a concept like a write-ahead log, which is essentially a ledger of saying, hey, I know exactly what I'm doing from this point, and I can replay those transactions as needed to get to that point. And I'm not the database administrator. I might be using terrible, wrong terms, right? I need to take the SQL course. So take what I say with a grain of salt. Restoring from backups, right? That point in time saying, hey, I can roll the entire database back to a specific point. But remember that sometimes that's not what you want, right? If your developer or someone has corrupted a single table in your database, or there's a section of records that need to be restored, generally what you'd have to do at that point is build a database, a brand new database based off of your snapshot or off your backup, log into that, and then transfer those specific records over to your new database, right? If you don't want to do the entire thing, you've got to kind of finesse it a little bit more. Restore to a new instance, right? Are you dropping this thing onto the original instance and you say, hey, just roll the entire thing back, go as quickly as possible, or are you going to have to come back to it? So what is the primary advantage of RDS automated backup with transaction logs? At each point in time within the retention, not to just backups. I think that's the right one. Yeah, Eso que preso. All right, read replicas. Read replicas. So why would you want this? Why would you want a read-only copy of your database? Why is there more database administration in our life than what is absolutely minimum? The idea is that there's going to be more consumers of your database in some use cases than there are writers of your database, right? The idea of Slack, there's lots of people that are reading messages, but you read 30 more messages than you write, hopefully, right? Unless you're a particularly chatty person, right? And so a read replica allows us to basically have a spot, a place for database, for if you need to interact and you need to consume information from the database, you have a place that's a read-only copy that you can pull information from, but it doesn't slow down our ability to write. And this can be helpful. Like we did it once for a customer that they had a big database, a large data set. It was expensive to operate. And sometimes our readers were way less important to the business than the writers were. We needed to be able to write information to that database at a high priority at all costs, right? Get it into the database as quickly as we could. And so a read replica let us do this. We pointed all of kind of our front-end users to the read replica. They would be able to get to the database. It would generally be fast, but no matter how much they hammered that thing, it would never prevent us from writing to the database and getting there. All right, so what does it want us to do? So obviously, if it's a read-only replica, you can't do the write operations here, right? You're doing selects, not upserts, not these other things. We talked about this. Or you can also stick them in different locations, right? It's like getting the data closer to the user is almost always a noticeable benefit. Well, can be a big improvement to the application. Create a read replica. Okay, for our guy. So let's go do that. You got to go to RDS. Don't need you anymore. Boop. And where is the read replica option? Boom. Can I just do this actions? Oh, no. Where is that thing? Database actions create read replica. Oh, it is there. Okay. I'm just blind. So I think it's patient ping replica. It seems reasonable. DB3 mind call. Use east one. One instance, please. IPv4, not public. Oh, I wonder if it wants us to make it publicly accessible. It wants us to put it in the private. So this would be a replica that only we can consume. Does it want us to put in RDS? Yeah, we're going to stick in that same security group. So the same rules that apply to our main database are also going to apply to the read replica. But note that you could put a different one. I want these people to be able to reach the read replica and these people to be able to reach the real database, right, that's sitting behind it. Stick that in 1A. It's using that same subnet group. It's all good. Password authentication, standard, retention period as low as it goes. I don't want that. I don't want that. Copy tags. That's fine. Great. Now let's see. Did I forget anything? Wait for the read replica to come online, but let's see if we actually check it. I don't think that we did. Oh, look, but I do check if you made it public, so don't make it public. I'll fail you on the test here. So grab that. Let's fire this thing. Oh, do I need the sounding? I don't think I do anymore. We'll just go over here. So fire that. What did it fail? Status code 0 got a 255. So it's not pulling the full information. Oh wait, no, it's just a credential thing. I'm gonna add this. Now will let me do it? Now you're gonna fail me again? No, first try. I'm not gonna win any streaks. So if you guys are watching me for the hot tips on how to get every problem right on boot, it's not gonna be here. Delete the read replica now. Optionally clean up the rest if you're taking a break. All right, okay, Zach. Could you at least have had us mess with it for a little bit before just creating it and deleting it? All right, that's going away now, so that's good. Delete the read replica. We did that. Option do this only if you're taking an extended break. Okay. All right. There. Which of the following resources costs nothing on its own and can be safely left in place? The security group doesn't cost. This costs. Elastic IP addresses cost. They didn't used to, and EC2 instance costs. So, boom. All right, identity and access management. So how do you permission AWS? How do you manage what can person A access? What can person B access? How do servers interact with AWS? How do you permission these things? How do I make sure that I don't, go to jail because I've leaked everyone's private information that they've trusted me with? IAM is a big portion of it. And it's really not the worst system that I've seen, right? You can do way worse than what IAM is going to do. It is complicated. There are terrible machines and authentication systems that you can build with IAM, but you can also build pretty good ones that aren't terrible to manage, ones that do generally keep you safe. And that's what we're going to try to do here. I'm going to try to give you some of those tools for doing that and not hating yourself or hating AWS because of it, or at least you can hate me for it. All right. So IAM does two things, right? The authentication, who are you? Are you who you say you are? And authorization, great, Zach. I trust that you are Zach, but guess what? What is Zach allowed to do? What are you authorized to perform based off this role? So, makes sense? That's the two things that IAM is trying to solve. So there's users, right? This represents an individual, right? This is like me logging into the system. There's groups. We're saying, well, that's great, but if there's 10,000 employees that all need AWS access, how do I interact with them? How do I make sure that I can set one set of policies and that applies to everyone and I don't have to assign policies 10,000 times and potentially miss someone? And a group is essentially that. It's a way to group those permissions and assign them to tons of people automatically. And if you're coming from Active Directory or if you're coming from lots of different kind of things, this is going to sound pretty common to you. And then the policies themselves. So I'd say, okay, we have the users, this represents people. We have groups, which might be like a group or a container of people. And then a policy would be an actual thing or permissions that you're allowed to do. That makes sense? All right, and then there's this idea of roles, right? So a role is one of those temporary credentials that you can give to something that's not a person or give something a task, but it's meant to be a temporary means of accessing an environment. There's no credentials that are tied to it. You have to be trusted through it, through a flow, like there's something called OIDC where I can trust you because of the keys or because of the website that your traffic comes from. Or I can trust you because you are an EC2 instance and AWS is able to assert that says, yes, this is the instance that it claims to be, or this is a Lambda, and so it's allowed to use these permissions or this role that's been attached to the system. So users as a person, group is a group of users. A policy is a thing that gives you access. It's like, what are you allowed? It's what are you authorized to do? And a role is something that is a group of permissions that you can use for a period of time. And it might be given to a person, right? A user might assume a role, And I'm not flicking you off there. That's the ring finger. It might be a user that's assuming the role, or it might be a machine or a service or a Lambda that's using those permissions for a short period of time. Now, why would you care, right, if it's a short period? Well, what if your service gets popped, it gets hacked, and it grabs all the keys? If those keys happen to be all roles or role tokens, the worst that they can do is the damage that they can do for a short period of time. They're not going to be able to live or dwell in their environment for a period of time. Versus if they get your administrative credentials that are tied to your user, there's no guarantee that those credentials are not going to live for a long time. And that's often the use case, is that an attacker or a bad actor will try to get into a network and to stay silently inside that network for an extended period of time, slurping up whatever information they're able to do. So, shorter lived, less exposure. Is there anything else in here? Okay, I've got a nice little breakdown. What is the best practice for giving an application server? All right, so we're going to be trying to key in on a few things. Giving an application server access to AWS resources like S3. So we're talking about AWS stuff, so IAM is definitely going to be at play. And we're talking about not a person, but a server, right? And so servers are going to be using this side, right? These roles, these temporary tokens, instead of these long-term person-based identities. So we're not using inline attached to the EC2 instance. That's not a thing. You can't attach policies directly to an instance. We're going to use an IAM role, right? Okay, that sounds right. And a trust policy. A trust policy is the thing on the role that says who's allowed to use this role. And it provides temporary credentials. That's another word for a token, a short-lived token, without long-lived passwords. And that's exactly what it is. Hey, look at that. I got a chest. Let's keep going. Did something happen here? Oh, I still need more XP. We're not there yet. We got more work to do. All right, let's make a new user, and each user gets a username and password or API access to. You technically can create a user that doesn't have a console password or API keys. Like often we do that for folks like, hey, so-and-so left the company, and so you leave their user account there, but you disable all the access is an option. So users are these long-lived identities, and what are we gonna do? Vincent Vega is new on the dev team, and we definitely don't want to give him root access, right? We want to make sure he knows what he's doing before he potentially, destroys the company. Seems reasonable. We want to create a user. So we're creating patient ping admin Vinny. So let's go create him. We're going to use our trusted search bar, come to IAM, and jump in here. We're going to create a user. There's my Zach admin that we're using before, right? I did promise we'd come back to IAM. And I do not want to give him an administrative access. So we're not going to put him in this group, right? Because remember, everyone who's in this group has administrative access. So no. Next. And create. Must contain only alphanumeric characters and dashes. Did I miss something? Oh, did I put a space on the end of it? See. All right, thank you, copy and paste. If only it did some client-side validation, right, and prevented me from doing that. All right, we got Vinny created, and did that, on set. Don't do anything. All right, yeah, we did that. All right, click that, fire the hole. I don't think we need the web server up and running. Invalid character name, looking for A at the beginning of the user. It's a jerk. All right, I'm gonna go ahead and we're gonna kill. I wonder if we still need the server. I've forgotten, but I'm going to exit the server regardless, and I'm going to run exit again, and I'm going to AWS Vault boot dev, and I'm going to say no session. And does this work? AWS STS get caller identity. Okay, that's working. And now can I run this? Do not pass go. Do not collect $100. All right, and destroying my streak once more. I wonder if there's a way for us to make sure that, hey, you can't fail for like failing the credentials, but you can only fail for these later steps. Lane, I've got good ideas. I've got good ideas for the CLI. All right, next. Inline policies. All right. So this is something that's common and it's regularly used. We're going to talk about what it is and then why you probably shouldn't be doing this. So policies allow or deny access or actions, right? Remember we talked about authentication. Who are you, who you say you are, right? You need the secret passphrase in order to get in, or you need a trust policy. And then there's the other side of what are you allowed to do, right? And the policies are what defines what you're allowed to do and what you're not allowed to do. And so you can see here, it's just JSON. It's JSON with my comments in it, which isn't real JSON, but the formatting still looks nice. So you can see, basically, it's a list of things, and each one of these things has an effect. What does it do? So this is allowing us to do something. Okay, and what is it allowing us to do? Anything inside these brackets. Right now it's letting us describe, and you notice that it supports splats or asterisks, and we can set dynamic ranges. So this lets us do any EC2 action that starts with the word describe. So this would be most of the read operations, but not all of them, right? There's like lists and there's view and there's some other ones in there, but this would be a lot of the read-only properties. So seems reasonable. And then what are you allowed to do it? So not only are you allowed to say these specific APIs, but you might say these many APIs within the US East 1 region, or within this security group, or within these other criterias. And so you can kind of compose these how you want to. The Zach's special recommendation to you, the listener, try to only use allows whenever you can. Try to use a separate administrative account from their normal user account, right? Have the user say, hey, you need to use this super admin role when you need to do those super admin-y things, and this is your normal user for when you're doing normal things. That way you've got beautiful logs that document how users are working with AWS, and if a user is regularly doing something that they're having to jump to their super admin user, one, you didn't block them, right? They can still do the thing. And two, you've got a quick log that you can go look at and fix their regular access and think, hey, is this something a developer should be doing on a regular basis? Regional things, regional people. All right, let's go to. Talk through this, talk to this, talk to this. All right, so it wants us to go in here and it wants us to do this the wrong way. All right, so we'll talk about the inline stuff later. But let's build the policy and then we'll talk about why you might want to do it a different way. All right, so we got to go to Vinny. And it wants us to throw this policy in. It looks like the one we just looked at. So I'm going to add a permission. I'm going to say create an inline policy. I'm going to just give me the JSON, paste that in, and save it. Is it working? Did it think? Did I have validation? Okay, there it goes. We need policy name. Okay, boom, boom, boom. Okay. All right, so now we've got this. He's got a policy name attached to him, and it is attached to this user. What did I put in this tip? Oh, look at that. Okay, so you could actually put it that way too. All right, let's keep going. Paste that. All right, we passed. Okie dokie, let's keep going. IAM groups, right? So remember groups? Groups can only contain users, even though I really wish they could also contain roles. They can't. Only users, so these are people, these are long-lived credentials, and it's a way for us to set a set of policies on these things. I love how I put Lovelace and Carmack, although I'm in a different group, so maybe I'm in a different category than some of these smarter people than me. So inline policies basically attach those rules as a singleton, this is the only place that this rule exists, and it's attached directly to that user. That user is deleted, the policy evaporates and goes away. What did that user have access to? I don't know. Does 6 people need that same policy? You have to write 6 copies of that policy. It's a pain. And it's hard to find, and you've got to check 7 different places, right, to see what the access are. Like if someone asks you, say, hey, what access do all the developers have in the environment? If you have to go check every inline policy to answer that question, you are not going to enjoy your morning that's going on. So the alternative, right, not inline policies, is to do a group. You create a normal group, you attach the policies onto it, and it applies to everyone consistently. You need to make one change, you only have to change the policy that's tied to the group and not everywhere else. It's all good things. Your CISO will sing your praises, Lane will praise you for good security practices, and so on and so forth. All right, so we got to create a customer managed policy. So let's go do that. So instead of IAM users and these inline policies, we're just going to go here. Policies, create policy, choose a service, and I'm going to choose, what is it supposed to do? It's supposed to be IAM? Yeah, I want JSON. That's the name of the policy. I need the JSON, ASO, paste that in there. Beautiful. And here's the name of the policy itself. No spaces this time, that's good. And then I imagine it's going to want us to create a group. And notice they're called user groups, right? It's denoting that you can't stick a role in there. And what does it want us to create? Readers, okay. And back to naming things, right? Name it what it is. Don't get fancy with your naming. Your name should convey information to the reader and understand the context that they may be operating in, right? So if your developer is looking at your group, can they tell what that group means? Versus if you start naming it after famous directors or painters or things or Ninja Turtles, you're going to be in a sad spot when you got to go fix stuff. All right. So I got readers, and I'm going to add Vinny to the group, so that's fine. And then I need my customer managed policy. And there's my EC2 readers. I'm going to attach this, and I'm going to create the group. And it's going to create the group, it's going to attach the policy, it's going to throw the users in there. And I think that's about all we have to do. So we added the user to the group, and then we need to remove the inline policy. All right. And this is why it's obnoxious, because you got to click on every individual user. And you see, here's the inline, here's the group-based policy. Goodbye, boom. All right, good, boom. And let's fire this. Did Zach break my credentials today? I work. Roles, right? So roles, short-lived tokens meant for either users to assume to do something in a temporary fashion, right? You assume into it and you get a short-lived token, and it can be many hours long. You can configure how long that thing lives. But it also permits you to perform those functions that are attached to the role, right? Perform those actions that are authorized by the policies that are attached to the role. It's not rocket science. Policies let you do things, right? And you can put a policy on a role just like we were doing with a group. But you can also put a role on an instance. Did I show you guys that? Or you guys might have noticed it in the earlier lesson. Oh, did I delete my instance? No, I didn't. In the security section, or is it in the general? Let's find it. Oh yeah, right there. So you see IAM role here. So you can actually take a role saying, hey, I know that this web instance needs to access S3, or it needs to talk to SMS for configuration parameters, or some other thing in AWS that it's doing. You can create a role and attach it to the instance itself, and you don't have to perform any OS configuration, and that server will start to be able to exercise Bodo 3 Python commands, or you can even run the AWS CLI, and it will just work automatically because that role is attached to the instance itself. It's super handy, and it's all short-lived tokens. Someone pops your server, they literally can't get a long-lived credential out of that server by like reading the environment variables and things like that. Now, if your role allows them to create new root or new God mode users, right? It doesn't actually help you all that much, so you do have to be somewhat smart about it, but it's a great thing. It's use it and be happy. All right, so what are we gonna do? So we talked about this, creating a role, assigning the role to a trusted entity, like an EC2 instance, so we do talk about that. The entity can assume the role, right? So the server, hey, I need to do some stuff. Says, let's see if you're on the trust policy. Okay, and that does have to be on the trust policy of who's allowed to use this role. So that's all fine and dandy. And then here's the trust policy, right? So you can see it looks a lot like a normal policy, but instead you've got this principal directive, right? So the principal says who is allowed to use this thing. And right here, we're specifying if you are coming from AWS and you're from the EC2 world, so this is not Lambdas, this is not RDS or CloudWatch or 100 other services that are out there. But if you're coming from EC2, you're allowed to do this thing. And what are you allowed to do? You're allowed to assume the role that this thing's attached to. Make sense? Assume it like I'm gonna operate as it, I'm gonna use it. All right, so we're gonna create a role. Let's create this patient ping read only role, and let's use it. Oh, jerk. I gotta reset it. All right, so I need to go to IAM. I see the button, I'm choosing that. Usually the search bar is the better option. Go to roles, I'm gonna create a role. I'm going to say this is to an AWS service. That seems reasonable. Oh, like I can choose that. We'll see what it does out of the box. And I need to attach my policy to it. Customer managed. Now what this is going to do is it's going to, when you choose one of those it's not doing anything fancy, it's just pre-building that JSON for you with probably what you need, but you'll see it's almost always easier. I almost always just paste in the JSON because I've written it once. So you can see, okay, what's it doing? The principal is EC2. Someone from EC2 is able to do what? Able to do these actions, which is assume the role. All fine and dandy, but I need a name. Select patient from policy. All right, it's just called that. That seems reasonable. Yeah, he's got the policy. We're going to create the role. Okay, I'm glad I didn't delete the server because we need it. And we're going to put this role on it. So let's go do that. Maybe I should, read my lessons and not just go ad lib through these things when, I thought about this before and tried to make good use of the time. But I got to fill all this loading time that, Amazon's Mr. Jassy has put into my life. All right. So I need to set, and a role is going to be a security action. So I believe it's in here. Yeah, there's modify the role. And once upon a time, you couldn't actually change the role that was associated with a VM. That was fun times. You wanted to change the role? Guess what? You get to build a new server that day. So there's our role. Attach. And what do we say? It gets to We can test it out just for fun while it's loading up. Let's go, so SSH onto patient ping. So I did it. Do I have AWS? I think I do. AWS EC2 list instances, describe instances. Let's see if I can remember that. Like that. So you see, I didn't have to do anything. There are no permissions on this machine, but if I do AWS STS get caller identity, what are we gonna see? Do you have any guesses? If I type correctly? It's a difficult thing. It's a difficult thing typing. You can see I assumed role, and you see that patient ping automatically got attached. And not only that, but on all the audit logs, it puts the instance ID, this unique identifier for this instance and this instance alone, saying I asked to do this thing. And it's off the races. And so I can't do things like give it a policy that would let it do S3 things. It can only do those EC2 describe things. And it works great. Out of the box. No fuss, no muss. All right, let's fire this. Did I get it right? I got it right. Boom. Oh, I got a treasure chest. Look at that. So I can't do anything for 6 hours. That's true. Deny policies. All right. Deny policies, try not to use them, right? With great power comes great frustration, great confusion on why on earth this thing is not working. Add just the permissions you need progressively when a user asks for it. Don't just give them star access to everything and then deny what they don't need. Amazon tomorrow is going to introduce some new service that has really expensive APIs that your developers will try messing with and spending all sorts of money. Or maybe you will do it on accident and not realize you're doing it. Deny rules are not good. Have an allow list, put the things that you want on it, and maintain it. All right, so what is an explicit deny? The denies are kind of like Windows permissions, right? Where a deny overrules any allows. So if you had a rule that says, hey, you are allowed to do X, and then there's also a deny rule that says you are not allowed to do X, you wouldn't be able to do it. The deny would win over any rules attached directly to the user or on the group. Okay, okay. Use least privilege, right? This is a big security concept of saying give people the access for what they need and nothing more, right? And try to reduce it. Audit, look at the permissions that you're providing and try to make good guesses on this is what they're doing and this is what they're not doing. And there's even things like the identity access manager that will tell you on a per role and per user basis, hey, this user has this rights. Did they use it in the last 6 months? No, they haven't. And so you can adjust it and build those profiles to fit your users without having to go, talk to every single developer in your company. This is also helpful for like, hey, those permissions I just gave to the server, right? What if someone pops that server and it tries to interact with your AWS account? And there's some things that you do want that server to be able to do, but does that server need to be able to create new admin users or spin up new servers that could host a new fleet of Bitcoin mines, right? And all sorts of things. It's just a little bit of caution goes a long way and will really reduce and really frustrate someone that worked really hard to hack your machine. Okay, see? And Lane's even making my point, right? The instance is compromised. What can they access and how do you lock them down? And in this case, right, if you had a user that you say, hey, I just need to fire axe absolutely everything, a deny rule would be actually a really good way of solving that and getting it in place. So that makes sense. So create a deny all policy that we can attach. So let's go make that policy and attach it to our read-only role. Okay. So IAM policies, create a policy, and JSON me, and I want the policy content. So I should just say, so you see what action, all actions, what resources, all, and then what is the effect? It's not allow, it's deny, right? Paste that in here. Next. And what do we call it? Deny everything. That's the SID. What's the name of there? No spaces. And great. Customer manage. And what's in here? Yeah, that looks like it. And we want to attach it to this role. Oh, it's going to do what we did in just a second. Okay. Jump on here. And what's the name of that role that we made? Oh, it's this guy. All right. So let's say add. I'm going to attach a policy. This would be an inline directly attached. Oh, I guess it's a role. So the policies are always attached to the role itself. So customer manage, deny all. All right, now watch this. So if I jump onto the server again and I say, okay, let's do our AWS EC2 describe instances. Look, everything works fine and dandy. But now when I attach this policy, gonna give it 5 seconds. 1, 2, 3, 4, 5. Oh, it still worked. Come on, Amazon, you gotta make my point. I mean, maybe it's a little too fast. Oh, there you go. See, second time's the charm. And maybe it takes a little bit for the propagate. Amazon's a big shop. They can't get everything right the first time. But you see, it did not take long for that policy to take effect. Those short-lived tokens did not take a long time to flush out, but we can dynamically remove that with just one deny policy. And that's really not a bad use case for it. All right, we attached it, we did that. And can you run describe instances? That's basically what we did. So let's run the command, not on the EC2 box, but on my machine. How many more do we have in this? Oh, not two. SSM parameters. SSM parameters, I think, an underused, underrated AWS thing. Basically, what if you had to have some shared configuration, or what if you just needed to store some information? Like, what if you wanted the date or some kind of version stored or some piece of information that you need to be able to update when you need to, but not have it baked into the instances themselves. And SSM, right? SSM is a system state manager. It does a lot of things. It'll do auto patching. It does version detection. It does a lot of things, but SSM parameters is a really simple and free for most use cases key value params that you can access, right? You need to set a specific environment variable or a specific setting for your application to go fetch. SSM parameters can be permissioned on a per parameter basis or namespace, and to be able to set those at the AWS level for all applications to use and respect. And so it's nice. It's like a quick way to get kind of feature flag kind of implementations into your environment. So they say, what examples? Okay, should it run in debug mode? What domain name? Where should it send logs, right? It also lets you update things kind of on the fly, right? If you want that kind of behavior. Oh yeah, so it's like things like setting environment variables. So you can say it uses paths, right? So you can see, we'll talk about this when we actually create it. It's kind of like S3 where it's like you can set namespaces, which are kind of like folder paths or things like that, to group different sets of SSM parameters together. And this can be helpful because when we do our IAM permissions for those SSM parameters, we might want them to be able to access some of these things, right? You might need the DB endpoint, but you might not want anything that's in secrets. And writing all those IAM policies by hand individually would be really painful. But if you can make assertions about the rights on the namespace or the group of SSM parameters, it gets a lot easier. It'll make more sense when we're going through it. All right, secure string type, versioning, right? This is also nice. It's like, hey, what was that set? Like the application was working a week ago. What changed in the last week? Having versions baked into all your configurations with SSM params can be really nice. Okay, so we're gonna create a database URL. That seems fine. Oh, and I bet we're gonna bake this into our application. That's right. Foreshadowing. All right, so let's come in here and let's create an SSM param. So over here, go to SSM. All right, parameter store, and I'm gonna create a parameter, paste in our name. Oh, there I got it. Don't paste it 3 times, please. Boom, create a parameter with that name. Description, do I need one? No, and the value. Oh, we need our thing. I just want string, yeah, not secure string. The value, let's actually do this. See that SSH config already coming in handy. All right, grab you. So instead of setting this as a file baked into all of our environments, which seems lousy, let's bake it into this SSM parameter. So come over here, paste that there. Great. That seems glorious. Done, done. We need another one. CMO name. Chief Medical Officer. Seems reasonable. All right, great. That seems fine. We want standard. We want string. Dr. Strangelove. Parameter. Let's see if I got it. Did we get it? Did we get it? Did we get it? First try. Got that? What does it want us to do with it? SSM parameters are strings, right? So, this is important, right? So if you have bools that you want to put in your configuration, it's not as nice as JSON or YAML that might be able to do some type assertions for you. Everything is a string. You put a 1, that's a stringed 1. If you put a true, that's a string that contains the word true. You put nothing in there, and it's going to be open and closed quotes that you're going to see inside your application. Yeah, oh, look at that. And I'm just restating. 5 turns into 5, true turns into true, 3, 14, right? It's all that. You can even shove JSON in there, right? But you can see it's going to escape some of these things, so it'll actually still be happy as a string. So be cautious, especially about those special characters that you shove in there, and make sure that you know that the application is sanitizing and parsing those correctly. Marshalling, right? Depending on what language you're in. And guess what? They're free up to 10,000. So go eat your heart out on how many SSM params that you want to create for your, learning experience. Typecasting, okay, so I talked about here, it's like, hey, what if I want to convert this, right? We say, hey, go fetch what I put in secrets and shove it into this secret stir, right? And then I've got the raw port number here, right? This would be a string that gets stored in this variable. And then I say, I want to convert this. Can you convert this to an integer? Can you cast it? And if that works, great, it's going to work. Or does it throw, right? Because that thing didn't actually contain the number that you thought it would. If you're coming from more an operations background, this might seem a little more esoteric, but it can be absolutely critical in how you write your applications, and is your application going to function, and what can you put in here to make it useful and expected complexities. All right, you retrieve SSM parameter, it has 5432 stored as string. Your application needs to add 100. So you aren't going to be able to do an add operation to a string, right? When you try to do that, it'll just bolt the 100 to the end of the string, and that's not what you want. So you'd have to turn this into a number. You'd cast it just like what we did here. After this point, you would add 100 to the port or 100 to whatever that number is, and then you would have an integer. But then if that integer needed to be put back in SSM, you might have to do something before you do that. All right, so let's see. No, this is absolutely false. SSM parameters require special arithmetic. No, this is false. SSM are always strings. You must convert it to a number. Yes, that's what you want. Accessing the SSM parameter. All right, so now we want that EC2 instance to be able to access those SSM params that we just made. So we're gonna make a policy that allows them to do what? The actions are get the parameter, right? Read the string out of it, and they list all the parameters that are available. And you notice what we did here? We specified the parameters that they're able to access. And what's in here is the database and the CMO. So if we created some new, or if we have a typo in what our SSM parameter is named, this permission would not authorize us to access those other things. So, seems great. Let's grab this, and we want it to be called, it seems reasonable. So this is like the name spacing if you wanted to group these things together. And here's the actual thing that it wants us to do. So it wants us to go into that. It wants us to remove the deny all. That makes reasonable sense. Let's go to IAM. That was on the roll, right? So it would be this guy, and then goodbye that. You can now do things again. It doesn't want us to inline. Oh, look at that. See, I'm already inlining right after it told us not to do inlining. I'm sorry. I should have been more disciplined. Create inline policy, JSON, boom, next. Policy name is this, created, and it needs the read-only and the EC2, okay. And it's got 2 policies on it. That seems reasonable. I'm just gonna run it. We're not gonna test this one because it seems pretty similar to what we were doing before. Look at that, and that all worked. So use SSM from the EC2. So now that we have access to it, but we haven't actually proven or done anything with that role. So remember the pinger app is there running, and right now, we jump onto the server. Right now, it's not using it. It's using that .env file, right? That's hard-coded and can't change dynamically, and it's reading that each time. But I'll bet if we remove this thing now, is what it's gonna have us to do, we can tell the application to instead use SSM parameters. And how are we supposed to do that? So we deleted that env file, that environment file that hard-coded that connection or that configuration into the application at the OS level, right? Remember, if we had destroyed that server and recreated it, it would have lost that .env file that existed there. So our application was stateful, right? It had a memory of something that it needed in order to operate. And we just turned it stateless when we make it read from SSM. That all seems reasonable. We did this, we already have it running. I guess they just have to delete that env file. Oh, okay, so what it's gonna try to do, the application's configured to go to SSM first and then go to the env file. That seems reasonable. Actually, let's go look at it, because it's really not rocket science. Patient ping. So you can see here, there's a fetch SSM config, and it comes in here and tries to fetch this thing. And if it's not able to do that, then I think it loads the env files. So you see there, say, hey, I wasn't able to load the env files. And then it says, okay, if you don't have that, then please go to the OS, go get the environment, and this probably loads, there's probably a .env on the top. There, you see right there? So right here, it loads that .env file into the application, and then it starts doing it. You don't need to know that, but just know that that's how the application was plumbed to look for SSM first, right? That wouldn't happen for free by itself. Okay, so I think I just need to start it. So let's go back over here. Let's go patient ping. Let's just UV run patient ping. Is that what it is? All right, I can't do it because it's already in use. What's the thing called? There it is. Killed Python there. And now we are going to start this thing back up. I ran it, so I had to do a little extra ceremony there because I ran it in the background thread, so I had to go find that thread. That's that pgrep I was looking for. Hey, where is that Python running somewhere? And let's see. There you go, loaded from SSM, DB init. Okay, reminder table's ready. So I think we're good. Okay, let's go here, booyah. Entonces, we got cleanup. What a wonderful thing. IAM and SSM, before moving on, we need to remove the main RDS instance and optionally clean up any cost driving things. So I am gonna wrap for a few minutes here. Let's go clean up some stuff and you guys can walk through me. I'm gonna clean up the EC2 instance and the RDS. EC2. All right, U actions, terminate, instance state, terminate instance, skip, which makes it go faster. That's wonderful. RDS. And RDS is going to give us lots of prompts to say, are you really sure you want to delete the database? Which is helpful when you're dealing with, real databases that would, would end companies as they exist if you accidentally deleted these things. But I'm okay with patient ping going under. I'm not going to retain the backups. I'm not going to create. I'm going to acknowledge. And I'm going to not type delete me. Instead, I'm going to copy paste it, and it's gone. Anything else that we spun up? IAM stuff is free. Security groups are free. VPCs and subnets are free. Internet gateways are free. I think we're ready to go. Let's answer this question. In this cleanup, which lesson required delete even before continuing? So we deleted that already, but this one was brand new. Oh, the elastic IP attached would have to be deleted too. Even if you're continuing immediately would be the RDS one. Okay, so we're gonna come back to monitoring here in just a few minutes. All right, next chapter is monitoring. Let's dive into this. So this is gonna be chapter 6, V1, monitoring is a big trust of software at scale, right? So this is a big portion of kind of the more ops side of DevOps and kind of how it operates and how it works. Like, how do you know when you need to do deployments? Can you react to things that are going on? Can you increase the number of servers? How do you know your servers are healthy? And monitoring is kind of the answer. It's how you make wise decisions and kind of measure, prove that your software is performing like you think it should be performing, or if you need to respond to it. So getting monitoring right it's not hard, right? It just does take a little effort, right? And it's not a attractive thing to spend time making sure your logs come through in a healthy way, right? In an ideal world, your software works the first time, but inevitably it doesn't, right? And you need to figure out why it does and have tools that help point you to the exact thing that's going on. So let's talk about monitoring. So some of the drawbacks of monitoring and some of the things that does make monitoring a little annoying to deal with, right, is too sensitive, right? Do you have a lot of signal to the noise that's going on with your system? Is it sending notifications? Is it alerting you when it actually does matter? And it's hard to test. It's hard to replicate fail scenarios, right? In different applications, throwing in different parts of the application. Do you have the details to actually make that thing useful, right? And so we're gonna walk through some of these things and how to make it worthwhile. All right. So your patient ping, ensure the app's monitoring is actually useful. Let's say it should only alert when needed. It should have, I didn't mean to hit enter there. It should include details like a trace or transaction ID, so you can tell what part of your application is actually being worked. And we should be able to test the alert system and simulate failure modes, right? There's a reason we test our code, and see if Boots is happy with that. Boots is happy, let's keep going. Monitoring targets. All right, so until we have something to monitor, we need to set up an EC2 instance. So let's go do that again, and then we have to get this up. So boom, and we're online here. So we're gonna do this. Basically, we're gonna build an instance, and then we're gonna install the CloudWatch monitoring utility on it so that it can heartbeat and send information about our application up to AWS, and we can take a look at it. So let's use our launch template again, because it's got all of our settings kind of pre-cooked, and hopefully you're getting a little bit of a vibe that says, hey, it's nice to have these things ready to go so you don't have to build them from scratch each time, if I can hit the right number. All right, actions, launch instance from template. We want one of these things and launch. All right, so that's cooking up, and we'll come to our instance list so we can see when it comes online, and we'll need to update the IP address associated with our SSH config, right? Because the IP address does change, right? It grabs a new elastic IP address, or does it? No, we have to add the elastic IP address. So let's go get ready for that. So we'll see if I saved my other one or if I did a good job cleaning it up. Oh, it is here. All right, so let's grab this. Let's associate elastic IP address with our instance. And I don't want that, and I'm gonna allow it to be reassociated so I don't have to like do extra steps if we ever want to use this thing again. Good. Go to instances, and let's go ahead and just update. We'll just double check it right quick. There's our SSH config, and let's see what it was. Yep, that matches. Let's see if we can access this. Okay, yeah, see, hey, that IP address we've identified is now tied to a different host, and it's saying, hey, are you sure you want to do this? Yes, we are sure we want to do this. So I'm going to grab the command, say, yes, it's trusted. And now, oh, mercy. Let's not regenerate SSH patient ping. Yes, the fingerprint is okay. All right. Well, if I can type it, or sudo. Yeah, here and there. So we got this, we got EC2, and it wants us to confirm that the VPC lives and such. So I think we're good to go now that we have an instance. So we'll drop it here. And, oh, I'm not logged into AWS. So that's my fault. AWS, this is on Spiff, so I need to jump over here, I think. AWS Vault exec, boom. Exit out of that, we'll get a new one. All right, sorry, so let me check my AWS credentials. Yes, it is, and it's using that Zach admin account. So now let's see if I can submit. And it doesn't say it, so it wants a tag with name patient ping web v2. So let's go, okay, and you can see we don't have any name. So patient ping web v2. Did I get that right? Yes. All right. Now let's see if you're happy. Boots with that. Not patient ping. Oh, did I add an extra? It'd be nice if it showed you this shit. Yeah, see, I added an extra dash there. Yeah, let's see if that's happy. Save that. So now it is patient ping web v2. I think that is right now. Let's see if that happens. All right, first try. Let's keep going. So we got that. External monitoring. With an EC2, we can get some monitoring data automatically with no charge. So these are basically anything that we can look at it from Amazon's view of the hypervisor, right? There's some things that Amazon just has to be aware of and it can view from the outside. How much of the CPU you're utilizing, how much bandwidth is coming in and out, right? Because those things inherently talk to the hypervisor, say, hey, how many cores am I allowed to use, and fancy things of like, do I need to burst? And so the hypervisor is aware, or Amazon's aware of some of those things without any tooling of the instance whatsoever. And sometimes that's all you need. It's like, I just need to know if this thing is pegged or not. And so if we come over here and we hit monitoring, you'll see it's gonna start gathering here. Oh, no data yet available. Let's see if we can view this somewhere else. So we'll come here and let's do view and view metrics. Sometimes this updates a little quicker, but it can take 5 minutes or so for this thing to come online. And that's where that enable enhanced monitoring, right? If you need this period to jump down even less. Yeah, so this is gonna take a little bit to cook. Let's see if it lets me do it. How much did CloudWatch metrics, yep. And is my server doing anything, right? You can see if you have a server that's sitting doing literally nothing, which is a great way to save money. So what does it want us to do? Create a dashboard and force CPU usage high, verify the spike, and then stop. Okay, so we're gonna actually simulate some load here and see what's going on. So let's create a dashboard. So we'll go to CloudWatch, dashboard. We're gonna create a dashboard. Does it want a specific name? Yes, it does. Grab that. There's our new name and metrics. And does it have a specific, we want line, EC2 per instance. Line, EC2 per instance, CPU utilization. There it is. CPU, no, there it is. Boom, create widget, save dashboard, and we want to occupy a core. So what this yes command does is it basically, I just run it, it just pipes Y over and over and over and over and over again. And this gets used in like some bash scripts that have like, hey, I want auto approve on all the settings. And so this thing just fires Ys at it until it exits or something else stops it. And to be tricky, right, for me right now, I'm in the SSH session and my Control C isn't actually getting in time before the Y. And so you have to click it really fast to be able to cancel the process and then exit out of the loop, right, that command is piping or creating. So you can do it sometimes. Sometimes you just got to kill the SSH session. But yeah, so that's all good. So let's SSH to patient ping. And we're going to generate this load and just dump these Ys to dev null, right? So into nothingness. But we'll be able to see that it's going to be consuming a lot of resources. So if I go to patient ping here, and let's just take a look at it this side, you can see there is my yes command, and you can see that it's just chugging away, right, at 93%. Basically, it's producing Ys as fast as the CPU will allow me to do it. And because this thing doesn't even have to wait for the console to like print out the various characters, it's all going to dev null. It will consume literally as fast as the CPU is able to produce Ys, it will generate them. Kind of panicking. And you can see like the load average is stepping up over time, right? This is the quick average over a few minutes, and it goes on. I always forget the increments there, but this is the most immediate, and this kind of gives you the running average for longer periods of time. All right, we've got some yes load, and let's see. Keep loading for at least 5 minutes till it shows a clear state. Once you're satisfied, you can hit Control C to try to escape it. And let's see what this does. This is just going to check if the dashboard exists. So let's refresh and see if it's actually populating. No, it's not, but I don't think I really want to wait just 5 minutes for this thing to load up. It does what you think it does, and we showed that the load is showing up on the system. We'll see it as well too, because we're going to be poking around a few other areas of logs as well. So let's go ahead and run this thing and we'll see if it lets me pass or if we got to cool our heels for a bit. Oh, not that one so much. Let's see if that's working. Yes, fault. Exec, thank you. Exit that. All right, let me pass. So we'll keep going. Internal monitorings, right? So we talked about things that Amazon can tell about the server without any other knowledge of the server itself, right? Because they are operating the actual hardware, and the hardware has to be aware of the CPU utilization and has to be aware of the networking that's coming in and out of that guest VM that's sitting in that virtualized hardware. There are some things that are the domain, the operating system manages and maintains it, right? And so if it's something that only the operating system has the concept of, things like disk space or the usage of memory and how that's getting allocated out to applications and what's being used for swap and what's not being used for swap. Anything within the application has to be used. There has to be something within the OS that surfaces that information up to CloudWatch so that it's able to interact with it. So disk usage, application logs as well too. So if you write a thing and it's writing heartbeats to it, using an agent on this, right? And CloudWatch is just one agent that you could use, will allow us to view that information and plot it on a graph or view it inside CloudWatch or query it or all those things. So here's some alternatives: Grafana, Prometheus, all good stuff. And we're going to be using CloudWatch agent, which fortunately comes installed by default, I'm pretty sure, on all the Amazon Linux boxes. So that just makes it nice and easy. But we're going to have to grant a role, right? So remember, we just finished up the IAM section. And if we're going to interact with AWS APIs, there has to be some basis for the instance to do so. It's not granted any special access by default. The external ones work because it's external. There's nothing that the instance is doing to interact with those APIs. It's just running. But in order for the instance to basically package up logs and then ship them to CloudWatch, it's going to be using APIs and then using some type of role or instance or keys that let it do so. So we're going to build the role, we're going to install CloudWatch, and then we'll start and make sure that the agent is up and running. So let's do that. It wants a role called patient ping monitoring role. Let's go build that. Hopefully this is a little refresh for you guys after we just finished up the other kind of role creation. I'll just say that for now. I'll say, we can do this. So this will let EC2, right, the trust policy that it kind of cooks up for us, will have what we want on it. And let's just skip this for now. Put the role name in there. You can see that by default, it's allowing the EC2 service to use this, right? So when we put this on our instance, it will be able to use this role by default and no keys will be needed. And consequently, like if these things get leaked, if it's not running on an EC2 instance, it won't have any benefits. All right, so here's the APIs. What actions do we need to perform? These different CloudWatch things. And then it also needs a spot to interact with. And so we're gonna allow it to interact with different CloudWatch groups, I think is what the term, or log streams, that it's able to store these things in. So let's go do that. I just want it as inline. Name the policy that, add one more inline. So I think these are supposed to be inline policies. So boom, and we will go to policies, add permission, create inline policy. We're gonna paste JSON, paste all that in. Next, and this thing is called, that's that. Delete all the starter and paste in the following and create the policy called this. Okay, let's call that. And then add one more inline policy for this one. And so, okay, so it's gonna be reading the SSM params. I already did this, so this might not be necessary, but maybe because we're switching the role, it's not automatically granted those SSM parameters that we had previously. Well, we'll add it in here just in case it does the check. So create a new inline policy, our JSON, just to make our lives easier. That's not what I wanted. I want this. That goes in there. Hopefully is valid JSON if I can write JSON correctly. And then here is the SSM access. So remember those SSM params is basically configuration that the EC2 instance can access. And that's all good. And that's all good. And then we want to jump to change the role for the instance to use this thing. So we'll go to instance. And I forget what role we had on this thing before, or it was like a read-only role, I think. But we will adjust this. I wonder if the launch template actually had that on it. So it's security, right? Because we're modifying the permissions that this thing can have is why they stick it in here. Modify the IAM role, and we want the monitoring role, right? Yeah, boom. Let's create that. All right, so it should have that. And then it wants us to jump in and install this agent. So it does look like it's potentially not installed by default, but is something that we have to do. All right, so I already did that. So sudo DNF upgrade. DNF is a package manager. It's also used by Red Hat. You'll see it pop up a lot, but essentially it's Yum with nicer kind of dependencies and what repos that you're gonna be doing, or at least that's the intention. All right, that's all fine. Let's upgrade, right? So this pulls a new list from the repository of saying, hey, what's the latest updates? And we obviously need sudo. Only the administrator is allowed to do that thing. So we did that. Now we need to install the actual binary. And grab it. See, it's 68 megs, not tiny. That's probably why they exclude it by default. And then we need to come and edit this file, which allows us to do the configuration. So grab you. And for you who are watching, I would not spend a lot of time like memorizing this JSON and how it looks. Almost everyone is going to be looking, unless you're dealing with this stuff all the time and like tweaking it, in which case there's probably a nicer way to do it, but the documentation is going to be your friend. Look at the permissions you want to do, follow AWS's pre-cooked recommendations. You're probably going to find that it's pretty simple and pretty plagiarized exactly how we configured this for how Amazon wants us to do it. So read the friendly manual whenever you get the opportunity. All right, so this is a new file that we're creating for it. So we can just do that. So vim, a new file. We need the content. Let's grab you, paste that all in. Am I gonna have to create the prerequisite files? Jerk. So first I have to make the directory that contains this thing. Not that so much. Make dir, including all the parents so that I don't have to create each individual folder one at a time. And I just want to create this. Boop, that's created. Now I should be able to vim this. Now I need to go grab the content again. Boom. And we'll paste this in. Oh, does it have to be root? And I probably said that in my documentation, didn't I? Yeah, you see that? So it wasn't the fact that the folder's not existing, it was the fact that I was not operating as root. All right, baby steps. And I guess that makes sense because what are we doing? We're saying this agent, every 60 seconds, it's gonna do something. It's gonna run the process as root, hence the sudo, right? Where is it going to be storing stuff? And so we specify that. var log is super standard. What's the log group name? It's gonna inject in, like these are little template variables. It's kind of, I forget what, is this Jinja or mustache? I forget what the syntax for this is. But you see this replaces this with the instance ID. It is interesting that the instance ID has a different way of tagging it than these ones do. I wonder if that's actually gonna work or if it's gonna use that literal string. We're gonna find out together if I found a bug in our course here. The auto-scaling group, okay. And it's got some other stuff in here. I think that's all gonna be fine. So let's start the service and it should give us a command. So we have the thing installed, but it does mean it's actually running. And so here we're gonna start it, which actually like boots up the process. And then we're going to enable it, which basically adds it to the startup targets for the system, right? Basically saying, hey, when you start up, basically once you reach the spot where we're spinning up user space of the actual users, not like the drivers or the hardware interfaces or things like that. But when we're ready to support users, we want you to start this thing up so that we're capturing any logs that those users or processors are generating. And then it wants us to do this. Okay, so we're gonna jump in. We're going to run the Python script, and we're gonna send the standard error and the standard out and append it to this file. And this T will also dump it to our console so we can see what's going on. Let's go here. We already had that. So actually, I don't think it'll hurt anything. It could not go to RDS. So I think I destroyed the RDS endpoint. That's right, in the spin down, but I'm not sure that RDS is actually required. Maybe we just need to remove that var so it doesn't expect the database to exist. But either way, we'll have good logs for us to reference, and we'll see if we need to bring it back online. So that's good, that's good, that's good. And let's see if our log group is up and running and see if it's collecting anything. So go to CloudWatch, and that's the AWS logs, log management, log management, and there she is. Seems hopeful. There's a log stream with the instance ID, so it does look like that's working just fine. And do we see, oh, look at that. We're seeing the same stuff that we're getting in our standard output here in our CloudWatch logs as well too. So this is nice. If the server is destroyed, right, or some other administrators working on the thing, none of those logs are on my machine, or I have to go look at the history or go like pull what was in the terminal. It's all preserved here, and this is going to cost near nothing, and we're ready to go. And it's nice and safe and easy. Just knowing that this exists and that it's not too painful to get it up and running, and that the tools that you have are almost enough to set up very decent baseline logging from the very, very start of your project can really differentiate one developer from another, or differentiate one cloud engineer from another, just saying, oh yeah, that's no big deal. We can work through the primitives and kind of know what's going on. All right, so we're done here. I think we can fire this thing. So let's go over here, go over here. Let's go fire this, see if we pass. Oh, it didn't like something. So it wanted a role name, patient ping monitoring role. And did I typo my role name? It's gonna be the bane of me for not naming these things consistently. So I apologize to you that I did not make the JQ a little bit more friendly for walking through these things. Patient ping monitoring role seems to match. I didn't like it. Running command, it got a list output. And it's looking for just the first instance. Do I have more than one instance in here? I don't think so. This is looking at patient ping monitoring. So it's looking at this string here. Is it showing me the actual command that it's running? Let's grab this. The nice thing about this is that there's no magic here, right? You can see the exact commands that we're using to actually test the services. And then it's piping that to JQ. Let's see what's going on here. Okay, so it's asking for, is there more than one instance? Let's take a look. So I think there's only one instance, and then it's coming in here to instance profile, patient ping monitoring role, patient ping monitoring role. I feel like that should be working. Oh, let's try again. Still getting it. So AWS IAM, so it's trying to fetch this role in step 2. So I was checking the wrong role. Okay, and I know it's going. The credential that I used for AWS doesn't have IAM roles, IAM permissions, so I gotta do this. So there is some restrictions on what you can use temporary credentials for in some circumstances, and now you can see it's working. So that's my issue. And it's not magic, right? You can go through and run the exact same commands that we're running to check the work under the hood, and we're up and running. CloudWatch alarms. All right, so it's great that we can gather things, but we don't want to be staring at logs perpetually depending on n number of servers or applications that are running. So having something that can just tell us when we need to pay attention can be nice. So our metrics, let's set up automatic actions to be taken. Our service is an auto-scaling group of 1 to 10 servers, and we just hit 10. We have a service emitting a high number of 500 errors. One of our servers is at 95% disk usage, right? So all these things are saying, okay, someone needs to intervene, something's going on. If the server is throwing 500s, right, server-side errors, is it a cascading problem? Did it get it in a locked state or something else? And sometimes just looking at the error or restarting that server or replacing it is enough, or you've got to actually take interactions. Or you need to scale up, right, where you hit the max number of servers as allowed. Do we need to do something, or are we up and running? Oh, okay. let's go get our free chest. Oh, we're chewing through it. All right, so we're gonna create an alarm that triggers when we go above 20% CPU utilizations and hit an email address. Seems reasonable, So we need an alarm on CPU utilization. So that's gonna be in CloudWatch again. And once this loads, we'll go to alarms. You can see I've got none built right now. We're going to create an alarm. We're going to do classic. We're going to select a metric. We're going to go EC2 on a per instance basis. And it wants CPU 20%. CPU 20%, 1 minute static. All right. So we want CPU utilization, metric name. All right. There's a few different instance IDs we can key on. So let's go find the right one. I was right here, right? I think I had it in describe instances. And here's our ID, 805. So you can see that not only like CloudWatch persists after any single instance goes up or goes down, right? And so you have any instance that I've created on this account will still live in CloudWatch and still it gets aged off by default. All right, so that's all fine. We want greater than, what is it? It wants average, 1 minute, greater than, and we said 20%, next. And then an alarm state notification, if it's in alarm, we want to inform an SNS topic. Oh, are we not doing other step? Just doing the alert seeds 20%. So I think that's good. All right, so we click that, and then we're going to test the alarm here. Okay, so I think I can just do this. We're not hooking it up to send us an email as of yet. Oh no, we are supposed to create a topic. So configure in notion. Okay, so we gotta go back. So where's my notification? So we're gonna create a new topic. We're gonna call this, does it want a name? Yes, it does. Okay, it wants an email address. We'll do cgates@level.work. Simple enough. Finish create topic. Okay, and I think that's going to do it. And the alarm name, boom, next. Beautiful, create an alarm. And we're in warning now. Okay, I guess that's just a warning. So it's insufficient data is the state of it, but it's showing a warning here because this is going to do something. With endpoint that is pending confirmation. So do I need to confirm? It might let me just keep going. When you first create alarm, it may show insufficient data. Okay, that's all good. Okay, that's all fine. Let's go generate some load. So we got to get it into an alarm state. Okay, that should be generating some. I'll check it here, make sure it's actually doing the thing we think it's doing. All right, so I can see the yes command is running and I can see lots of good CPU utilization. So we'll let this chooch for a little bit. And after a minute of it gathering data, now the instance is only going to send data on an interval. What do we say on the aggregation period? Was that 1 minute? Now let's go check. vim/opt, AWS, Amazon CloudWatch, and there was Etsy for configuration details, and then there was Amazon CloudWatch D, right? And so anything gets put in these .d directories, basically show all of these as independent parts of the configuration. So, all right, so every 60 seconds, root is going to send up information about the metrics that it's gathered up and it's ready to go. Okay. So we can let this chooch along for a little bit, and with the magic of editing, it'll probably snap like that for you guys, and I will be stuck waiting here for a bit. Okay, and once it's going to check, it's going to describe the alarm. So I don't think the check is going to be looking for the alarm to actually go off. So let's see if we can pass this thing. Oh, I can't do it there. Gotta do it here. Oh, not there so much. See if that passes. We can keep going. We'll let it alarm in the background just so you guys can see it. But if we pull this up, we should see it starting to, yeah, you see that thing starting to climb, right? It is an average, so it's going to take it, not just the first one is going to be able to trigger it. So let it keep chooching. CloudWatch is great. Oh, CloudTrail, right? So now we're switching from information about my individual servers and what the server is doing and logs that I can generate for myself and stick into a CloudWatch group or a log stream or lots of different things. But what if we want to know the answer? Who is interacting with my AWS account and what are they doing? And the way that AWS solves that is with this CloudTrail, right? It is a specific type of audit logging for interacting with AWS APIs. And that can be helpful, right? What if an attacker were to jump into your account, create a brand new server, hammer your API, right, using some temporary role, and then delete the role, delete the server, and leave with whatever information they managed to scrape. And CloudTrail would be that spot where we could say, hey, show me all the AWS API commands that are out there, and show me a good authoritative log. And authoritative in quotes, right? There are some things that don't always guarantee you will have 100% CloudTrail coverage. And there's also disparities on how quickly from action to visible CloudTrail log it will happen, right? Sometimes you'll get orders out of events if you're watching it really closely. But 99, well, nigh 100% right of the time, CloudTrail can be an authoritative record of what actions are happening, when they're happening, and who's trying to interact with your AWS account. So I'm going to come in through. So it's like anyone that's calling the AWS API, describe instances. Basically every click that we're doing along the way in the console is triggering one to many of these things, right? Just look at this. If I inspect, if you pull this up, right, there's nothing magic about it. We look at the networking tab, and this might be too small for you guys to see, so I apologize for that if that's the case. Let's see, I can make it a little bigger. But basically, if I fire a refresh on this, you're gonna see lots of different, some JavaScript stuff, right? Let's go to XHR. Is it helpful, right? There's evaluate, right? Some polling, but all that to say, right? Stuff that's not hitting the CDN here. There's lots of interactions with the API to pull down the information that you're trying to render in here. So, neither here nor there. Let's keep going. So what is CloudTrail? CloudTrail is focusing on monitoring performance health. No, it's not. It's telling you what's happening on AWS. It's focused on audit action AWS users in our account. Yeah, that seems right. CloudWatch are both focused on monitoring. No, CloudTrail and CloudWatch are basically the same thing. All right, let's keep it going. Great, we get to clean up. So we're gonna wanna go kill the alarm because you do pay for these things. And you can see this thing did trigger into alarms, so that's good. So actions, delete, boom. Let's go delete our dashboards you also pay for. I just cleaned up for a project of mine of hundreds of dashboards that were being created that no one was looking at, and no one realized that you're getting dinged per dashboard that's in existence. Go clean up those things. All right, so we did that, and we did that. The log group, let's go kill that. I'm not sure this will actually work because as soon as I delete the log group, I think it's gonna recreate it. Yeah, we'll try it because it's asking us to do it. Delete the log group, boom. I guess we didn't give our instance the ability to create log groups. Some applications will create a log group if it doesn't exist. Now we got to delete our SNS. So we created this within that CloudWatch alarm widget wizard, but you'll see it listed in here. Hey, there's a topic in here. Grab this, you can delete it, pass the client-side validation there, and we're going to delete the monitoring role. I was being pretty thorough in the cleanup steps, but it's really not too bad. You just got to click through it. Let's see if it'll let me delete this while it's actively attached to something. Will be a fun little thing. Yep, it does. All right, stand by just 1 second. All right, so got that, and we're only if you're planning on taking an extended break. That's not us right now. We're gonna keep cruising. And that's optional as well. All right, which resource should you not delete if you're continuing? This guy. The other guys are all fine. Awesome. All right, and we're on to chapter 7. So we're going through DNS. So how do we connect? So we've used an SSH config here, right, to kind of pretend to do DNS, right? But if I do NS lookup patient ping, right, or anything like that, it's not gonna work. We've been using that SSH config to basically give us something that's easier to remember than these random IP addresses and to pre-cook some configurations into this. And that's kind of the same concept of what DNS is doing. I'd like a memorable name to be able to associate our resources to. And the other kind of secret power that it lets you do is to route folks to traffic or to a location that's relevant to them. If you want to route people to a server that's close to them, if you want to replace an old server with a new server and have that be transparent to your clients, DNS can be a great way to make that happen. And with that, right, with that power also comes a few ways to misconfigure or misuse or to fail at DNS. And those things that were sending your traffic to the right location, if not misused, will send your traffic to the wrong location. And so it gets a lot of flack for that potential, right, of no matter what you do, if the clients are going to the wrong server, there's nothing really you can do to get them back online and up and running. So we've got a AWS provided DNS name. So this happens by default, and you can see it on instances as well too. Oh, let me stand up a new session here. So we come to our instance, you'll see there's a setting when you spin up the instance, or it might be at the VPC level, where you can say, please give this thing a DNS name by default out of the box. And you'll see they take a very pragmatic approach to what they name these things by default. Let's go look. So this is the name, right? This is just for us, but if you come down here, you see the host name, right? It gives it a memorable host name, well, semi-memorable, of the IP address. It's an EC2 server and internal. And you can actually use this to talk from one EC2 instance to another, right? It's another DNS name, right? See, private IP DNS name. And the purpose that this is private, and can you take a second and kind of figure out why would this be a private DNS name, or could you figure out why this would be private and not public? Well, the IP address that it resolves to is a 10.0, right? This private IP address, we talked about RFC 1918 of some IP addresses being restricted and only used for private environments. And so a DNS address that resolves to this isn't going to be routable from anywhere besides the VPC that we're operating here within. And so that's the purpose of the thing. But we want an address to point here, right? This public IP address, this elastic IP address that we've put on here, and for people that hit our address to be able to go to the right thing. So let's see the steps that they have us do. For a real company, we're going to bring all right, we're going to have a boot.dev, right, address that we can point towards our servers. So, and that's what Route 53 does. It lets you kind of register this, and then we can set up DNS against it. And it tells you like, okay, you can also do the things for email records, right? And there's also authentication that you can do to say, yes, I am in fact the owner of this site, right? Here is an SSL certificate or a stub that you can bake into the address itself to say these are trusted servers or untrusted servers. And so we use DNS to kind of help with that as well. All right, well, so what does it want us to do here? So internal host names, so these are the .internal. Create a Route 53 private hosted zone. So private is going to mean that this isn't available to everyone. That's what it's intoning. So let's go create that. So we're going to jump to the Route 53 service, which is kind of AWS's DNS management. And we're going to create a hosted zone. Hosted zones. Oh, you know what? And I also thought, wouldn't this be fun? Boom. All right. So we're going to create a hosted zone. And we are going to create patient ping internal, private hosted zone, and create. We need a region, this east one, and we need our VPC. Don't use the default. All right, and we've got it created. And we've got a server of authority and a name server, right? And you can see that each of these actually use a different TLD or top level domain, right? .org, .com, .net. Okay, I think we're good. So jump this. Big. Blast that in there. All right, we're gonna keep going. All right, A records. DNS records tell the world where the domain points to, and the most fundamental is an A record, right? So A records take a name and turn it into an address, right? That is the most basic thing that can exist, right? There's other records that we'll talk about here in a little bit, but an A record is this simple one. It is a name tag to say, if you want this, this is where you're supposed to go. And you can know that it doesn't have to be necessarily exclusive in the values, right? Two addresses can point to the same server. And this will happen a lot, right? If company A acquires company B, right? Oftentimes what they'll do is they'll point company B's main address, main URL to company A's address. Say, hey, if you want this company, we actually acquired them, go over here, right? And they send all the traffic that was going to that other company and send it to themselves. And that's a pretty normal, happens every day kind of thing. All right, so that's all fine and dandy. You see this @ sign, that's an important one, right? This apex domain. And I will let you know that Route 53 specifically does let you create an A record at the root, at the 0, at the apex record, but many DNS providers will not let you do this. You have to have some IP address at the very top of your domain that you own and is consistent and doesn't change very often, right? That's tricky. And so Route 53 is actually kind of a nice thing, right? To just solve that for you, to let you put in something dynamic and go on your merry way. All right, VPC, select patient ping, action, and we're gonna edit the VPC settings, okay? Basically, we're gonna make the VPC aware of this new private zone that we just created and then enable those DNS host names that we were talking about a moment ago. Boom, actions, edit VPC settings, isn't it here? Enable DNS host names, thank you. Network address usage mechanism, no thank you. Okay, we got that turned on, and then the other thing, select private zone and visit details, and we're going to create an A record. All right, let's go back to Route 53. How many steps back do I have to do? I'm just tabbing back. So we're back in Route 53, hosted zones. I clicked on my internal one that I just made. We've got to create an A record. Okay, so it wants www patient ping internal, but notice that the only thing that we're adding, this part is a part of the hosted zone itself. So any address that we create in this hosted zone will have this as a suffix. So we only want to add this www part. And you can see it kind of reflected here as well too, where it shows patient ping internal. So if I do www, you see that it added that sneaky dot right there, that period. And so you can create an Apex record that would be nothing in this, just anything that's going to patient ping internal, or we can add this and it secretly adds that dot. And we call this a subdomain of it. So that's all fine. And we want to point this to an address, a private IP address in your VPC. Like that. It wants 15 seconds and create records. So I should see this here. So there's our record. You can see that it does look correct. It's an A, it's pointing to 1050 like we've asked, and we'll validate and pass. Let's keep going. All right, DNS, time to live, and caching, right? So one of the superpowers of DNS is that it has caching kind of built in as a primitive of the format. If you're sending 1,000 requests to a game server or to a web chat or something like that, if you added a check to some external server saying, hey, what's the address for this thing? What am I doing? Please tell me the right thing to access. That's going to add a network path, right, a there and back again to every single one of those requests. And so caching, asking one time and then asking and using that cache aggressively is a huge function of what makes this still that you're not paying a huge penalty on the performance of your applications when you use DNS. So you run it once, and then you refresh it. But the time to live is something that we can configure when we set up DNS. And so you can communicate to the people using your site how often do they need to double check that they have the right address. If you have a super static application, or say it's a landing site for some like conference, right? We're gonna set this up one time and it's never going to change ever again. Having a TTL that's crazy long is perfectly fine, right? You can use that cache and tell the clients to say, don't ever check back again, this is never going to change. But it gets painful where what happens if you make a mistake? If you set a really long time to live, you tell your clients, hey, cache this for days or weeks or months, and you change the address. There's a typo that you have to go to a different host. Your IP address changed. You are then at the mercy of all your clients updating the cache at the interval that you told them to do before they're going to be able to access your resources. And so I think it's really important that you think about this, right? Of setting a low TTL can be nice if you're worried about it, right? So generally the rule is start low, come back in a week or two, and then set it to the real value that you're going to want it for a long term. And the other kind of big rule is be patient, right? That these things can take a little bit to propagate out and to be available to clients and for clients to start accessing the new one. All right, let's keep going. You pay per time that Route 53 responds back, right? Per million addresses. So for our scale, this is going to cost nothing, right? But just be aware of that. If you've got a popular site, this TTL is set really low, you're going to be paying the piper or Mr. Bezos to make that happen. You want to update a record. It's got a 3600, right? So that's a 1 hour. So you got 1 hour. Why still users use some old IP address for up to an hour later after your update? So that's not right. It has to do with the TTL, right? That caching. No, cache the old record for the TTL version won't query. Yes, this is it, right? So when you set that TTL to 3600 seconds or 1 hour, you are telling anyone that's using this address that don't bother checking for a change in address for up to 1 hour. And so when you make a change, it's going to take that cache time until it does. All right, dig, NS lookup. Let's go look at this thing. So we have this, but its name is only accessible within, right? Remember, we chose private DNS and we set up DNS within the VPC account. So let's go test to see if it's working. So we're going to jump onto this, SSH, patient ping. Do I have dig installed here? Let's see. Oh yeah, we do. So if I run that, you can see that that 10.50 address does in fact show up when we ask for it, right? That it was able to resolve it. And yeah, it doesn't look like we even need to do the install. So that's it. Let's see if this just works. Beautiful. CNAME records, right? So this is where it gets a little bit more complicated. Like, what if you need something fancier than just a sticky note that points to, or a sign that just points to what the server is? And that's where CNAMEs come in. CNAME records point to either some A record, right? Which is essentially an IP address of a server. So it's either going to point to a server or it's going to point to some other record. right? And so if you wanted to group people by east, west, right, and be able to funnel them to a set of servers, or if you wanted to send them to a load balancer, or if you wanted to have different ways, right? It's a very common thing in like WordPress setups to have multiple domains pointed to the exact same website and to group those things together. And so based off of the address that they resolve to render different content to them. And these are some of the workloads that you can set up with a CNAME work. So let's see, it wants us to make a CNAME, right? So it wants us to point to some other record, either a CNAME or an A record, point to some other domain name like www short links. Okay, so let's do that. So we'll come over here, and remember, when we're inside this hosted zone, we can only control this side of the equation. So this will be links.patientportal.internal, but you see it's asking for an IP address because we have not flipped this record type to a CNAME. So routes to some domain name, or AWS has fancy things where you can send this directly to an AWS resource. So we'll send anyone that asks for links.patientping.internal, we're gonna redirect them and fire them off to here. And does it have a TTL that wants to be sent? Oh wait, oh actually that's the example, that's not the actual assignment, so let's not save that. Okay, so we came in here, oh it wants to do blog. So we'll do blog.patientping.internal, and then we're gonna send this to the www route. Okay, that doesn't make sense. So anything that comes here is gonna get redirected to www patientping.internal. What's the TTL it wants? 15 seconds. Oh, that's recommended, not a floor. That's good. And create records. So you can see that we have our CNAME record and say, hey, anything that goes here is going to go to this address. So it's going to say, okay, go to www patientping.internal. It's going to go to patientping.internal here. This is an A record, and so we're going to have the address of the actual server. So if you hit this address or this address, you will both go to this 10.50 if we've set things up right. So let's jump onto this, and we're gonna dig the blog. All right, and so you can see that it did in fact get an A record. So even though we came here, it went to blog and it said, hey, this is a CNAME record, I need to go to this address. It went to this address and said, hey, this is an A record, and I'm gonna go to 10.50. And so that chaining is happening exactly like we intended for it to do. So that's great. Let's run another test, and it passed. Beautiful, let's keep it going. So we need to clean up compute resources we've been carrying through early chapters. So that web server, we're gonna finally bid adieu to. So let's go blow it away. So instances, close this, instance terminate, and, oh, I should check this box. Too late. All right, go away, refresh. This should update, initialize terminating. So this instance dropped it, and so we should see this in the shutting down. Just so you know, there's a default filter, right, that says, hey, I'm only gonna show running instances. And so if you don't see something you expect to in this little analog, click this, make sure you don't have any filters that are running. All right, it's gone, and it wants us to release the Elastic IP address. Remember, Elastic IPs are in EC2 for reasons that are unexplained, indiscernible. So I'm gonna drop this thing, and you release the IP address. And it's important to note that once you release this, it can be picked up by some other AWS client, right? So if you're doing things like sending email using this IP address, just know that someone may have ruined the reputation for that specific IP address before you ever had a hold of it. Or if you set up all your firewalls to trust some random IP address or some Elastic IP address and then you release it, now someone that you don't know may have the IP address that has the keys to your kingdom. So be wise, keep it up to date. All right, we did that. It's gonna check to make sure that those things are gone. Describing instances, beautiful. S3, so this is one of the first AWS services that was in existence, right? It has to do with storage buckets and object storage, right? There are an entire class of data that you need to store or regularly need to store, that you need to be able to store a lot of something, and that the access of that something doesn't need to necessarily be fast, right? I am writing archive images. I'm creating logs that may or may not ever need to be used, but I need to have high assurance that we've got them in case we need them. And I don't want to fill up the disk that the application is using, right? And so S3 basically, like EC2 is metered or rentable server capacity. S3 is rentable storage capacity. You can throw basically as much as you want on it for all intents and purposes, and you will just pay by the gig for as long as you need to hang on to it. So, simple storage service, Slower, but very scalable. And it's using objects, right? It doesn't have a real file system. There are some utilities like Fuse and other things where you can kind of fake a file system onto S3, but it's mainly just you pass in a key, it's gonna send you blob information back related to whatever was stored under that key. There's not even real folders, right? If you poke around a little bit, it's just fancy names and what's under that name. So here's server storage and serverless storage, right? And we access it all through an API. And this API is one of the better ones of Amazon, where this has kind of become the standard or the kind of basis for a lot of other object storage providers out there. You'll see S3 compatible storage or utilities or applications all the time where people build it for this, and it's not even just for AWS, it's for several other providers. Okay, bucket names have to be globally unique, right? So if you spin up a bucket, until just recently, where now they do let you kind of tag an organization bucket where that is namespace for you privately, that bucket has to be not the same as every other person in the entire AWS ecosystem, right? There's an interesting article not too long ago where like some training application accidentally said, hey, store your demo data to this public S3 bucket, and someone else actually built that bucket and was getting all these random tutorial files uploaded to their bucket because there's one bucket for that name and that user happened to be using it. It's cheap, 2 cents per gig, right, per month, and it gets cheaper as you use it more, and there's cheaper storage tiers that we can talk about. So what's the primary use case? File-like data objects such as PDF, that seems reasonable. No, it's not for containers. No, it's not for compute. No, it's not for hosting relational database. This is actually interesting where there is the ability to run Lambda or serverless functions against your storage, right? If you go look back at Joyent, right, they were one of the ones that pioneered that idea of saying, hey, it'd be nice to have a container that runs next to my object storage, but that's not what they're looking for here. Oh, S3 buckets. So an S3 bucket is basically the top level. It's the highest level container for an S3. It's like the box that you put it within. And they have globally unique names. We talked about that. And we need a favicon, right? So this is a pretty typical use case of, hey, I don't want my servers to be responsible for providing this favicon, right? I just need a file, and I need to be able to update that file without giving someone root access to all the servers. And so S3 might be a nice way to do that. All right, so let's go create a bucket, and we're gonna call it this. So we're gonna go to the S3 service, and we're gonna create a bucket. And from creating a bucket, general purpose is fine. The bucket name is going to be Boots and Cats. If you guys haven't, that's a fun YouTube video. You should go Google that. We're gonna leave, I think it wants us on all default. Leave ACLs to uncheck block all AWS public access. Okay, so we are gonna make this thing public, right? It's gonna be much helpful to our website if no one can access this. And it's definitely gonna give us a lot of warnings here to say, are you really sure? Where many a company have published private customer information or database or backups to public buckets and didn't realize that they were sticking things in there that they didn't necessarily want to be public. We don't need versioning on, right? This saves every change that we've made to our bucket. We don't need to be paying for that. And what does it want? Uncheck, leave encryption default, click create bucket. Beautiful. Okay. And I think it's going to be smart enough to figure out our code name here. We're going to find out. Beautiful. Oh yeah, it just contains this string. So that's all fine. All right, so an S3 object, we've got the bucket, right? We can put things into the bucket, but now we need to actually like shove some things in here. Storing is simple. File A goes into bucket B at key C. So the file would be something like mycat.jpg, and the bucket would be the thing like, okay, what's the name of the bucket? BD images here. And C would be the key of what the name is. So it would be whatever the file or the object that's uploaded here. And that'll make more sense. I'm not sure I'm crazy about my visualization here. Okay, you can kind of see the name of the file is right there. And then you can see like the S3 path that it generates, right? There's the bucket and there's the actual name of the file. All right, it'll make more sense once we actually shove some things in there. So let's grab this. We're gonna grab a favicon from this course. Grab that. Let's go download it. All right, cat favicon. All right, we've got some image data, so that's good. And it's in my spot here. Navigate to AWS S3, click on your bucket and click upload. All right, let's go to our bucket. I'm gonna click upload the file, and then I'm gonna drag the file into here. But I don't want to necessarily show all you fine folks my file system, and so I'm gonna use the CLI to do it. So I'm gonna do AWS S3, and I'm gonna copy my favicon file. And it's going to go to the name of my bucket, which is this boot cats. And I'm going to call it favicon.ico. All right, and you can see this copied the file from favicon on my local disk, .favicon, to the S3 bucket. And so now if I list what's in there, AWS S3 there's my bucket. And if I say, hey, list what the contents of that bucket is, patient ping, favicon, bucket, and cats, and there it is. So if I refresh this now, you can see it showed up in my bucket and it's ready to go. Click the object's URL in the browser to verify the favicon loads properly. So if I click this, and then there's a object URL. No, access denied. I missed a step somewhere. All right, let's go figure out what I missed. Okay, that's all right. Permission denied, weird. Under the bucket permissions tab, we've got to actually update the policy to allow it. So permissions, bucket, permissions, block all access is off, but I think it's this policy that needs to be injected in here. Oh yeah, and here's the actual policy that we need to do. So we paste this in, click edit button. Thank you. All right, and we have to update our boots and cats. And so basically saying, hey, public read, you have to add this policy in addition to clicking that allow access. So let's see if that made us happy. So if I come to objects, favicon, and I click on the actual object URL, I can see I'm getting the content for patient ping here. Good, good. All right, let's run our check then. Beautiful. And next up, CDNs, right? What are CDNs? So we created a bucket, we can store some objects, but did you notice that our object had to live in one specific region? What do you do if you don't want that to be the case? What if you needed to get this thing all over the world, right? Would you have to create S3 buckets in each one of these locations and then migrate a copy of that file, and then anytime that file updates, bring over, get rid of the old file and replace it with a new file? No, a content delivery network is meant to do just that. You have one kind of authoritative copy of the file, and just like DNS, you set up an address for that thing to live at, and you set a caching lever or caching time for that object to live. And so when someone accesses it, it gets pulled to a data center that's close to where they reside, and then all future requests will hit that local edge point and kind of copy the specific file and not pull brand new copies, right? So if our origin is in US East 1, we would do one copy that would get pulled to the server, and then once that's there, it would be cached for whatever we determined the appropriate cache for that file to be. And all those local requests would just hit this point and never have to do the transatlantic trip there. Make sense? I think it makes sense. So reasons you do that is things like latency. It takes too long to drag information across the globe, right? Noticeable amounts of latency starts to happen when you have to do these round trips across the globe. Origin server load, right? You would have to buy one large server if you're serving all those files from one spot, versus if you can distribute that load, you, one, have much quicker connections that can take place and satisfy the request. But number two, you've got 20 servers that can provide that file and get those favicons to the people that need them. All right. And how that works is you set up an S3 bucket, load balancer, whatever your source content hint is, and you set up a distribution is what it's called when you say, hey, this is an origin and I want you to distribute this information all around. Caching and then delivery. So it seems straightforward. So what's the best reason to use CDN like CloudFront? To reduce latency, that's a really good reason. To guarantee 100%, no, that's not going to do it. There is some uptime benefits where if your origin were to go down for some reason, your CDNs would happily keep serving whatever that content is, but that's not 100%. To ensure your origin server runs no background processes, I mean, that might be helpful, but that's not the reason. To avoid the need to set up web servers in the first place, there is static websites, but CDNs and static websites aren't necessarily the same thing. So it's going to be this guy. All right, let's keep going. CloudFront distribution, where your content is, right? So we talked about this distribution. Basically, it's that configuration that brings the bucket online. Source, the default root object, why we need distribution. We talked about that. But now we got to do something. Create a distribution that points to your S3 bucket and make the favicon accessible through CloudFront. Okay. So let's go do that. All right, so I'm in here. Let's go to CloudFront, and we're going to create a distribution. Almost helpful. Close this distribution, create a distribution, and we want free. Most popular to spend money. That's fine. A distribution name. It wants this single app or website. Yeah. Next. domain is optional, so we're going to leave this. And this basically, if you wanted to stick this behind boot.dev, right, you could put your domain name into this, and CloudFront would be able to serve resources using that exact same domain name. If you don't have that enabled, it'll use a CloudFront specific address to host those assets under. So there's pros and cons to that. It has to do with DNS, like do you want all of your website to be served under your domain name that you control, or is it okay to leak or to have multiple domains under the hood of what's going on? And depending on what you need and kind of the UX and kind of the IT architecture that you're aiming for will drive if you want to make one decision or the other. And sometimes like web browsers will flag if you have a lot of different domains that you're building content from. All right, let's choose an S3 bucket. There she is. We're gonna choose our favicon. That's all fine. Why isn't it letting me pick it? I don't want that. I want to choose the bucket itself. Okay, there it goes. That's interesting. I didn't know you could make a specific, I guess it would be a directory versus the actual specific object. That's all fine. Let's see. Use recommended, browse S3, choose the bucket itself. Next, enable security, leave default, click next, simple enough. Wait for the distribution to deploy. And it's got a little CLI command that we can fire there to actually run the thing. All right, so we got this up and running. And so it's in this deploy stage, and this can take a few minutes. But let's see if the test will let us keep going. Oh, it does want deployed. So we're gonna have to wait just a hot second here while we let it deploy. Let's go to distributions. Can I review it from here? Deploy Ying, and let's go grab the command. So you can check the actual command that it's running. It's gonna be this with the JQ. There's that, and let's pipe this to JQ, and we're going to look at this command. Let's drop the contains. Is that the answer? What am I missing? Domain name. There's two select statements. That one, there's this. Okay, there's that one. It's gonna be the outer, then this guy. Unexpected token open. It doesn't like the select with this. We'll just drop it. Let's go here. Oh, I'm missing a, okay. And then there's a status. What's the status name? There it is. It's just the first object. In progress. So let's do this. We can wrap this in a watch. Did I drop it? Oh, I dropped it. That there. It's working. Yeah, it doesn't really much matter. Still in progress. All right, we'll be back. All right, and it finished. So if I come back over here again, you'll see that this is no longer deploying, but is in fact enabled. And so now I think we can pass the test and we're good. All right, let's keep going. And we've got lots of stuff here. So let's see, CloudFront invalidation. So right, so what if you want to actually destroy something that CloudFront has cached in all those different POPs or points of presence or those data centers around the world, and you want to force it to go grab new files, right? Is it like DNS where you have to actually wait for the clients, or do we have a way to speed that up? And the way that we can speed that up, and CDN invalidation allows us to go to each one of the data centers that's hosting that content on our behalf and say, hey, get rid of any data that you have, and the next time someone asks for it, fetch a fresh copy, right? We have a typo in that website. Don't send that out anymore. Come and hit the origin, right? Hit the source server for new content that has the correction or the new content or the update within it. All right. Hey, there's new content. Go update the cache, right? So it's all this. So we're going to go upload the new logo to S3 and invalidate this. So we're going to grab our new content. We need the black and white icon. Let's go fetch this. Boop. So I've got this, and we download it as favicon ICO again. So now we can run our same command, S3 AWS S3 CP favicon. So I'm just going to copy the new version of it directly back up to here. All right, it's uploaded. And so now if I do AWS S3 LS, we can see that this is here, and it's as of 13/16, which is literally just right now. So that's perfectly fine. And now what we're gonna do is in the S3 console, we're gonna go upload that. We've done that. Load the favicon in the browser. So let's go grab the thing again. So if I come to S3, click this, navigate to S3 and open up your bucket and upload that. We did that. And then it wants us to go to the CloudFront distribution of it and download what's in the CloudFront distribution. And it should still be the not black and white version. So we wanna go to CloudFront, distribution, we need this. So I need to go to CloudFront, copy this domain. We're gonna paste this in, but we're gonna add that favicon.ico there. All right, and you can see it actually did update. I wasn't quick enough, but that CloudFront has already picked up the new copy of this thing and now has this cached. So that's all fine and dandy. But generally, let's keep going through the invalidation. So let's go over here and we're gonna come to CloudFront, and where is that? All right, here's the invalidation. We're gonna create an invalidation by paths, and we're gonna say favicon favicon.ico, and we're gonna boom, in progress. Hopefully it doesn't take too long. Now this does take a moment, right? For every single data center around the world, it's going to let it know, say, hey, there's an invalidation here. Do you have that file? Yes, no, and if yes, please get rid of it. And so regardless of how distributed this thing is, you don't necessarily know how many data centers have that until they all respond back as, yes, we've invalidated. So we're done there. It didn't take super long, but that's all good. So this all looks good to me. So let's fire this. Oh, I missed it. So what's it looking for? So I was able to do that, but was not able to look up create invalidation results max 20. Why didn't I able to find this? Did not find any events that I validated. So maybe because it wasn't actually fetched ever. So let's do that again. So I'm going to come to fetching so it does have that invalidation ID. So let's go fetch our icon. So I'm going to go back here. I'm going to do this, paste in this and fetch what's in here. So now the CloudFront should have this icon associated with it. And let's go grab the old one and put it in there. So let's go back to this guy. I think it's just called patient ping. Let's see. curl -o favicon patient ping -favicon.ico. Let's see if that just works. Okay, now let's do AWS. Copy favicon. And it needs to push it to our bucket. Well, that didn't pop up. There it goes. So paste that back up. So now if I run this command again, I should still get the old one because it should still be in there. Okay, it's still black and white even after a and then after a hard refresh, it did pick up the new one. That is interesting that it's able to reason out and get it so quickly. Let's see if I missed a step. So we did that, done. Object path. We could use a star. Oh, it wants something specific to it? Oh yeah, you see that? It wants a event that specifically has favicon in it. So my total invalidation wasn't what I was looking for. So I forgot. So we want only that guy. And it's chugging. Let's see if my command now catches it. We're here and fire this again. Does it show up? Okay, now it's showing up. And so now I should be able to pass this thing. And survey says, all right, we're good. Keep going. So pre-signed URLs. All right, so the question is saying, okay, Zach, we opened a public bucket. There is no authentication happening here whatsoever. What if this is a user profile or an image of the user? Like think of Facebook, like the profile image thing, or a boot dev, right? Our profile image is here. What if I didn't want just anyone to be able to access these resources or whatever I'm serving via this CloudFront? Can I still do authentication, but still use a CDN? And the answer is yeah, pre-signed URLs let us basically give you a trusted link that anyone with this link is able to access the resource and still access it from the CloudFront side of things. They don't have to go across the globe to pull the file, but they can still be validated and authenticated. All right, but they're time limited, right? Because as soon as we generate this trusted link that says, hey, anyone with this link can access the thing, right? You don't want these links to live forever. And anyone that's able to basically reverse engineer or look at that link to be able to access the resources. So let's go ahead and create one. Here's what a pre-signed URL, right? So you see it's adding these URL params to it and just injecting some content to the end of this thing. And you'll see some key value pairs like, okay, there's an expiration and there's a signed header and there's a signature, right? And these would be built as part of that the user would click on. All right, so we've got this, and so we've got a command we need to run. So we need to basically run this AWS S3 command, and we're gonna pre-sign this link. And we're gonna say, okay, how long is it gonna expire in 15 minutes. Now it's important to note that this is related to an S3 API, not necessarily CloudFront at this layer. But so just keep that in mind. So this is pre-signing an S3 bucket. So you don't have to authenticate with AWS to pull whatever's in this S3 path, but that anyone with this link can go grab it. So let's go here. And what's going on here? What does it want? Paste the pre-sign, into there. So we're gonna paste it into here and then it'll fetch it in the back end. Okay. So let's come over here, pre-signed. We're gonna call this, I forgot the name of it already. Oh, not that. Where is my bucket? For want of a bucket. All right, keep going. There it is. So, of course, it didn't give it to me. History, grep S3, grep patient. That should get me pretty close. All right, that's better. All right, so I want to S3 pre-sign, and it's going to be this address right here. All right, so it made us a nice big long link. Unfortunately, this will be expired before any of you fine folks are able to do it. Paste that in there, and it's happy. All right, but why do we use pre-signed URLs? We talked about this, right? We want to give privileged access to someone without them having to go log into AWS, and that this is a trusted environment. So your API might want to send a pre-signed bucket URL so that they can fetch a banner image or fetch profile images or et cetera, et cetera. Okay. Hosting PDFs, right? Have you seen those things that, hey, we will give you this data sheet if you give us your email address. And after you type in your email address, they might give you a pre-signed URL so that they can be confident that you aren't getting those sweet data sheets without giving them your marketing information, right? That's very likely how they're sourcing that and doing that under the hood. All right, so that's all fine. It keeps you from crawling, right? So like if you're worried about your content being scraped and available to all for regardless if they're paying for it or not us at boot.dev. We want you to learn to code, learn how to use AWS, right? We're publishing these courses. But other stuff, they might care that you pay them before you use the content. So why should you use pre-signed URLs instead of just making your bucket public? To reduce the storage cost by serving? No, that's changing how you share. It doesn't change what you're sharing. To keep content private while it's still allowing temporary access, right? Each one of these has an expiration. That seems reasonable. To improve download speeds? No, it doesn't change that. Automatically log? No, it doesn't do that. CloudFront with DNS. Your CloudFront distribution is under this terrible address, right? And you might care that your files are all served from your trusted domain, right? Versus having random domains in here. I've had projects where this has caused browser images or untrusted or insecure warnings depending on the browser version that's being used because multiple domains are being used to serve one site. And so you can stick CloudFront behind a domain name that you control, and this is how you do it. So we could say set up a DNS record, right? That would be that AWS hosted zone, but instead of the private hosted zone, it would be the public hosted zone so that it is publicly accessible. They don't have to be within our VPC to make it work. Okay, so we're gonna stick it under the patient ping address. That seems reasonable. Navigate to Route 53, select this, CNAME, and then CDN, and then the value. Okay, so we need our CloudFront distribution. Boop. We want this guy. And we want to go to Route 53 next. And we're gonna go find that record that we created, our hosted zone. And inside the hosted zone, we'll see patient ping internal, boop. And we're gonna take our CNAME. Now this is this, does it want the top level? Okay, so create a new CNAME record for under CDN, okay. So this will be cdn.patientpinginternal. And remember, is this pointing to an IP address? No, it's pointing to that other URL, right? We want it pointed to this cloudfront.net. And so we're going to change this to a CNAME that lets us reference some other address and create the record. And boom. And that is it. So let's test this. Well, hopefully it's propagated by the time this thing actually runs. Beautiful. All right, and clean up. So what does it want us to do? It wants us to get rid of the CloudFront distribution. Disable, disable. You have to apparently disable it before you can delete it. You must disable it. I did. Come on now. Come on now. Let me refresh the page. Oh, it's still in this deploying state, so it might get stuck there for a moment. What else does it want me to clean up? It wants us to empty the bucket and delete it, so let's go do that. All right, and I'm just gonna delete the one file in here because I think it goes faster than they're empty. If you can type. Depending on your typing speed, it might be beneficial to do this individually. It won't let you delete the bucket while there's things in it, which is fun, particularly because you're paying for that storage until all those files get deleted. And so if you had a couple bajillion files within an S3 bucket, it actually takes quite a bit of time to iterate through all those files and delete them. And so I've actually run into situations before where I've had a client delete a specific AWS account because that was faster than deleting all the objects within that bucket, which feels like it shouldn't be the case, but it is. All right, empty the bucket, delete the bucket. Okay, you have no buckets, all that's good. And we want to delete the hosted zone. So I'll click this, we'll delete the hosted zone. The specifies a non-required resource record set, so it cannot be deleted. Let's just delete our records. So you can't delete the certificate of, or server authority or the main name server designation. But now let's see if it'll let me delete this, now that I got rid of all the other ones. I think it's because it was tied to that CDN. It's like, hey, you are deleting something that we're using. Don't do that. But that seemed to get it freed up. And now let's come back over here. Is this done? Still deploying. Let's see if it'll let me delete it. You must disable your distribution first. So I'm sorry for all y'all that are waiting for this thing to finish as well too before you're able to delete it. Okay, let's see if it actually checks it though. So it's gonna check the S3 bucket. It's going to check the distributions. And what is it? Distribution list in the domain name. Let's see if this actually ties to it. It does definitely tie to it. Does it know what the key is it looking at? Distribution query, distribution list items. And does any of the distribution list items contain? Yeah, so basically if I was tied, because of my bucket name containing this, it's gonna have to actually be gone before that test will pass. All right, a little patience, but we'll knock it out. Let's go see if this thing is done. All right, it's disabled now. Now I can delete it. So that was quicker than deleting apparently. You cannot delete this while it's subscribing to it. After you cancel the pricing plan, you can delete the distribution at the end of the month. Oh, that's obnoxious. Let's go down here. Manage plan, cancel plan, delete. Now will let me delete. You can delete the distribution at the end of the monthly cycle, billing cycle. This does look different than when I was deleting it before. I wonder if they changed this to try to lock folks in. All right, well, let's see if it lets me pass the dry run. Otherwise, we'll have to get creative. Okay, that did work. Let's go over here. Let's see if this is working now. Beautiful. All right, we can keep going. All right, we're in ECS now, right? Elastic Container Services, of how to use something that's not Kubernetes, right? But to run and orchestrate containers within AWS. And this can be a great solution for you if you want a simple way to get containers up and running. There's many a client of mine that have wanted container deployments, but aren't ready to go bite off Kubernetes as of yet. And ECS might be a good solution, these elastic containers and staying within AWS's ecosystem to run these things. It's not complicated, it's not rocket science. We're gonna use a lot of the things you already know or we've hit in the other lessons, and let's just kind of knock out. So the first thing, before we can deploy new containers and get them up and running, is we need to have a VPC, our subnets, the internet route table. And so we've got this all set up from previous lessons. Let's just let the system double check our work here, make sure we're not missing anything. Boom, all right, easy peasy, we can keep going. And we got a chest, look at that. All right, containers are a big part of how software is deployed, right? There's a Docker course, right? If you really want to jump into Docker, but let me give you kind of brass tacks, right? We talked about a little bit in the very beginning of the course, right? We went from single servers running a single application to one server running many applications, but you had to buy many of these different things, and if one application died, it could affect another application that was running. And so virtualization was introduced, right? So that you could buy one large server and run many different workloads. And even if one server self-destructs, it can't affect another server that's virtualized, but still running on the same hardware. It also lets you buy expensive, large pieces of hardware that can operate many different servers at the same time. So you're not managing as many different things to plug in and disks that are spinning. You have one consolidated piece that you can get some economies of scale with. Containers are kind of the next step, right? It goes back to Chroot for Linux or Jails and BSD. But the idea is saying, what if we shared as many resources as possible, but then still had kind of the abstraction layer for application one not being able to break application two? And so containerization preserves that ability of different applications not being able to break their peers or the other people that are on the same piece of hardware as them. But then it also streamlines, right? There's no floppy disk emulation that are going on. We don't have to bring over the entire operating system, right? We can just bring over a smaller piece of it, of what's needed to run our application, and have it try to be and really focus on trying to have it be repeatable, right? So that whether if you're running this thing on an ARM CPU or on a Mac or a Windows file server or something like that, that it's consistent across the board. And this is powerful, right? Because if we're running containers, if we're developing an application, if we put it in a container and we get the desired behavior, we can have a high confidence that when we deploy this onto AWS, it's going to have the same behavior, right? It just might be larger or running way more of these things right next to each other. All right. Containerization, let's walk through it. So you can run Docker, right? You can run Kubernetes. Kubernetes is another way to orchestrate containers, right? Hey, how do I build containers? How do I manage how many containers are there? How do I connect containers to one another? All those things are controlled by the orchestrator, right? Docker Swarm or Kubernetes or Nomad, right? Or etc. So we're going to be using ECS, which is kind of AWS's managed and hosted and supported container orchestrator, right? Running containers. So you might choose ECS over Kubernetes, right? EKS for running containers, right? When you want to avoid Docker, right? No, these are all running containers themselves. The Docker is one of the first, or one of the first one to gain mainstream adoption, right, for running containers. When you want to fully manage container service with less operational overhead, right? And that's kind of AWS themes, just like RDS gives you a database, but they control some of the operational patching and maintaining and getting this thing failed over, right? And running in multiple availability zones. ECS is kind of the same way, right? Where it's running containers, but with training wheels, with taking some of that operational burden away from you, right? That you don't have to manage it. When you run containers on premises, no. And when you need an absolute maximum performance, nope, ECS is not that. All right, let's keep going. All right, so the first thing we need to do is when we're working with any containers is you need a spot to store containers. So we're gonna build containers and then we need a spot to store them where ECS can access them and use those containers. So that thing is called ECR, Elastic Container Repository, if I'm not mistaken, right? And it lets us basically build a container and store it inside AWS. And so when ECS asks for it, it's in the region, it's available. We can set up permissions with IAM and everything just kind of works. So let's go build an ECR repo. And we're gonna also build a container here. All right, that's simple enough. So patient ping ECS is what we want. So we're gonna come over here, we're gonna come to ECR, Echo Charlie Romeo, create a repository. Our repository is called patient ping. We want immutable, right? Or immutable means like once you upload a container named version 1, you can't possibly overwrite what was in version 1, or it takes a lot of effort to do so. We're going to do immutable because we're just making it easy on ourselves. Use the default keys. We'll create that. And now we need to push something into it, right? We've got the repository in there, but you see those view push commands? View push commands. And so say first we have to tell basically the application. We need to tell Docker, right, that we're going to be logging in to AWS, and this is where the repository lives. I'll copy this guy, paste it here. Okay, login succeeded, so that all worked. Clicked into the repository, did that. Copy and paste this command. And what's it going to do? But we need, where is the actual file? Navigate to the ECR in the search bar, create repository. And I think I should add a step here that says that we need to go into our patient ping folder, which I think is what it wants us to do. Okay, you see this patient ping in the, and just run this thing. I don't know if I got this right or not. Yeah, there's no Docker file here, so we need to actually go to here. Oh, it's on our AWS thing that we actually cloned that repo. That is interesting. Now that we have a Docker image. Oh wait, I skipped the Docker image in the previous lesson. All right, that might be my fault. Let's jump back here. Or maybe did I click it twice? Oh, I did. Okay, so I just skipped a lesson. That makes more sense. I'm glad I'm not just completely spacing. All right, so we talked about this. We talked about lesson 2, why ECS? But we actually need to create this guy. Okay. So that's a container registry, like Docker Hub, right? Docker Hub is a public container registry. I think you could also do private images there as well too. But if you didn't want to basically host it inside ECR, you didn't want it specific to AWS, there's other places that you can host containers, like GitHub and GitLab and other places that will also let you store images there. All right, so we need our file. Let's create this. So let's do makedir. We're going to call this patient ping, and we'll call it main.py, or what is it, app.py? It wants app.py. Paste all that in, and what's it doing? It is jumping in, it's grabbing the region name, it's saying hello from CMO, it's building a payload, and then it's listening under port 8000. All right, that all seems reasonable. But we don't have a Docker file here, so let's go back to our instructions. All right, here's our Docker file. So this is what actually tells Docker what it's going to be building and how it should be constructed. So Docker file, actually, let's update that name. Docker file does like, I think by convention, the capital D for Docker file. Did I specify that here? Yeah. So just know, it's a little obnoxious, but they do like capital D Docker files. Boom. So this is going to be from Python Slim, right? Basically, hey, start off by using this container, or sometimes this will be specify the operating system. Slim is usually kind of a convention for saying this is a minimal installation that basically if it's optional, we leave it off and you're responsible for adding it back in. So you can see here, we're having to install Boto 3 onto this thing. And then we copy our application file into app.py and we tell Python, go run that thing. And that's all there is to it. So we'll build this thing locally. And you see now that I'm in the same directory as that Docker file, this thing actually works versus when, I tried to skip it before. So that's all churning through. And then we want to run this thing. So Docker run, this flag like cleans up after we leave the container so it doesn't just run forever and ever. We're gonna name it patient ping container. We're gonna expose on port 8000 and then go here. That all seems reasonable. Let's grab that. Once the thing's finished, and it looks like it is, so I can just docker images, grep, and let's patient. Is that what I called it? There it is. Patient ping ECS latest is where it is. So now we can run this thing. Nope, not that so much. Let's go back over here. Copy this command. Okay, and it is going to run this container. And it brought it up, but notice it didn't give me any output. But let's go check to see if we can access it. So if I come over here and curl localhost, did I say 8000? Is it gonna work? And there it is, hello from the container. I just wasn't patient enough. All right, so that all looks good for me. And okay, that's gonna use localhost 8000, which is all fine. Boom, hello from the container. Boom, all right, now we can actually push this to ECR. So we've got this, and we're gonna run docker build X, which is a faster way. It also lets you build cross architecture, right? So it doesn't matter if you're on an ARM chip or an AMD chip or et cetera, what your CPU is, it will just build the thing. And we have to add our account ID to this list. So let's do that. So cancel that, PS grep patient. There's no Dockers running. Okay, so let's do this. Paste that in there, and we've got to update our account ID. And our account ID is right here. So I'm just gonna grab this portion of it. So you see 906 DKR, and over here, 906 DKR, and it continues on. And notice that we're adding a thing to the end of this colon latest, and this is the tag, right? This might be a version, or it might be like that Python Slim that we saw before. But basically this tells us what is this specific artifact within the repository, right? This is the name of the container, but what does this version give us that the other ones don't? And latest is kind of the convention to say, I'm not telling you anything about this image besides that this is the last one that got uploaded. And it's dangerous, right? If you aren't the one publishing images to this address, what if a hacker were to compromise my machine and change or upload a new malicious version of the container? If you download the latest, you would get that malicious container regardless of whatever version you had selected or were using before. So that's why you're gonna see warnings all over the place saying, don't use latest when you're choosing a container tag. But we're using it here because we're the only people that control what containers get published to this. All right, let's go ahead and push this. So it builds the container, it's pushing layers, right? This is kind of how Docker's distributed acyclic graph, right? Or basically they can say, hey, we're only going to build the components of the container that require it, right? So if you only change one line at the very end of the container, Docker can say, oh, we're not gonna rebuild all these things that we already have, we can push those other things. This is what lets us do this. If I run the exact same command and fire it again, pushing layer, and you can see that took way shorter, like there is no 7, 8 second, 9 seconds intervals. It already had these layers, and so it just keeps on keeping on. All right, here's the ECR, here's our private repo. Open this up, and you can see now there's our latest image is up and running. So let's run our check. Beautiful. And let's keep going. All right, now we need an ECS cluster. That's great that I've uploaded an image. It's great that I can run the container on my own machine, but the purpose of ECS is that they handle that. They handle the resources, they scale it for us, and they do all of those other things. And so we wanna get the cluster, right? The actual compute that powers the ECS instance up and running. So it's a logical grouping of compute. A cluster can hold a number of capacity providers. Hey, this is great. We need 10 cores. We need this many gigs of RAM. And a capacity provider tells ECS, it tells the cluster, how is it allowed to provision new resources? Does it use really big machines? Does it use really small machines? What regions does it put it in? And how long should the CPU be pegged before a new instance comes online? And these are all configured as part of the capacity provider of ECS. All right. So we're gonna be using something called Fargate and Fargate Spot. Are we doing that? We're gonna find out. But Fargate, right, is essentially, that's AWS's serverless kind of function for running containers. And a Fargate basically says, hey, you aren't gonna see an instance running in your account. You are just gonna see the container running in your cluster. A Fargate Spot uses a Spot instance, right, to power that thing so that it is much, much cheaper, but also that container might implode at any point in time with a 2-minute head start. And so this can be great where if you spin up, hey, I always want this level of resources that are available with this container running, and then I want 90% or X% of it running on Spot instances and really bring down the bill of how much I'm spending on my compute. And so you can mix and match, and your capacity provider can define what an acceptable limit and mixture and setting for those things for your cluster is. All right, serverless gets a lot of hype. We're gonna do a serverless after this, so we'll talk more about this in a bit. Fargate capacity providers, when you configure, that's all fine. So we're gonna create a cluster. Let's go do that. So let's go to ECS. I think there's a default cluster that also gets provisioned as well. And just like the VPC, don't use it, right? Oh, it doesn't. Okay, that's good. Might be the default capacity provider. Oh, look at that. They've got funny names on the thing. All right, you got that. What's it gonna say? Fargate only, create and wait. All right, to double check the capacity providers are set to Fargate. All right, let's go see if that's right. So I can see the only two capacity providers for my cluster here, or I guess this would be for all ECS clusters, are the Fargate and the Fargate spine. So that's all fine and dandy. And what's this gonna do? It's gonna ask for that and look for active. So that seems fine. Let's see if this will work. Oh, jerk. I describe clusters and it should be contain that. Let's run this. It's a failure is missing. Why is it missing? Unable to assume, oh, my credential ran out. See, that's obnoxious. All right, let's go back to ECS. We'll create our cluster. This is one of the things you do have to be cautious of when you're running ECS, especially if you get into an environment where you're running more than one cluster on an AWS account or a specific region. If you can have a cluster capacity provider that is shared by multiple clusters, which is a terrible idea, don't do it. And if you are in that position, split out your capacity providers and make it owned by specific clusters, because bad things can happen when they get confused, or if you delete the wrong one, or you end up with a cluster with no capacity providers. It can end up in complicated scenarios. I don't care about that. Create the cluster, that's all fine. I'm gonna create this, Fargate only. There's a cluster for a failed cluster with the same name. Well, we might have broken it. We might actually have broken, yes, here. Did I mess with anything? That's all turned off by default. That's all fine. That's all fine. Maybe it's creating, just not rendering correctly on my side. No clusters. That's the capacity provider, but here is the clusters. Let's run this. And it's not gonna let me create that cluster until it exists. And let's see. And this is does it check the name of it? And the name must equal patient ping ECS. So I might get stuck here until I can clear this error. That is a little unfortunate. And it's looking for, expecting JQ.fit, here's the length, to yield 0. So if I have anything in this failures list, it's going to fail on me. All right, well, I might have to nuke this AWS account and get a net new one, or I might just give it a few minutes and come back to it. So let me pause it here and I'll see if the error corrects itself after 10 minutes without you having to watch me breathe for 10 minutes. All right, I think I got it figured out. So it turns out what's happening under the hood, and what AWS likes to do sometimes, when you come and try to create a cluster, right? What it will do under the hood is that AWS uses a tool called CloudFormation to run a lot of commands on the AWS platform itself on your behalf. And so when I created and failed at creating one of these clusters, it was actually a CloudFormation error where it tried to ask for something before I had finished creating and got into a race condition. But we can fix it ourselves, fortunately, and you don't have to wait for AWS support. So if you go to CloudFormation here, you can see that it ran an ECS create patient ping ECS stack, right? That's what CloudFormation calls these kind of primitive resources. And you can delete this thing. And when you delete a stack within CloudFormation, it backs out the resources that are associated with it. What is it? So you delete the stack and you'll see that, hey, there's a delete initiated for this thing. And if you watch it, there's a delete in process where it will walk through and back out the resources that it created as part of this CloudFormation, this stack of AWS resources that it's trying to create. And once that finishes, it's gone, right? And if I come to ECS now, you'll see it's gone, right? There is no cluster here. But now I can still create it, right? I can create my patient ping ECS cluster, hit create. And you see the cluster's creation view in CloudFormation. You can view this and we can watch it now create a net new stack of what it's creating. And this can be really helpful to think about, okay, if I was AWS and I needed to create a lot of different things that are all like interconnected, in this case, it's doing some things in IAM as well as in the network, as well as getting Fargate and different resources all ready to go for this cluster. Sometimes you can see exactly what AWS is doing and see the exact same information like AWS support would use to troubleshoot and kind of work through the issue. So, all right, we're back up and running. let's see if I can pass my test now. So I'm going to run the dry run. Let's not sacrifice our streak just because of this. It looks like that worked just fine. So let's add the -s. Boom. All right, we're up and running. Let's keep going. All right, ECS permissions. So we talked about IAM roles, but they also apply to ECS, right? So if we want our ECS containers to be able to do things on Amazon for us, like access those SSM parameters that they need in order to run the application, or RDS or CloudFront or whatever those things need to do, or write to an S3 bucket, they need permissions. So we need to give ECS access to specific containers to pull them down. And after a container boots up, it needs its own set of permissions, right? So remember, there's a builder credential and then there's an operator credential. There's two sets of credentials that ECS uses, right? You might want different permissions for when you're actually building the container and pulling an image versus when you're running that image, it's gonna have different needs. It doesn't need access to pull container images once it's just functioning as our little Python app. So there's an execution role. Essentially, what does permissions does ECS need to start exec? Like the Docker exec command, it runs a container, it starts a container. So try to tie that into your mental model of Docker exec role, right? It's the start. And then there's the actual task, right? This is a long running task. What permissions does it need as it's running? It's a hard thing, and I've seen a lot of engineers get confused between an exec role and a task role, but just equate that in your mind to exec, like Docker exec, just run a Docker command or run or start a specific thing. All right, so we're gonna have to create it. We also have to set the trust policies are gonna be different here, right? Because it's not EC2 that needs to access these resources, it's ECS. So we'll have to make sure that our trust policies of who's allowed to use this role is set up correctly. All right, boom, boom. So we want to create a policy and we'll figure out what the name for it is here in a sec. So IAM is where you do permission stuff, and we're gonna jump into policies. We're gonna create a policy. The JSON editor is your friend. We're gonna paste this in, and what can we do? We're allowing some ECR. So is this exec or is this task? It's exec, right? Because it's part of building the container, or pulling the container down that we need. So this all looks good, and that's fine. So we're gonna say next, and we're gonna call this policy patient ping exec policy, and that matches what we'd expect, okay? And the next one is the task policy, right? What does it need to operate? And what this thing needs to be able to operate is the SSM parameters. Remember, that's where we stuck like the database access and things like that. All right, I don't need this. JSON is fine for me. Do I need to change CMO name? Create that so that your container can read the SSM parameters you created in 5.7 /database and /CMO name. Let's add the database URL as well. So we'll add another resource in here that is allowed to get. I think that's right. And we'll add some spacing here. Did I do something wrong? What does it look like? Oh, I didn't. It needs the full ARN. Okay. Boop. Nope. All right, that looks right to me. CMO name and then the database URL, and we're gonna check. Let's go grab /database URL. I think I can remember that. So what is this thing supposed to be named? Patient ping task policy. Let's grab that, plop that in here, back out the other one, create the policy, and let's switch this to my customer policies. So there's the task policy. Let's go to SSM params and make sure that I name this thing correct, right? There's no reason to guess. We can actually just, make sure the thing is right. All right, so we want to go to SSM params, which is hidden way down here. For how useful parameter store is, AWS doesn't give it kind of a fair shake of where they stick it in their UX. All right, that does look. CMO name and database URL. Both these things are fine and dandy. All right, so we need to create a role, and we're going to say ECS is allowed to assume this role, and then we need to attach the policies. So let's come back to IAM, roles. We're going to create a role and a custom trust policy. We're going to paste in our trust policy. Oh, we can just tell it to allow ECS. Boom, boom, AWS service. This is for ECS, Elastic Container. Does it spell it out? There it is. And you're gonna see that there's nothing magic here, right? That's fine. It's gonna add that default AWS permission to it. But you can see it's just allowed. When you selected that, it did two things. It added this ECS service principal, and then it chose a policy that AWS has built in for doing ECS-based actions and save you some steps there. But nothing magic. We need to call this thing, batch role name is this. So we're going to give it, call this the execution role. So this would be what it starts up. But we're going to create two rules. We're going to create the execution rule, and then we're also going to create the task rule. So we didn't combine these. That makes sense. So I'll create this. Let's create our other rule. So it's going to be AWS service. It's going to be elastic container service. And next. And that's fine. That's the magic policy, the AWS managed policy that they added. And we're going to add the ECS task role to this one. So these things are identical right now. We haven't attached any policies, but what's going to change is for the task role, we need to attach, add a permission, attach a policy, and we're going to go to our task policy. That lets it do the SSM things. And then the other one needs to let it access the repository. So we'll go to the exec role, the execution role. We'll add a policy here. Attach policies, and then customer managed. And here's our execution policy. And naming these things in a very straightforward and purposeful manner is going to save you so much heartache in the future. It is painful to diagnose these things. Call it what it is and try to encode meaning into the name that anyone can understand and kind of give it the sniff test too of, is this doing what it's supposed to be doing? All right, open both roles, verify. All right, that all looks good. Let's grab this, fire this, and let's see if I got it right. All right, we're good. Next lesson, ECS task definition. All right, so we had a launch configuration or a launch template. Do you remember that for EC2 where we basically put all the information you need in order to build a EC2 instance, and we had a single spot that we could just kind of have as a recipe, and then we could print off that recipe as many times as we wanted, a template as it were. A task definition is exactly that too. It's everything that the ECS task needs to know about where it runs, what permissions, what networking, what security group configs, what environment variables, anything that a growing container needs to be able to operate and use, we can put into the task definition, and then it will run as we ask it exactly what we want it to be. So we're going to walk through this. We're going to answer these questions with a task definition, right? So you can see we have things like, hey, what role should get attached to this thing? What platform should this be running? Do you need a Windows container, right? What container definitions, right? Saying, hey, I need port mappings to be in this. Your task can actually run with many containers within it. You aren't limited to just one container. There's a whole class of kind of application called a sidecar, which is a container meant to help other containers. It's not meant to run on its own. It's only meant to provide some other service as a composable component for other containers. And ACS and task definitions are how you kind of define when you need that and when you don't. All right, so we walk through here, family, CPU, memory, all this is pretty self-explanatory, right? And really, you shouldn't be trying to memorize these things. Know what they are, know that they exist, and look it up when you need to. It's not complicated. All right, so we got the cluster ready, and let's build our task. We need to jump into ECS and go to task definitions. So we'll go to ECS. We will go to task definitions, and within task definitions, we need to paste in some JSON. Create a new task definition. Oh, what's it? Task family. Patient ping ECS. Is that what it's called? I think it's what it's supposed to be called. Yeah, EC family prefix. I should have defined that better in this list, so I'm sorry for that. All right, we paste in the JSON. This is going to be Fargate. Where's my JSON editor? Come on now. Oh, I see. With JSON. Oh, it's so much better. Okay, so I can do that. Eliminate all my. All right, so we need our exec role and we need our task role. So let's go over to IAM. I feel like AWS updates their icons pretty often. I can, like, they have beautiful icons. I just do not know what they mean. And yeah, that makes me a little sad. So don't feel bad if you don't know what the heck the orange icons versus the red icons mean. I don't know either. All right, we need the role arms. Let's go grab one. We need our roles. All right, here's the exec role, execution role, and I want the ARN, which is right here. Copy. All right, I'm back over here, and I click this, and I'm gonna say this is the exec role. This goes here. I'm pretty sure this is just called task role, so I think I would just do that. We need the image URI, so we've got to go to ECR now. I'm gonna go fetch that. ECR. Remember, ECR is where we're storing our containers. There's the container URI. image URI. So we're going to go back here. And what I don't know is if we're supposed to put a tag on the end of the thing or not. Let's see if it tells me. I think we're okay. I think we're going to try that. I think it assumes latest by default. So let's continue. So hit create. I don't see any other variables we need to replace. And we've now got a task definition. Okay. You can delete a task definition by deregistering, so that's all fine. All right, I think that's good. Let's fire this thing and we'll see if we've got that. All right, we've got a task definition. Let's keep going. How many more do we have on this? Not too bad. All right, now we need a security group, right? This course is gonna give you something in the back of your brain that says, hey, there's a lot of moving parts here. It's hard to get all these things right. What if I was standing up 30 containers or 30 different accounts that all needed AWS ECS? Hopefully your brain is wishing that there was a simpler way to encode all this. And the answer is CloudFormation or Terraform or OpenTofu, right? Or there's ways to build all this configuration in a composable and repeatable fashion. But it depends upon you understanding what you're building and why you're building it. And that's why we're taking the more methodical approach in this course. And maybe someday there'll be future courses that do some of those other kind of nicer things. All right, let's build the security group. All right, we're gonna build one for the ECS tasks. And it will have an internal security group that allows traffic from a load balancer to our ECS task, okay? And then one for the load balancer itself. Okay, so basically we're gonna have two different security groups. One that's containing our load balancer that lets all traffic in. Remember 0/0 is all the IP addresses on the internet are allowed to hit this thing. And then this only allows traffic from this green box. All right, that seems straightforward and makes sense. So let's go create a pair of security groups. Remember, where are security groups? It feels like they should be in networking, but they are in fact in EC2. So we're gonna jump over to EC2 and build a pair of security groups. And we're gonna create a security group. And this security group is going to be called, this is the external. And notice that I'm being really explicit in what we're calling these things. Make sure you build it in the right VPC, otherwise you're gonna be confused in a few minutes. And outbound is fine, but I'm gonna allow all traffic on port 80 in. So I'm gonna say 80 from 0/0, and it doesn't need a description. Allow that. And I don't necessarily need any outbound rules, and I don't need any tags. It needs a description here. Oh, it wants that on that, not necessarily on the rule. So, but it doesn't really much matter. All right, we've got an external one created. Now we need to create one more security group. So we're gonna go to create the internal one, and then we need description, and allow traffic from the load balancer to ECS tasks. Gonna not use the default. Don't use and don't let your friends use the default. It might actually want internet access, but we're gonna add another rule here for allowing port 80 traffic, right? This blue, we need to allow all traffic from green. So let's say all traffic from, and then instead of this custom IP, we're gonna do security group and we're gonna choose the public side. So instead of saying this is the CIDR block that we trust, we're gonna do this. But I made a mistake. Did you catch my mistake here? I've stuck this in the outbound rules, which is not what we want. So let's blow this away. Instead, we want this in the inbound rules. Who's allowed in? So we're gonna allow all traffic inbound from our security group, SG patient ping public. So anything that lands inside this green box is gonna be able to ingress inbound into our blue box where the ECS tasks are actually running. So that seems reasonable. Good, security group, create. All right, we've got our two security groups. So we did that, did all that, did that. Patient ping internal. All right, let's see if we passed it. I missed something. What did I miss? Security group name, patient ping -external, patient ping internal, expects it to exist. What did I miss? I feel like there's two security groups there. One security group, two security groups. What doesn't it like? And results false. So IP protocol -1, query security groups, external, from port to port. So let's check our external. So patient ping. Oh, I call it, all right, there's patient ping public and patient ping external and internal. What is it supposed to be called? Patient ping external should have added inbound rule on port 80 from anywhere. So ping inbound should have an inbound rule from port 80. Okay, we got that. And then this one should add an inbound rule for all traffic from patient ping external. Oh, I think I might have chosen patient ping public. Okay, so here's our internal. Ah, you see that? I used the wrong name. All right, we'll edit the rules, back this guy out. Patient ping external, here it is. All right, see if I got it right that time. Boom. All right, let's keep going. Application load balancer. Let's do this for kicks. Application. All right, we're working on anything but ECS. Yeah, there is some setup, right? There is some pre-cooking that you have to do. But once we kind of have these things pre-cooked, just like those EC2 launch templates, it becomes pretty easy to run it 1 time or 100 times. And so we're having to pay the piper a little bit up front and getting this all ready and operational. But once ECS is up and running, generally no one has to touch it. All right. Start listening for traffic, but we need to set up a load balancer and a listener. Okay, so we have this green box, the security group, but we need the load balancer and we need the listener created, and the listener has to take traffic. Okay, that seems reasonable. And why do you need a load balancer? Number one, what if your application is flaky, right? So you have an application that breaks or undergoes maintenance. It would be nice to just not stop responding to clients. It'd be nicer if you could send the clients to a web page that says, hey, we're under maintenance right now, check back in a few minutes. Or here is a standby website that you can access and still operate for the time being. A load balancer lets you have that top level box to be able to accept that kind of traffic. Also, what if your traffic exceeds what one server can handle? The load balancer functions as a traffic cop that can distribute that load to a server that's available and can process that workload. And so it lets you do things like, hey, I want 20 servers or I want 1 server, and the load balancer's in charge of knowing which servers are available, who to send it to, and what is the logic and rules for sending traffic to the right server. So load balancer takes some of that networking off of your application. That is what they build, right? You can go grab Nginx or Caddy or HA Proxy, right? There's 1,000 other different load balancers out there that have been designed to do it in a really optimal fashion, and you don't have to invent that when you're working on your application. All right, so let's see what it wants us to do. So load balancer is the thing itself. The listener is what sits on this side. It's like, okay, how do we interact with the internet? And then we're gonna also have another side over here where it's the target group, where it's like, okay, where do we send traffic after we get it? So we're working on the public side of this thing. Create a load balancer. There is cost associated with it. So as soon as you click this button, have in your brain that you need to go kill this thing off before too long or before you check out for the weekend. All right, patient ping ALB in EC2. All right, so we're in EC2. For some reason, load balancers are within the EC2 menu as well too. So just know that, a little bit of trivia for your soul. Create a load balancer, create an application load balancer, a load balancer name, and we want this internet facing. We want to choose our VPC for this thing, and we're going to set up through that. So let's start doing that. So here's our load balancer. Is it done creating? It's active now, good. So that's listeners. And I think we actually have to create a target group over here. So let's go over here, create new target group, and it's going to be IP addresses. And the target group name will be patient ping TG, right? Nice simple names are a wonderful thing. And let's be 8000 IPv4. We're not going to use the default VPC. Don't let friends do that. Does it want HTTP 1 or 2? I think we're going to leave it on this for right now. All right, health checks. It wants, leave that as that in the defaults, okay? And target optimizer, that's fine. All right, the patient ping, that seems fine. Specify the IPs and define ports. Choose a network, so I think that's what I want. Enter IP. You can manually enter IP addresses from the selected network. Is that what we truly want? I think we're setting it up as a hard-coded IP address for now, and then we're going to set it up, once we have our actual ECS tasks up and running, we can automatically register them going forward. Let me see if I got this right. We won't register targets yet. Okay, so let's just set this as is, and we're going to go ahead and create. That makes sense. So we obviously can't register a target that doesn't exist yet, and we don't want to just pluck a random private IP address for our container, because the containers are going to hopefully be being created and being destroyed all the time. And so you would have to constantly update that anytime a new container showed up, which is not what we want. But fortunately, ECS is smart enough where it can automatically bring on and register it with the load balancer as soon as it comes healthy. And that was in that task definition. And we'll show you how we do that update here in a second. All right, let's save the changes and fire. So we've got this. I think we've got everything we needed. Let's see. Oh, I missed something. It wants patient ping ALB query load balancer's output text. Oh, it wants a forwarding rule. So we didn't set up our forwarding rule. So we actually have to go, we have a load balancer and we have a target group, but we didn't connect these two things together. So We're going to associate with a existing load balancer. There she is. Actions. We're going to say just the target group. Where's that setting for the target group? I always forget. Listeners and rule. Okay, it's going to be a rule. Add a listener managed rules. Oh, here we go. So here's the listener, and for the listener, we set up a rule for it. So here's the rule, actions, deprioritize the rule. So this is this, but we want to set this up to instead send to this. So we're going to edit the rule, and instead of sending it to a fixed response, we're going to do a target group. And now our target group is listed here. We're going to send 100% of the traffic there. Versus if you have like 6 things, you could add different weights and it would split up that traffic for us. So now the listener is aware of the rule of which target group it should be sending to, right? So the listener is on port 80. It's attached to the load balancer. And then what's its action? It's going to forward to the target group 100% of the traffic. Okay, so I think that's going to be it. All right. We're good to go. CloudWatch log groups. All right, I promise we're getting close. We only have 2 more lessons, so stick with me here. So how will we know when something goes wrong, right? We talked about CloudWatch. We talked about agents that are installed, but how do we apply that same concept to containers? And the reason what we do is we basically bake into each of our containers the ability to create a log group. So when that container wakes up, it can create a little repository of where it stores its logs and that it's able to put logs into that stream, right? So a few things. It needs to be able to create a spot to store things. It needs to be able to say, hey, I'm going to start streaming information to this. And then it needs to put things onto that stream of pushing that standard out, those errors, those log messages to the AWS API. So simple enough, we're going to create the log group itself. So here, we're going to go to CloudWatch, and then we'll go to the logs, and we'll create the log group. And just click this. Where are my groups? Log management, I assume. There. All right, create a log group. Boom. Expired after a day. All right, actually, I think I said like 7 days or something like that. Standard. Okay, can I set it down? Okay, does it check? I don't think it checks. Perfect. All right, we're going to do create. All right, that's all I needed here. Let's see if that passes. Beautiful. All right, now we can actually run the service. So we have a network to put this thing in. We have security group rules. We have a load balancer that accepts traffic and sends it. We have a task definition, right, which says, okay, what are we running and how are those containers? We have roles and permissions associated with those containers. We have a log group that we're going to store information that our containers generate. And now we just need to run the thing. We have all the trappings, we have all the fixings available. Now we just need to like cook the meal here and actually get the containers up and running. And what a service tells us is where do we place our tasks? How many do we need, right? When do we go up? How many total should we have? And how do we connect to that load balancer that we just created? So all simple stuff. So let's go to the console, ECS, clusters. We're going to open the cluster and under service, click this, go to services. We're going to create a service. Our definition, there she is. We're going to say 1. We're going to use the latest version of this. The service name should be called Patient Ping SVC. Beautiful. And then it's using our cluster that we defined. We're going to capacity provider here. And we're going to set Fargate for the capacity provider. Then under networking, boop. And we're going to choose don't let friends use the default network. We're going to choose does it want the private or the public? I think it wants the public subnets for this thing. Okay, we're gonna use an existing security group. This would be the internal. Get rid of this guy, we don't need it. Do we want a public IP address? Public IP turned on, okay. There it goes, so it's creating the service and you can see it's doing that CloudFormation nonsense again where it's actually building everything that it needs inside here as it's chugging along. So we could roll this back if we really wanted to. Now let's see if it spins up a task for us. Oh, we missed the load balancing things. All right, we have to go do our first update. So let's go to our service. We're gonna edit our service. Load balancing, use load balancing. And the VPC, okay, add load balancer, application load balancer, that's fine. The load balancer we choose, there she is. The listener we need, we're gonna register it to port 80 and the target group, there she is. Update. All right, that will help things. It does look like it successfully ran that. This might still be rolling out there. We're gonna see if we break it by changing it while it's still in the deployment process, but I'm hopeful. I'm an optimistic individual. No tasks are up and running yet. Sometimes you can see it. Okay, here we go. So what I did is I switched over from health and metrics and tasks, which show you, hey, are any of these things running or stopped or etc. But deployments will show you kind of what's happening in progress right now. So you can see, hey, we asked for 1 new service and 0 are currently running and 0 are kind of in motion. Let's go look at those tasks. Let's say, are there any stop tasks, any running tasks? And it looks like it's still kind of waking up. Okay, they're still waiting. Let's see if there's any events. All right, there is an issue. Failed to assume the role for patient prong role. The role that being passed has a proper trust relationship and that your IAM user has permission to pass this role. All right, so we got to go troubleshoot what's going on with our task role. Oh, you see, and it's also the task role, which is the one that I typed in by hand because I definitely knew better and did not double check things. So let's see if we have to go update that, if I got the role name wrong. Okay, that does seem like the right role. What's the trust look like? It's allowing ECS to assume this. That looks correct. And then the exec role, let's make sure that that got everything. Okay, that's got that attached to it. Let's go check the exec role, see if we messed something up there. And this is allowed to do ECR things, a patient ping ECS, and do log group stuff. Now, okay, that's interesting. Did I get this wrong? I have to go back to that because why would this need to write to logs as part of the exec side and not the other side? But this part is definitely right. And I don't think I would copy and paste just that part. So I think that is what it's intended. It's 5101. So this is happening currently. Let's see if it's still happening. Proper trust in the IAM user has permission in that your IAM, okay, this could be the issue, or my user may not be able to pass this role to it. I am logged in as an organization account role. Did that change anything? Let's go ahead and just do this right quick. Okay, in about 5 minutes, we can jump onto CloudTrail and actually view that list of all the AWS API actions and see if that broke something along the path. All right, 0 tasks up and running yet. ECS task roles that was provided. The chopper. All right, let's go check our permissions here. So permissions. So here it is. This is meant for the execution. So the execution, okay, it does have both sections. So it has this ECR component and this component. And then this one has the SSM param component to it. But where's the creation of the role? Create role. Okay, did I just set it up for one? ECS tasks. Let's go check that. Let's go to IAM. You guys are going to get to enjoy a little live troubleshooting with Zach to figure out what we did wrong in this thing. All right, so boom. So here's the trust. You see that? So that be on both of them. Verify the trust relationship allows to assume the role. Okay. So it looks like I chose the wrong one there. So this is ECS, the service, versus ECS tasks, being able to use it. All right, so that's the execution. Let's go to the other one. ECS task. Trust, edit, update this, boom. All right, now let's go to ECS. Oh, we got one pending now. All right, and that does look like it was the issue. So we referenced the ECS service task, right, which would be like an ECS as a global thing performing it versus ECS task was what it wanted. So, follow instructions, it's always a good sign. And let's see if we get any logs out of this thing. All right, this operation's only supported the standard log class, so we don't have that portion because I chose that infrequent logs. But let's see if this is working. Okay, let's jump back over to our current lesson. And remember, just to recap the issue, right, is IAM roles, right, are made up of 2 parts. The authorization, what are you allowed to do? And the authentication, or what's called the trust policy, who do we trust to be able to do this thing? Hello from the container, from Dr. Strangelove. That looks positive to me. 12 seconds. Oh no, jerk. I got it the first time. Or was that just the expected that I got? Expect standard out from the container. Did I go too quick? All right, let's go to our task. Is this thing up and running? Update our service, the logs, so we can actually see what's going on here. All right. What do I have to say? I set up the log group myself. So we're gonna have to go to CloudWatch and turn off that infrequent log storage class. Okay, log management, boom. And I'm gonna say action, and I'm gonna say edit. I wonder if it'll let me, that's just the retention settings. I want edit all of the settings. It might not let you. Yeah. Here, see if this is working. No, let's run this. So I'm gonna try curling it myself to see if we can get the content here. All right, so I did get to a public IP address. Did land on it. Tried 443. I don't want 443. Oh, see, I did HTTPS. That's unhelpful. Do that. So establish that. So let's go check the load balancer, see if it's happy. But the fact that the containers have not come online yet makes me think that we have an issue. Right here, it does look happy. Let's go to deployments, services, click on the service, and if we go to the deployments, so we've got a failed task, but this one does look happy. View the task. This one's deactivating as of when? Okay, 5:09, so that's 3 minutes ago it started deregistering a task. Port 8000 is unhealthy, target group, reason timeout. All right, so if we see another timeout occur, we know that our container isn't quite ready yet. And you can see this is still in the deployment stage, so we may not be past this initial step. Okay, so let's go to the load balancer, and we'll just kind of walk the train of things here. So this is an internet load balancer. It's reaching target group 80, and then it's sending it to this. Let's check what permissions it has. So this should allow port 80 inbound. Inbound rules, port 80 from anywhere. All right, so it's getting to our load balancer, and then it should be allowed to go out. Oh, so you see this? So while we're letting the traffic in, it can't go anywhere. So this, we missed a rule here that we needed. I got a little too carried away. So if I allow all traffic to leave our load balancer, that's gonna help us out a little bit. Okay, did that change our behavior at all? Look at that. All right, so now that traffic can get to our load balancer and then get forwarded to the target group, things are working much better now. So it's not magic, right? You just got to think of how is traffic coming in and check each step along the way and look for those typos and things like that. And it's going to call to your mind and says, okay, Zach, this is great, but even someone that's been working in AWS for a while can make dumb mistakes as you're clicking through and trying to get stuff done. And it calls together templating and other things, infrastructure as code ideas that can be really helpful in this kind of context and save you from making mistakes like me. All right. So we got that, let's start cleaning up. We've got our ECS task up and running, and so we need to delete the service. So let's go to ECS, I think right here. Can I just delete this? Delete the load balancer, boom. Confirm. Security groups don't cost anything. And let's go here. So let's go to ECS, delete the service, which controls how many containers are up and running, and force delete that thing, which is wonderful. And we're actually gonna back out the whole cluster. Now, because we're running Fargate, right, which only runs basically serverless, or it only runs compute infrastructure when we're asking for containers. The cluster itself won't cost anything. But if you want to make really sure that you can't possibly spend money through this, deleting the cluster is a surefire way to make sure that nothing is going to be provisioned. All right, we need to go clean up ECR, right? Because we don't want to pay for storing a container we're not going to be interacting with. And let's see if we got everything. You did that. Did that. The target group doesn't cost anything, and we delete the load balancer, but let's do it just to be thorough. Remember, load balancers are going to be in the EC2 section, so we got to jump back over here. Boop, and delete. Okay, target group's done. That's done. The task definition, we can go do that, because the task definition, you actually can use one task definition for multiple clusters. I don't recommend it, but you can definitely do it. But that's why it doesn't automatically kill this thing when you, what's going on here? Actions. Now I can deregister this. And once all revisions of a task definition are created, I believe this will just disappear after a moment. Yeah, okay. Delete the security groups. Doesn't cost anything. Does it actually check for security groups? No. So we're gonna skip that. And IAM roles don't cost anything. ECR we did. And the CloudWatch group, let's go kill that. All right, logs, log management, patient ping ECS. There it is. And actions, delete, boom. Boom. All right, I think we're ready to go. We'll see if we forgot anything. Boom. All right, with that, we are done with ECS, and we're gonna move on to Lambdas. Running without, like, what if we bail on the container and we try to run something even simpler? So it took us a little bit to build the network and the instances. It took us a little bit longer to build the container and to get that up and operational with all the trappings that it needs and the capacity provider and all those different things. And serverless is kind of the next step on that journey. What if I try to delegate as much of the operational responsibilities as I can? And that's kind of the promise of serverless. They're going to try to take as much of that responsibility on themselves as the platform provider. This is true with Heroku, right? Or fill in your favorite serverless provider and AWS Lambda as well too. But sometimes you have to break that abstraction. Sometimes you do have to know how the networking works. And so the foundation that you've built in some of the other courses are really helpful for understanding what exactly is AWS doing under the hood here? How does it get permission? Where do the logs go? And we're going to be able to plug in a lot of that knowledge that we've been accumulating into how we work here. So let's talk through Lambda and let's get cracking on this. So Lambda, You write the code, you upload it. Sometimes there's like special handler syntax. And there's actually the ability to provide an entire container image to say, not only am I going to tell you the code that I want you to run, but here is the actual container binary. Fire this thing, right? And I don't care how you do it, just run it and bill me for the time. And there's some flexibility available here for AWS in their serverless offering. So we talked about the pitch. When does it make sense, right? If you have an event-driven workload, say, hey, I might have none of these things or 5 of these things a week, or I might have hundreds of thousands. Your choices are either to build the capacity enough to support that peak load at all times, be okay for clients sitting around and twiddling their thumbs while your slow, cheap server gets it done, or something like serverless, which makes sense. It will spin up as many workers as there are tasks to do and just chew through them. So you'll see things like crawlers, right, that say, hey, I don't know if there's going to be one link on this page that I've got to go crawl, or if there's 10,000 links. It can be nice for that kind of event-based workload, right, and super dynamic. Video transcoding often happens, right? If you drop a file into here, we're going to spin up a Lambda and we're going to package that thing up and transcode it on behalf. And there's no overhead, right, in between batches. Scheduled tasks, right? This has been a really beneficial thing in my history of saying, I've got to run this utility, this report, this action on a regular basis. I don't want to have a server to update. Just for something as small and easy as this, I just want to stick it on a cron and be done with it. Lambda can be a great way to do that and to package it up and to do it in a consistent way that is sustainable, that you're not going to hate yourself in 6 months and trying to remember how you plumbed it. Prototypes, MVPs, right? It's free until the thing gets used. And so if you are in a state where probably this project is not going to get off the ground, then serverless might be a great thing for you to say, I'm going to build the thing and we're going to prove it right up to the point where we can make the assessment if this is going to be a real project or not. And why pay for compute infrastructure until you get to that point? And you can delay when you have to put money where your mouth is, right? And when does it not make sense? Long running processes. There's max times that a Lambda can run and you're going to be dancing around it if you are trying to build these things. A big stateful application, right? If we talk about stateless, like the application is dumb, all the brain, all the logic that it stores is somewhere else, versus a stateful, which means it needs to be able to react and to store memory of past transactions and change, right? There's side effects related to it. A large number of dependencies. I'm literally fighting this in my day job right now of saying, how do we vendor certain binaries so that our Lambdas aren't too big and they just explode and won't run, because there's an arbitrary limit set on how much data you're allowed to associate with these Lambdas. And other things, right? You also have to know a few of the other kind of side things, right? There's a cold start fee where if you haven't run a Lambda for a sufficient period of time, there's a latency or a spool up time penalty that you pay, right? If AWS has to load your code into a container and they fire it, if they haven't done it for a while, there's not going to be one ready. They're going to have to transfer the storage, boot the OS, get it up and rolling. And there's things that you can do to get it a little faster, but it's something to keep in mind, right? If you need instant reaction whenever this thing is actually needed, think about if Lambda is really the direction you want to go. So yeah, I think that's enough. Let's go through our question. So what's the primary advantage? You pay for the computing time you use with automatic scaling and no server management. I think that's obviously the answer. Let's see. Lambda provides better performance. No, a vCPU is a vCPU regardless of how you run it. Lambda is always cheaper. That's certainly not the case, right? It depends on the workload. It can be cheaper. Lambda functions can run indefinitely. No, 15 minutes. Is that right? Did I get it right? Where's the... 15 minutes, that's what you get. Otherwise, it's going to implode. So we'll keep going. And let's build ourselves a Lambda, shall we? Oh, I'm also going to do this. I just want the sweet XP bonus. All right, deploy Lambda. So Lambdas are just functions, right? And it's a function that usually there's a specific name, usually like handler, or depending on the language, there'll be some syntax that basically you expose a function that can be called outside of your application with a certain thing, and then that gets executed when whenever the trigger for that Lambda is set up. It'll fire the code that's associated with it. It'll do whatever side effects are written within your code, access the database, write a file, send a Slack message. It will do whatever the thing it's supposed to do and store the logs how you configure it. It might be dumping to standard out, it might be right into CloudWatch or Grafana or Datadog, but it's going to do the thing. And you get the return object. So if we want to do it, this thing to do anything with AWS APIs, right, we're going to need permissions. We need to authenticate and authorize, right? Authenticate, Lambda is allowed to do this thing, right? You should be thinking trust policy. And authorized, right? What is the Lambda allowed to do? We want it to be able to write things into CloudWatch for us. So create and deploy a patient ping function role with a role, patient ping Lambda role, by pasting Python code into the AWS console. I am a fan. I can do that. I can paste some good Python. It's super cheap, right? If you're not running this thing for a long time, but there's also horror stories where someone got into a infinite loop where your function called itself over and over and over. And just like, it's nice at times for Lambda to be able to scale up to the need that's currently there. If that scaling is infinite, you're going to have a data center's worth of containers trying to execute your code, which, gets expensive real quick. And so don't be that guy. Be careful when you're referencing and firing other Lambdas that you don't get into a recursive loop. And there are some protections around that these days, so it's a little bit harder to do, but still doable. Don't try. All right. So we got to go to IAM. So let's get logged in here and let's get my role name, this guy. Okay. We'll go to IAM. So I'm going to go to roles, create a role. I'm going to just do my own trust policy because we got bit on that last time. And is it not going to tell me the trust policy? What does it want me to do? It wants AWS service Lambda. All right, so it wants us to do this one. So the AWS service, let's choose Lambda and hopefully we don't get bit by this again. Boom. And it allows Lambda to manage AWS resource, allow Lambda functions to call AWS service. Yes, that's what I want. And then it wants me to add a permission called AWS Lambda Basic. AWS Lambda Basic execution role. Isn't that fun, right? So we just got done talking about exec roles in ECS. That's what it's using to build the container, and a task role, which it uses to operate the container. And helpfully, in Lambda terms, flip the terms, right? Exec is what it uses to run the Lambda code. So we'll have words with Bezos after we're done, see if we can get that changed. But that's helpful. All right, let's keep going. So we got our role, we got our things. That's all good. We want to go to Lambda. So let's go here, go to Lambda, and then we want a function name this for Python 3.4. We're going to create a function. My function, we want Python 3.4. Pretty sure we're not using anything fancy Python-wise, right? There's no like big type or type assertions or new things. So you should be good on just about any Python runtime that you've got. No. And that capacity provider, right? That should be firing some neurons in your brain, hopefully after the ECS section of what that does and how it operates. So it's creating the function for us. And then on permissions, okay, dismiss. Let's go to configuration. Let's go to permissions. Let's go to edit. You see, it did create a default role. I think there probably was an option where I could set that role. But I'm going to update this to patient ping Lambda role. Save that. Okay. Leave all the conditions and create the functions. We did that. Now we want to go to the code and we want to paste in this thing. So code, you can see it's going to give us a little IDE light thing going on here. I think it's VS Code. Yeah, this looks VS Code-ish to me. So we're going to paste this in here if I can type. All right. So we've got a handler and a function here called Lambda handler, and you can see there's two parameters that we're sending into this thing. And what's this thing doing? It's building some context here. We're getting an IP address from this identity that gets passed in. So we're getting this get context, right? We're grabbing the identity. Oh, we're building the request content, so we're getting that from this event. So this gets in, and we're pulling the request context out of that. And then we're pulling the identity out of that context. And then we're pulling the IP address out of that identity. So that could be simplified down, right? We can do it all in one, but this at least is straightforward. So, and we're doing something that, right, we're saying, hey, we got an IP address and it prints this thing out, and then it builds this return type that says, hey, your IP address is X. So this thing is going to be basically like a little ping server that just dumps whatever IP address that you call the function with. All right, that all seems straightforward. So we're going to say update. No. How do I just save it? How do I do it in here? Undeployed changes. Okay, here we are. Deploy. I think that's how I do it. All right, so it's updating the function, and what it's gonna do under the hood is it's just gonna put all these things into a flat zip. If there's dependencies that you've declared in here, those dependencies have to be packaged and included in with your payload. And there's other ways to do Lambdas that aren't through this that are a little bit nicer to deal with. And basically that's gonna be the process. You're gonna have to build your zip file that has the code in it and any kind of modules vendored into that, right? Copied into that folder so that you've got all the code in one place and it doesn't have to go to NPM or cargo or pip, right, to go grab dependencies for this thing. All right, that's all good. Keep the default handler and then click deploy. We've done that, I believe. So let's go over here. See if I got this right. Let's see if my boot dev is still authenticated here. And the -S this time. Boom. All right. So we've got the Lambda deployed, and now we want to test it. Your Lambda function is deployed. Now let's test it. And there's two different paths, right? We're going to do the CLI fashion first, and this is usually what I default to, just because you can do the painful part once, and then it's really easy to repeat CLI commands or script them out or do the thing that you need to do. All right. So we're going to invoke from the CLI, and just so you know, right, the CLI is using Python under the hood, right? There's no magic in the CLI. So if you ever have a question saying, hey, how did they do this? You can go look at the actual invocation of it and do the exact same thing yourself. All right, so the first invocation might take a half a second here, right, to actually fire up, so that's not unexpected. But then the other ones should be really fast because it'll basically keep a container on standby for us after our Lambda has been recently used. Okay, so first I think we're gonna go through the AWS console. So in the console, Lambda functions patient ping. We're gonna open up the test pads and the test tab, and we're gonna fire this event, right, this little piece of JSON at our Lambda, and we'll see what happens. So if I go to test, and I'm gonna do this, my event name is test, and I'm gonna paste this in and format my JSON. That probably is good. All right, and then you fire it, and what do we get? Boom. And it went through and it says your IP address is 8888. Where on earth did it get 8888 from? So you can see it's getting in our code, right? It's getting an event and it's going and saying, hey, go get the source IP address. And if there's not an IP address, it goes and looks at the headers of the packet that comes in. And if it's not there, right, it says unknown. And so this must be getting a source IP property. And so if we look at the payload that it had, you see that it's actually coming in with an identity and a source IP. So it's getting this JSON from our test object, it's loading it in, and it's rendering it back out. So how does in-browser test harness work for your Lambda? It sends an HTTP request to the given payload to a server? No. It sends a mock object, right? It's a simulated call to the function and captures and prints. We're not directly hitting an API to invoke the Lambda function at this point. It just fires it directly against the Lambda itself. So this is the intended answer. All right, API gateway, right? So that begs the question saying, oh, that's great. We can fire this thing. We can go to the CLI or we can go through the GUI, right, to send this JSON payload. But wouldn't it be nice if we could just hit an address, right? On our website, this is going to be the expectation that they're going to run a GET request or a POST or some kind of HTTP verb to interact, and we need to fire the Lambda when it gets that receipt. And that's the function of an API gateway. Basically, it gives you routes and a response and basically a server that can then invoke whichever Lambda function that you need to do in order to respond to that specific request, right? You're getting cat pictures, it grabs it from the database, and then it builds the payload and sends it back to the user, and great. All right, so what does it want us to do? So, and you can also do multiple Lambda functions, and Lambda functions can also call other Lambda functions. So you can build some terrible state machines, terrible Rube Goldberg machines out of Lambda. So be careful, be responsible in how you string these things together. And let's go. So create an API gateway called Patient Ping IP API. So let's go to API gateway. And it's over here. Create an API. And we want to build an HTTP, or I wonder if it should be this one. Yeah, it's definitely this one. And put our name, IPv4 is perfectly fine. Doesn't want any integrations. It wants us to add Lambda as an integration. Is it a private resource? It's up there at the top. I just missed it. That makes more sense. And we can choose our specific thing. We can choose a version, right? So you could have it, depending on the route that you hit on the API gateway itself, it invokes different versions of the Lambda itself. So it seems reasonable. And then we want to add, does it want us to add a route? It wants us to add a default or a top level route for this thing. So boom. Method get, boom. And we want this to fire to that. Okay. And we need to do a stage. Stage is $default for leave auto deploy enabled. So that'll basically, when there's a new version of the Lambda, does the route automatically update. That's what we want. And that seems great. Okie dokie. Navigate to deploy. We need to test it. Deploy stages in the left of the API gateway and click on the stage called default. All right, here's what I want. Deploy stages. Deploy, and then here's the stages. There's default. And then, how does it want us to do it? Click on the stage, copy the invoke URL. There it is. So I just click on that, and the top level route, there it is. And we're hitting this 50.8. We got a real response back instead of just our payload response. And that's great. But this should also bring up some thoughts in your brain, right? Of saying, hey, how did it know? How did it go through this? And does it report back the IP address of the API gateway or otherwise? And if you go dive into the code a little bit, you can see kind of how we're handling that. We're using the X forwarded for to pull the right IP address out of this thing. All right, that's all fine. That's all fine. Let's run our test. Nope, not there so much. Boom. All right, let's keep going. CloudWatch log groups and Lambda logs. So what Lambda logs do automatically, and because there is no server, right, you can't write to a file on the OS of what's running the Lambda by default. And so we've got to store the logs somewhere else where it will persist after the Lambda gets torn down and never exists again. And so that could be S3, that could be like Grafana or some other like external log store. Or, AWS is meant to be called with CloudWatch. And so there's two things, right? One, it's convenient, it's pretty straightforward, and it's pretty cheap, right? If you're not just dumping gobs of information onto it. But then it should also be raising up a thought in your brain of saying, okay, I'm using a lot of AWS primitives that are both convenient, but it also leads to that vendor lock-in that's often really associated with serverless platforms. It's saying, okay, not only do I have to refactor my code, but refactor my logging engine, right? And how I interact and how do I operate with my code. And so the more of these kind of conveniences that you take on, the harder it is to kind of pull the escape hatch or the ejection seat, whatever that's called, and go somewhere else. Take your ball and go home kind of thing with your code. So be aware, but we're going to show you the easy path here and kind of what it offers so you can make kind of that informed decision of what's going to be the right thing for the utility that you're writing. All right, what Lambda logs automatically? It's going to tell you when it starts, right? Because it needs this for billing. It's going to do anything you like print to standard out, right? Print F or console logs, right? Those kind of things that you're sending to the standard out. And for container applications, that's really a common practice to just dump your logs to the standard out. And then at the container level, we kind of handle where do those logs go. And the container itself isn't really aware of how we handle error logs and standard error type messages. The request ID, so we know which one it is, and when it ended, and then the report, right? Saying, okay, based off of the start and the stop, here's how much you paid, right? And then this request ID would also tell you what function was fired as well as like the resources associated with that specific request ID. Because if you go in, you can change the amount of CPU and cores and storage related to your Lambda after the fact. And so you need an ID that tells you exactly what you spent on that invocation. But there's another thing, right? We're generating a lot of information on every single API request, and this might be a lot depending upon the app that you're using. So be cognizant. All right, so what does it want us to do? It wants us to go to CloudWatch. It wants us to go find that log group, and it wants us to find this and scroll through some events and find these things. All right, seems reasonable. So we'll go here, we'll drop that, go to CloudWatch. Within CloudWatch, we're going to find our Lambda's log group. So you go to log and log management. I think it's prefixed. Oh, wait, it's the only log group I've got right now. So you can see it's in here. And you can see, okay, there's one log stream. And so you can do this to say if you've got like 60 versions or invocations, right? You don't want to click on each individual one and search it. So you click the search all just to make it easy. And you can see there's our start, right? Newest or oldest on the top here. There's the end. Did I get that right? Yeah. Here's the init, here's the start, here's the standard out, right? That it spat out on the first call, right? When I ran the invoke and the test call. And then here is the start when I ran it via the API gateway. And from the Lambda's function point of view, whether if I fire this thing in test mode or if I fire this thing from the API gateway, it got an event. And so it's up to whoever wrote the Lambda to be able to say, okay, this is test mode. I want this to act in a different way. Or something inside that payload tells me that this didn't come from the API gateway, and so I should put it in test mode. Just beware when you're invoking your Lambda that you're doing what you're intending on doing and in the environment that you intend to do it, right? You don't have a VPN to protect you of not firing it against the wrong spot. All right, I think that's all we need to do here. So let's go over here, we'll fire this thing. All right, boom. How many more we got? Oh, we're close, we're close. All right, so we built a simple HTTP API with Lambda, so it's hitting posts, but I try to get you thinking about other things that you can do with this, right? We talked about S3 buckets with user uploads, right? If you wanted to send an email that says, hey, thank you for uploading that thing, it's really easy to trigger Lambdas based off of different events. Did you get an email? Is there something added to a SQS queue? Was a new S3 file uploaded, right? All of these things can be triggers for your Lambda to run. Or for me, just for the simple person, to tie it to a cron job so that it fires on the 5 minute or the 1 hour or the 1 day or every Tuesday that you want this report generated and be done with it. So lots of things you can do with it. No servers to maintain, and it will scale up more than probably you will ever need for it to do. Scheduled, right, here's the cron based, right, of firing. Event Bridge is the utility that it uses to basically generate those events. And so you can do that. You can jump onto RDS. All right, I've done this before where we needed to run regular backups of an RDS environment and the snapshots was too large, right? We were running many different clients on a single RDS cluster. And if we did an RDS snapshot, we would have to restore every customer's data in one giant like backup or like temporary database in order to pull any information out of that. And so running a Lambda and doing the Postgres dump on a per DB basis gave us individual backup artifacts that we could use for what we wanted to do. And it made it much easier. Discord, Slackbox, right? It's like, okay, if you want this thing to respond when someone says a message with a keyword, right? Or scrape the messages on a regular basis. This would be an easy way to do that and it's not gonna cost you anything. Probably, right? Till you run to millions of messages or some really long running Lambda. So it makes sense sometimes, really doesn't make sense in other times, and the art and the kind of the thing that makes architecture fun in AWS is being able to choose and know what the right situations are and discards the ones that are only going to give you heartache. And when you hit one of those situations where it's like, hey, this is really the right tool for this situation, sometimes you can make really cool things happen. All right, so running large applications, large dependencies, no, if you bust the limit, right, you can't run it in a Lambda and you're gonna be in for pain. Running a database, no, anything that's 24/7 isn't a good use case for Lambdas. Processing files automatically, yes, 100%, and then another long running, boom. And with that, we are on our final cleanup. So it wants us to come through and delete all these things, use the AWS console search and with the patient ping to come find all these things. So you can go do that. But I think, let's see. Oh, I thought I gave me a nice little command that like ran through and deleted all the things, but let's run through. So we'll go through RDS first, and RDS, in just in case like you're trying to figure out how to delete all your resources, I'll experience your pain with you. I think I've done a good job cleaning up. But for RDS, I went to databases and nothing here. So we're okay on that. Boom. Is there a subnet? Let's come here, subnet groups. There is, so I'll delete that. Checklists are your friends. The security group, doesn't cost anything, and I'm gonna just throw away this account, but where is the security group? I don't think you can see it here. I think you gotta go over to EC2 and do it. Let's go over to EC2. We'll knock out those things and all the security groups that are within it. So let's see if I've got another instance running. No instance is running, that's a good sign. Let's go kill off my launch template. I'm not gonna need to print off any more of these things. Delete template, delete. Case insensitive, that's kind of you. And is there anything else in here? Did we create an AMI? I don't think, yes we did. Let's delete you. Deregister you, delete associated snapshots, boom. Security groups, dump all of these, delete security groups. All right, some of the things it didn't let me delete, patient ping internal and external. These were tied to a load balancer. So let's go kill off those things. Oh, I don't see maybe the target group. What is it tied to? Try just once more. Maybe that just has a, yeah. So inside that security group is a reference to another security group. And so it didn't want you to delete it. And this is the default, will not be deleted, jerks. Or it has some kind of network interface. Oh, it's either default. So you can't delete this one without more steps. Actions, that one's gone already. This guy is going away now. Delete, delete. Beautiful. CloudWatch, let's go over there. The other thing is if you are done with this specific account and you don't care about your free tier, right? So if this is your only free tier, you can't get another one of these usually out of AWS. And so you may want to actually go through and clean this thing up and not just, delete the world or just to throw away the account. So just be aware of it. I don't have any dashboards. Do I have any alarms? And I have no alarms and no dashboards. Beautiful. CloudWatch group. And I'm probably going to have to delete the, oh, it didn't let me do it. Let's go delete our Lambda while we're thinking about it. And the API gateway. Beautiful. And the SNS topic. See, one subscription, pending confirmation. And can I delete? I don't think I can delete it when it is pending, but it also doesn't cost you anything. Let's go to the topics. Wait, go back. In the roles, we'll do IAM last because I'm pretty sure that's gonna have prerequisites. Topics? All right, I've got no topics. I forgot how the subscription works. If there's no topics request confirmation, create subscription, topic. Yeah, see, this thing doesn't exist. Let's see if we can confuse the API by trying to delete something that doesn't exist. No, doesn't exist. All right, that's fine. We got rid of the EC2. Let's go kill the S3 bucket. Remember, you can't delete anything inside the S3 bucket unless all the objects have been removed too. The bucket itself doesn't actually cost anything though, so that's nice. General purpose buckets. And I got no buckets, so I cleaned that up. The Route 53 hosted zone. Oh, I think I cleaned this one up. Nope, I must have. All right. CloudFront. Also be sure that you're in the region that you expect, right? If for some reason this region jumps into one, this is a bad example because CloudFront is a global resource. Okay, this one is disabled, but it doesn't actually let me blow it away until I hit the end of the month. So that's fine, it's not gonna charge me anything. Let's go to kill ECS. I think I did this already, but we're gonna find out. Okay, no task definitions or anything, that's all fine. ECR, I can see that one being forgotten, right? These are the images that you built and stored, the actual Docker images. That's taken care of. The ALB, remember ALBs are stored in EC2, right? For reasons that cannot be explained, cannot be discerned. Let's see if I got any. Let me go back to that dashboard. Is there anything else in here? There's a key pair, I'll go kill that. And those are the two default security groups, I'm pretty sure. Default. Beautiful. One default security group per VPC. So you see that's why I have two defaults, even though that kind of doesn't really make sense, but they both start with O, but they are different IDs. All right, let's go delete my key pair. You do get charged for key pairs. Not much, right? But don't get nickel and dimed. Keep those nickels, keep those dimes, shekels, rubies, what have you, Kate Sauls. I can't delete my own user. Okay, I'm not logged in as my user, so I actually will be able to delete my own user here. One more active key, so it doesn't let you delete it till we deactivate the key. I'll show you how to do that. Goodbye, patient paying admin, and security credentials. And here's the access key. I'm going to say deactivate. You have to deactivate it before it'll let you delete it. And it wants you to grab this, paste that. Thank you. Okay, that's gone. That's gone. CloudWatch group, we already did that. The VPC itself and all the subnets. So I think deleting the VPC will actually grab a lot of the other things like the route tables and subnets that are associated. At least it'll try to do it. If there's a network interface that exists for it, you won't be able to do it. Also going to delete the default one just for fun. We'll see if it lets me. Oh, I see it doesn't let you do multi. So I'll just do the right one. See, let's say, hey, these will also be deleted. The internet gateway, route tables, the subnets. And this is where naming those things in a straightforward manner lets you know what you're doing in a quick way without having to go check 100 other clicks in order to get the thing done. Great, that deleted internet gateway, route table, subnets. That's all good. Internet gateway is gone, route table's gone, the instance is gone, the key pair, I blew that away. Launch template, I'm pretty sure I got rid of. The IAM user, oh, the group doesn't cost anything, I don't care. IAM policies and roles, because you might also want to clean these things up. So jumping to user groups, boom, delete. And note that this doesn't create the users within them, right? It just deletes the group. And so if your user was dependent upon permissions that it got from a group, you be careful. Just a little caution in your life. IAM policies, let's go over there, policies. And I'm gonna flip this to user managed or customer managed and delete these guys. Oh, that's obnoxious. It's gonna make me copy each one of these. Boop, delete, view, delete. Another reason why people like the CLI, right? fewer guardrails, but helps you go fast for people that want to go fast and not have to die by 100 clicks. Okay, boom. And the SSM parameters, that's going to be in SSM, right? If you type that, System Manager, and sometimes it will show up as an option within this top feature, sometimes it doesn't, but System Manager, which does a lot of things, but the most important is the dang configuration parameters. So you got to scroll down here, go to the parameter store, and then here we can destroy these SSM params, which these are, did I already get rid of? No, there, boom, delete, gone. Okay, the Lambda function itself, did I delete it? I might have. And then I also have to make sure I get the API gateway. Yeah, it's right there. Dashboard, Lambda function 0, perfect. Let's go to the API gateway. Note that deleting the Lambda doesn't automatically delete the API gateway, right? Because there's other things that you can use an API gateway to handle for you. It's not necessarily exclusively Lambdas. Beautiful. And CloudWatch log we got. So that is it. Let's see if we pass. Holding with bated breath. Running through the list. Oh, it does check, right? So if you want to pass this, you truly do have to go delete all these things. Oh, I failed something. What did I forget? JQ, unrecognized API security token included. Request was invalid. So I think the credential that I called, run agent get APIs, invalid a character at the beginning. Security token included is in, okay, so that was my issue. So it's this, AWS vault, no session, boom. This is the one. This is the one. This is the one. Hopefully my token doesn't expire while this is chugging along and running its 100 things. And that I don't get rate limited, right? If you run too many things against AWS's API, eventually they will slow roll you so that you can't fire any more things. You also pay for these APIs, right? So don't just run them. So I think we're going to call it at that, right? This isn't relevant to you guys of how I authenticate to my little Linux box. But there are many a small little frustration that you have to fight, right, to make these things work. But AWS doesn't have to be one, right? You can learn the primitives. None of this is rocket science. The documentation is really good. And I'll tell you guys one real trick, right, is that there are user guides published for just about everything out there, right? So if you want to learn AWS Lambdas, look for the PDF user guide is going to be the best use of your time. And so here you go. The developer guide PDF is going to have the exclusive and full content for just about any service, fill in the blank. And it's better than all the online documentation. It gets updated regularly, and this is the same thing that the support techs are using to diagnose and figure out what's going wrong with your service. So know that these PDFs, these user guides exist out there. Know that you are equipped and that none of this is magic. It just takes a little bit of purpose in figuring out what you're deploying, how you're authenticating it, how you're going about deploying it, and then make sure that you clean up, right? Don't waste money. Keep your money. Thanks. My name is Zach Gates, and thanks for watching.